Hello everyone, good morning. First of all, I hope your preparation is going well, and I welcome you on BYJU'S Exam Prep YouTube platform. So in today's session, we'll discuss mock test for electrical engineering. Okay, my name is Asu Jangra, and I'll start with the control system, and then power electronics, and then instrumentation and signal and system. Okay, so I'm taking 4 subjects. Then after Rathi sir will be live, and Rathi sir will take analog electronics, and the analog part will taken by the Rathi sir, and then Astos sir and Rakesh Talleja sir. So there will be a glitch after one and a half hour. There will be a switch of teachers after 1.5 hours, and I hope you will enjoy this session. So good morning everyone, good morning. So please share this session so that maximum student can join this, and they can get benefited from this session. So I have taken almost 18 questions from control system, signal, and power electronics, and instrumentation. Okay, so we'll start with that. So let me complete the introduction part so that everybody can join in the meantime. So this is my introduction. I hope everybody knows me, and I teach almost every subject. Right now we are discussing mock test for EE. There is one mega workshop which is going on 29th of January, which is taken by Rakesh Talleja sir, and this workshop is for GATE 2024 students. So if you have your juniors, or if there is if you have some friend who is preparing for GATE 2024, you can recommend this mega workshop to them, and they can join with Rakesh Talleja sir, and they get benefited from that. Okay. This is, tell me guys, is it fine now? Is it fine now? Is it fine? Tell me. Is it fine? Okay, it's fine now. Thank you. So I was telling you that there will be an exam analysis on 5th and 11th February at 1 p.m. So you have to be live with us, and you can check your answers. We will discuss the entire GATE exam on 5th and 11th. Okay. There is All India Open Mega Mock Test for GATE 2023. You can register for that, and the link is given in the description. Okay, guys, and you can check your preparation. You can check your mistakes. So whatever, you just need to attempt this test. Okay. There is one series which we are going to start is GATE Super 11 series, okay, in which we are taking top 11 questions from every subject for EE, EC, IN, and computer science. So you can also watch this series from 27th of January onwards. Okay, so let's start the session, guys. So this is my first question, and I'm going to start with the control system. So the first question is on your screen. You can see that the state space representation of a system is, this is x dot equal to 0 1 0 minus 3 x plus 1 0 u is my input, y is my output, y is equal to 1 0 x. I need to calculate the transfer function hs or ts equal to, this is hs, let's call it hs equal to ys upon us of the system will be. Now tell me which option is correct. Do it fast, guys. I need to calculate the transfer function hs. Okay, tell me the transfer function of this system. Tell me the transfer function of this system. Let me erase this. Do it fast, guys. Do it fast. So we have a state equation and output equation. I need to calculate the transfer function ys over us. Which option is correct? Do it fast, guys. Let's see how many of you can answer it. Do it fast, everyone. Do it fast. Let's see how many of you can solve it. And don't forget to like this session and subscribe our channel. Okay. Those students who have not subscribed us, please subscribe this channel and like this session. Tell me the correct answer. Tell me the correct answer, guys. This is my question number 1. You have 2-3 minutes. Do it fast, everyone. Do it fast. Tell me which option is correct. Tell me which option is correct. This is 2 marks question. 2 marks question. Do it fast, everyone. Don't make mistake. It's very simple. I think it's time for me to solve this question. Ajay is saying Agra. Late is saying again Agra. Anyone else? Look, you don't need to solve the complete question. You don't need to solve the entire transfer function. Okay? Because there are many students who are applying this C into SI minus A inverse into B plus D. Okay? This is my transfer function TS. So many students are solving like this. They are putting the values and they are calculating this. You don't need to do that. Just be smart. Look at the denominator. The denominator will be the characteristic of the transfer function. So if you can directly calculate the characteristic equation, you will get the information about the answer. Okay? Now, how to calculate the characteristic equation? It's very simple. Characteristic equation is SI minus A determinant equal to 0. Okay? Because you have to think according to the options. Na? So why are you calculating this? It's pure time waste. Don't do it. SI minus A determinant make it equal to 0. So what is SI minus A? So S minus 1, 0 and S plus 3. This is SI minus A. Take the determinant equal to 0. Okay. So now the denominator will be, what is the denominator? S into S plus 3. Our determinant will be S into S plus 3. So this is my denominator. So according to this, option Bombay should be correct. But wait a minute, guys. Wait a minute. Now we get the denominator. We get the denominator by taking the determinant of make it equal to 0. So according to that, B option is correct. But there is a catch. And the catch is, it might be possible that there is a cancellation of pole and zeros. Because this characteristic equation will come in the denominator. Na? Okay. This is the characteristic equation. Tell me, guys, using the characteristic equation, you can calculate the pole. But what about the numerator? It might be possible that there is a cancellation of pole and zeros. So you purely cannot rely on this. Okay. You cannot purely rely on this. Okay. So that's why there might be some confusion with that. But it's sure that this cannot be correct. That's for sure. Okay. This cannot be correct. Moreover, this can be correct, this can be correct, this can be correct. So we have to, we have to do the entire process. But this is important. You cannot ignore this, because sometimes you get the characteristic equation like this, and there is only one option in which this is provided to you, or maybe all the other options do not have this factor. So you can cancel that. You can avoid those options, and you can click only that option which has this part. Now in this question, what I need to do is I need to solve it entirely. Let's try to solve this entirely. So C, what is C? C is 1, 0, and then I have to take SI minus A. SI minus A inverse. SI minus A is this, and if you take SI minus A, then it will be 0, S minus 1 and 0 and S plus 3. I need to take the inverse of this, SI minus A inverse, into B. What is B? B is this, okay? B is 1, 0. Is it fine, guys? And D is 0. C into SI minus A inverse into B plus D. We know that this is the transfer function. And the inverse of this function is very simple. How to calculate the inverse of this system? Tell me, guys. 1, 0 into, it's 2 by 2 matrix. So the inverse of this system will be, take the determinant and write it in the denominator into S plus 3S. Just interchange these values and change the sign. Change the sign of these off diagonal elements, okay? Into 1, 0. So this is my C. This is the inverse of the matrix SI minus A inverse, and into B plus D. Okay. Now you need to calculate that. So first multiply these two matrices. and the denominator is s over s plus 3. Take it out. Take this function out and you just multiply this matrix with this. So you will get s plus 3 0. Okay, and then you have to pre-multiply with this. Okay, if you pre-multiply with this, you will get s plus 3 only. Okay, so that s plus 3 divide by s into s plus 3 you will get. So that s plus 3 will cancel. I told you that there might be pole 0 cancellation. So your answer is 1 by s only. Answer is Agra. Okay, I hope it is clear to everyone. But you cannot avoid this part also, because there might be some other options, no? Because a question can come in exam, and in that question the options are provided such that in the denominator it should be there, or it should be there, or it should be there. If there is a pole 0 cancellation, then it should be 1 by s or 1 by s plus 3 or this entire factor. But there might be some options which do not carry this part or this part or this part. Then you can eliminate those options. So it will give you a small idea. It will give you a basic idea. Okay, this characteristic equation will give you a basic idea. I hope it is clear. Okay, the entire transfer function you can solve it by using this formula. Okay, so I have applied this formula and then I calculated. Answer is Agra. Let's come to the next question, guys. The state transition matrix of the system. I need to calculate the state transition matrix of the system. State transition matrix means phi t. Phi t is e to the power at. We need to calculate e to the power at. Now tell me which options can be correct. Tell me, guys, do it fast. Tell me which options can be correct. Do it fast, guys. Do it fast, everyone. Do it fast. It's important. Do it fast. Let's see how many of you can solve it. Do it fast. Do it fast, everyone. Tell me the answer. Ajay is saying Bombay. Okay. Anyone else? Do it fast, everyone. This is again 2 marks question. 2 marks question. Krishna Veni, Bombay. Anyone else, guys? Tell me. Do it fast. Do it fast. It's a simple question. Do it fast. There are multiple methods of calculating e to the power at. Even you can check with the help of options. With the help of options, you can also check. But if you don't want to go with options, there can be multiple ways. There can be multiple ways. Do it fast, guys. You can solve it using options also by using the properties of state transition matrix. Okay, and the other way is using Laplace, and there is one more method by using Sylvester interpolation method, and there is one more method by diagonalization. So actually there are 4 methods you can apply here to calculate the state transition matrix. Raghuram is also saying Bombay. Okay, tell me, guys, what should be the correct answer? I think it's time to try, because you cannot invest 2 or 3 minutes in this question. It's a very simple question and you can easily solve it. So the first method is Laplace transform. What you can do is, we know that phi t is equal to Laplace inverse of Si minus A inverse. I'll tell you 2-3 methods. Okay, using this you can calculate phi t, and maximum student use this method. Maximum student use this method. Okay, this is very simple method. You can take the Laplace inverse of this matrix Si minus, first write Si minus A, take the inverse, and then take Laplace inverse. You will get the idea. You will get the answers. Okay, no problem with that. But I want to apply a different method, because it will be very tedious to solve for Laplace and then take Laplace inverse by using partial fraction. Okay, so it will be tedious for me. So what I do is I use interpolation method, Sylvester interpolation method. Now what is that method? Maximum students are not aware of that, but let me tell you guys. Can you tell me the eigenvalues of this system? It's an upper triangular matrix. So the eigenvalues is -1 and the second eigenvalues is -2. Okay. Now what I can do is I can write it like this: 1, 1 identity matrix. 1, 1 identity matrix, lambda 1, lambda 2, and A. E to the power lambda 1t, e to the power lambda 2t, e to the power at, and make the determinant equal to 0. Okay. Using this determinant, we can calculate e to the power at. I don't know how many of you know this. This is known as Sylvester interpolation method. Okay, now put the values of lambda 1 and lambda 2 and put these values. So let's put these values, or what you can do is, okay, let's put these values. If I put these values, then what is the value of lambda 1? Lambda 1 came out to be -1. Lambda 2 came out to be -2. Okay. So the matrix will become like this. Okay. Now what you need to do is you need to calculate the determinant and calculate e to the power at. It's very simple. Okay. You don't need to take Laplace inverse, or you don't need to go with the partial fraction. Okay. You don't need to take the inverse of a matrix. Okay. It's easy. I don't know how many of you know this, but if you don't know this, don't try this. Okay. If you know this method, then only you try this. Now let me show it so that you can get the answer. You can calculate the answer using Laplace transform also. I am just giving you the other dimension. I am giving you the other method. So, find the determinant of this. To calculate the determinant of this, 1 into, tell me, 1 into this minus this into this. So it will be -2 e to the power at, -2 e to the power at minus a e to the power -2t. Okay. Then +1 into, expand about this this number now, +1 into e to the power at, minus identity into e to the power -2t. Okay. E to the power at minus identity into e to the power -2t, and then expand about this, plus e to the power -t into a plus 2a, a plus 2 identity, and make it equal to 0. I hope it is clear. Now I need to solve this. You can see that in this expression, we want this e to the power at, and there is also 1 e to the power at. So you can combine them and you can take this on the right side. It is -2 e to the power at, it is +1 e to the power at. So you can take this entire factor on this side. So you will get e to the power at is equal to, so -2 e to the power at and +1 e to the power at. I have taken this factor on the right side. Okay, this is e to the power at. What is left on the left side? Tell me, guys. On the left side, you have -a e to the power -2t, this factor, and then minus identity e to the power -2t. Okay, and then a into e to the power -t. This is a into e to the power -t, a e to the power -t, plus 2 identity into e to the power -t, plus 2 identity e to the power -t. Okay, so this I have to calculate. This I have to calculate, and I'll get e to the power at. How to calculate this? It's very simple. You just multiply a with e to the power t and a with e to the power -2t, or you can take a common. If you take a common, then you will get a into e to the power -t minus e to the power -2t, and then you can take identity common, minus identity into, tell me guys, e to the power -2t minus 2 e to the power -t. I hope it is clear. That is equal to e to the power at. You know this you know the value of identity. You have to take the difference. Okay. Now just calculate this multiplication. What is this multiplication, guys? Every number is multiplied with this factor. So the first number will be, tell me, what is the first number? So I'll get the first number as minus 1 into this. So it will be minus e to the power minus t minus plus e to the power minus 2t. This is my first number, okay? Now the second number multiply with this. So e to the power minus t minus e to the power minus 2t. This will become 0. Minus 2 into this. So you will get minus 2 into e to the power minus t minus e to the power minus 2t. I hope it is clear, okay? Minus identity into this. If you multiply identity with this, you will get e to the power minus 2t minus 2e to the power minus t, then 0, and here you have e to the power minus 2t minus 2e to the power minus t, okay? Now what you can do is, you can take the difference and check which option is correct. If you look at the first element, this minus this you have to do. So this e to the power minus 2 will cancel, okay? And only term which will left is e to the power minus t. This minus this. Only term which will left behind is e to the power minus t. So this option has e to the power minus t, this option has e to the power minus t, this option has e to the power minus. It means using the first difference, A, B, C, all are correct. Let's come to the second part. This minus 0. So we'll get with this term only. And this term is only in B option. So answer is Bombay. Is it fine? Is it fine, guys? Tell me. Answer is Bombay. This is called Sylvester interpolation method. Okay. Using this method also, you can calculate e to the power 80. How many of you are aware with this method? Tell me, guys. How many of you are aware with this method? Sylvester interpolation method. Is there anyone who know this Sylvester interpolation method? Because this is fast. You don't need to take Laplace inverse, or you don't need to take anything. Okay. So tell me, guys, anyone who is aware of this method, Sylvester interpolation method? Tell me, guys. Let me give you one more method. Let me tell you, because you guys love this method, na? So that's why maximum student do it using this method only. Okay. Let me write it again. Sylvester interpolation method. Using Sylvester interpolation method, first you have to calculate eigenvalues. Okay. So there are two distinct eigenvalues. Okay. Now what you can do is, you can take the determinant as 1 1 identity, lambda 1 lambda 2 a e to the power lambda 1 t e to the power lambda 2 t e to the power a t, and make the determinant equal to 0. Okay. So using this, answer is Bombay. Now let's come to the next method. There is one more method. Using the property you can solve. What is the property? We know that e to the power at is equal to phi t. So first property is, if you put t equal to 0, it has to be identity matrix. If you put t equal to 0 on both sides, it has to be identity. So put t equal to 0 and check. Is it becoming identity? No, it's not becoming, because 1 1 0 1. It's not becoming identity matrix. So that A is wrong. Now let's come to B option, C option. C is again wrong. Because if you put t equal to 0, it will not be an identity matrix. Only B is identity, or D might be correct. B and D might be correct. Okay. There are two options which can be correct, either B or either D. Now what you need to do is, you need to apply one more property on this matrix. If two properties are okay, then we'll go with the B. Otherwise, you cannot say that B is correct. Using this property only, you cannot comment that B option is correct. Okay, you cannot do that. What you need to do is, now I need to make one more property. What you can do is, you replace t with minus t, and that will be equal to phi t inverse. Okay, that should be equal to phi t inverse. Now let's see whether this property is applicable on this B part or not, because B or D can be correct, na? Okay, so let's use this property to check. If you put t equal to minus t, it will become e to the power t minus e to the power 2t, 0, and e to the power 2t. Okay, this is my phi of minus t. This is my phi of minus t. Now, what is the inverse of this matrix? Inverse of this matrix has to be equal to this. How to take the inverse? Inverse can be taken directly, but first you calculate the determinant. So the determinant came out to be e to the power minus 3t. So 1 upon e to the power minus 3t into, take the determinant in the denominator, and then it's a 2 by 2 matrix. Interchange these, e to the power minus 2t, e to the power minus t. Interchange these two and change the sign of these off diagonal element. This will be 0, and if you change the sign, it will be e to the power minus 2t minus e to the power minus t. Okay. And then take this e to the power minus 3t inside. If you take this e to the power minus 3t, the first term will be e to the power minus 2t upon e to the power minus 3t. That will be e to the power t. The second term will be e to the power t minus e to the power 2t. I think this is also correct. The third term is 0 and the last term is also e to the power 2t. Okay. So in this B option, you can verify this property also. Is it fine, everyone? I hope it is clear. I hope it is clear. So using the options also and using the property of state transition matrix, you can check the answers. Okay. Answer is Bombay. I hope it is clear to everyone. Let's come to the next question, guys. Let's come to the next question. The next question is, okay, and let me tell you one more way. There is one more method for this. I don't know how many of you are aware of that. E to the power at is equal to s e to the power lambda t s inverse. Okay, there is one more method. I don't know how many of you are aware of that. Okay, this is diagonal method. You have to diagonalize this, and diagonalization is very simple. Since you have distinct eigenvalues, so this will be minus 1, 0, 0, minus 2. Okay, this is my diagonal matrix. Now what you can do is you can take e to the power lambda t. So e to the power lambda t will be equal to e to the power minus t, 0, 0, e to the power minus 2t. Okay, and then you have to pre-multiply with s and post-multiply with s inverse. Now what is this s? S is known as eigenvector matrix. S is known as eigenvector matrix. So using this, you have to calculate eigenvectors also. It's a lengthy method again. It's a lengthy method again because you have to calculate the eigenvector matrix, S matrix, because every lambda has the eigenvector v1 and it has the eigenvector v2. So you have to show these v1 and v2 in 2 columns. That will be my S. And then I have to take S inverse and multiply it. So there are multiple ways to solve this question. Okay, I hope it is clear. You should know all these three or four methods. Let's come to the next question, guys. So the next question is the frequency response. It's not free response. It should be frequency response. The frequency response of GS is plotted in the G omega H omega plane, omega 0 to infinity. Polar plot. He's asking about the polar plot. This is 1 mark question. This is 1 mark question. Tell me, guys, which polar plot is correct? Which polar plot is correct for GS equal to 1 over S into S plus 1, S plus 2? Tell me which polar plot is correct. Do it fast, everyone. Do it fast. Let's see how many of you can solve it. Do it fast, everyone. Tell me which option is correct. I need to plot the polar plot of this function. This is 1 mark question. Do it fast. Let's see how many of you can solve it. Which option is correct? Do it fast, everyone. Do it fast. Krishna Veni, Agra. Okay. Anyone else? Manoj Kumar, Agra. Okay. Banot, Agra. Anyone else? Subodh. Good, good. Everyone, do it fast. It's a simple question. You need to plot the polar plot. Okay, nothing else. Polar plot is required. Do it fast. Pavan, Delhi. Ajay, Agra. Okay. 30 seconds. I'm providing you 30 seconds for that. Do it fast. 30 seconds, not more than that. Do it fast, everyone. Okay, let's see. I think time over. Because this question is not of, you cannot invest 2 to 3 minutes in this question. It's a simple question. What you can do is you replace x with j omega. So it will be j omega into j omega plus 1 into j omega plus 2. Now, what I need to do is, I need to calculate the magnitude and the phase of this. So the phase will be minus 90 minus 10 inverse of omega by 1 minus 10 inverse of omega by 2. This is my phase. and the magnitude will be 1 by omega root of omega square plus 1 into omega square plus 4. Okay. Now you can see that at omega equal to 0, the phase has to be minus 90 and the magnitude has to be infinite. It means the point should be at minus 90 degree axis and it should be infinite distance away from the origin. From the origin, it should be at infinite away. Now minus 90. This axis is at minus 90. Okay. On this axis, if the point lies, then it will make the angle minus 90. It will make the angle minus 90 and the length should be infinite. But it's not necessary. Line can be this. The point can lie on this line at infinite distance away. If the point is infinite distance away, then this angle will again be minus 90. I hope it is clear. If the point is here, the angle is not minus 90. If the point is here, the angle is not minus 90. If the point is here, angle is not minus 90. But if you keep on increasing the distance, the angle will approach minus 90. It means the point is not necessarily on this line. It may be possible that the point lies on this side line, okay, and at infinite distance away. So it's sure that the function should start from the negative side, okay. It is pretty sure from this analysis that the function should start from the negative side, okay. Now only two options are starting from the negative side. You can see that this option is starting on this side and D option is also starting from the same side. The question is, what is this line? At what point this line should start? I mean, the asymptote I need to calculate. The line I need to calculate. Okay, how to calculate this line? As omega tends to 0, what is this line? What is this line? About which line this curve will start? We need to calculate that line. Is it at minus 3 by 4 or at minus 1 by 6? How to calculate that? It's very simple, guys. What you can do is, you can calculate the real and the imaginary part of this function at omega equal to 0. At omega equal to 0, you can calculate the real and the imaginary part of this function. Now, how to calculate the real and the imaginary part of this function? It's simple again. You do the realization process. You do the realization process. So, if I apply the realization process, then what you will get, let me erase this. Then what you will get is 1 upon j omega into, in the denominator, you have 1 plus omega square because you are multiplying with 1 minus j omega in numerator and denominator. Similarly, you are multiplying with 2 minus j omega in the numerator and denominator. So, on realization, you will get 1 plus omega square here and 4 plus omega square here in the denominator. In the numerator, you will have 1 minus j omega into 2 minus j omega. I hope it is clear. Okay, guys. So, you will get, after realization, you will get this. It's not called rationalization. It's called realization. Okay, it's called realization. Remember this point. Now, what you can do is, you can simplify this and calculate the real and the imaginary part as omega tends to 0. So, first let's calculate the real part. The real part is 2 minus omega square and the imaginary part in the numerator is minus 3j omega. I think this is correct. Yes. Divide by j omega into 1 plus omega square into 4 plus omega square. I hope it is clear. Now you can separate the real and the imaginary part. If you separate the real and the imaginary part, the real part will be minus 3 divided by 1 plus omega square into 4 plus omega square, and the imaginary part will be 2 minus omega square divide into j because I have taken this j in the numerator, divide by omega 1 plus omega square and 4 plus omega square. This will be my imaginary part. Okay, now you can see that as you put omega tends to 0, it will become minus j infinity. The imaginary part will become minus j infinity. The imaginary axis, it will go minus j infinity, and the real part, look at the real part, as you put omega equal to 0, it will become minus 3 by 4. So as omega tends to 0, the point will lie on this point. The point will lie here. It means the real part has to be minus 3 by 4 and the imaginary part has to be minus j infinity. So it will lie on this line. Answer is Agra. Okay. Answer is Agra. I hope it is clear. So this was simple question and you can use the polar plot concept to find the answer. I hope it is clear, guys. Let's come to the next question. Let's come to the next question. So the next question is, a pole of a second order system are located as shown. So the location of the poles is shown in the figure. This is J8. If you cannot see it, it's J8. This point is -6. This point is +6. This point is -J8. Okay. So these are the location provided to you. You have to find these locations. There are 4 locations. No, there are 4 poles. Okay. There are 4 poles. Okay. The poles of a second order system are located as shown in the figure. I think there should not be 4 poles. In a second order system, there should be 2 poles only. I don't know why they have shown 4 poles here. But anyway, the damping ratio of the system is given by considering both the possibilities. Okay. You need to consider both the possibilities. Both the possibilities means either you take these 2 poles or these 2 poles. Using these 2 poles, what is the damping ratio? Using these 2 poles, what is the damping ratio? You need to calculate that and tell me the correct answer. Do it fast, guys. Do it fast. You have to take both the possibilities. Both the possibilities means the system is second order, so 2 poles lie in the left half of the S-plane or in the right half of the S-plane. Using that, you need to calculate the damping ratio. Do it fast. Do it fast, everyone. Let's see how many of you can solve it. Tell me which option is correct. Tell me which option is correct. Do it fast, everyone. You have 2 minutes. This is again 1 mark question. So better you put only 1 minute. Okay. This is 1 mark question. Do it fast. You don't have to put extra time for that. It's simple question. Do it fast. Do it fast, everyone. Manoj is saying Delhi, Ajay Calcutta, Krishna Bombay. Anyone else? Tell me, everyone. Tell me the answer. You can invest only 1 minute, not more than that. Okay. I think I should try this. Raghuram is saying Delhi. Okay. The pole location is given to you. The pole locations are given to you. Ajay is saying Agra. Subodh Meena, Delhi. Okay, let's see this. It's a simple question, guys. What I need to do is I need to calculate the damping ratio. So for these 2 pole location, we know the damping ratio. How to calculate the damping ratio? You know, this angle is theta and cos theta will be the damping ratio zeta. Fine? Cos theta will be the damping ratio zeta. Now, what is the damping ratio here? Cos theta will be equal to zeta and that will be equal to base. Base length is 6. Divide by the hypotenuse. Hypotenuse is 6 square plus 8 square and take the root. So 10. So zeta came out to be 0.6. The system is under damped. Okay. The system is under damped. So for these 2 pole location, the system is under damped and the zeta is 0.6. What about these 2 pole? What about these 2 pole location? What about these 2 pole location? For these 2 pole location, zeta came out to be negative. Okay. Because if you know that if the poles are complex and in the right half of the left half of the S-plane, then the zeta will vary from 0 to 1. But then after 1, if the poles are on the right half of the S-plane, then zeta will become negative. Okay, zeta will become negative. Vishal Grow, sir, please provide solution of little bit detail. You are doing awesome, sir. I just want little bit concept behind questions. Okay, I'll try, Vishal. I'll try this. So I told you that we know that if this is the pole location, this is the theta, then you can calculate that cos theta has to be equal to zeta. Zeta is my damping ratio. Now, what we can do is we can calculate this zeta, cos theta is equal to base upon hypotenuse. So it will be 0.6. So on this left hand side of the S-plane, since the poles are on the left of the S-plane, then what you can do is you can say that the zeta varies between 0 and 1 because the system is under damped. in underdamped system, you know that zeta varies from 0 to 1, not equal to. It should not be equal to. Zeta varies between 0 and 1. Okay, this is called underdamped system. Now, if you look at this position, the system is oscillatory. If the system is oscillatory, then zeta will become 0. At this position, zeta is 0. Okay. Now, what will happen after that? After that, zeta will become negative. Okay. After that, zeta will become negative. It means zeta has two possibilities, either 0.6 or minus 0.6. At this point, zeta will be minus 0.6 because the location is similar. It's mirror image. So you can say that zeta is minus 0.6 also. 0.6 according to these two locations and minus 0.6 according to these two locations. Now we need to consider both the possibilities. So according to both the possibilities, which option should be correct? Bombay is correct, I suppose. Okay, because the mode of zeta has to be 0.6. Whether you take these 2 points or these 2 points, only one option is correct now. So if you take both the possibilities, then Bombay should be correct. Tell me everyone, is it clear or not? Have you understood this? Say yes or no. Tell me everyone, have you understood this? So if you look at both the possibilities, then according to both the possibilities, zeta should be 0.6 and minus 0.6. But we require both the possibility that can satisfy this condition also and this condition also. So obviously zeta mode has to be 0.6. Okay. So answer is Bombay. Let's come to the next question, guys. In the next question, the root locus of open loop transfer function. This is the open loop transfer function. The point of intersection of root locus with imaginary axis. I need to calculate what is the intersection of the root locus with the imaginary axis. Okay, I need to calculate that point. It means the frequency of oscillation I need to calculate. What should be the frequency of oscillation? That I should calculate. Okay, I need to calculate the frequency of oscillation. Do it, guys. Do it fast. Let's see how many of you can solve it. What should be the frequency of oscillation? Do it fast. Tell me everyone, what should be the frequency of oscillation? Let's see how many of you can solve it. Do it fast. This is 2 marks question. This is 2 marks question. Do it fast. Do it fast. It's a 2-mark question. Let's see how many of you can solve it. It's a 2-mark question, guys. Do it fast. Is it Agra? Raghuram is saying Agra. Okay. It's a 2-mark question. Do it fast. Why G is negative at first quadrant? Which G is negative? For this question or for this question? Why zeta is negative? Okay, okay. You are saying why zeta is negative for the first quadrant. Okay, let me tell you. Let me tell you UG. Why on this side zeta came out to be negative? Okay, let me tell you. The standard notation of the second order system is K divided by S square plus 2 zeta omega ns plus omega n square. This is the standard notation of a second order system. Now, what is the pole location of this system? If you calculate the pole location will be minus b plus minus root of b square minus 4ac divided by 2a. Okay, these are the pole location. Now if you simplify this, you will get minus zeta omega n plus minus, take this 4 omega n square outside, so that 2 will cancel. You will get omega n root of zeta square minus 1. Is it clear, guys? Now take minus 1 also common from this root, so it will become minus zeta omega n plus minus j root of 1 minus zeta square omega n, obviously. So this is the pole location, guys. This is the pole location. Now let's try to show the pole location. The real part is this. If the zeta is positive, the pole will lie on this side because omega n will always be positive. If omega n is positive and zeta is also positive, then the real part of the pole will be on this side and the imaginary part will be on this side. Okay, so the pole location will be here and here. But if you take zeta as negative, then there is one more negative sign. The real part will become positive and the imaginary part will be plus and minus. So the real part will become positive and the image. I hope it is clear. So if you take zeta negative, then the pole location will go on this side. If you take zeta positive, then the pole location will come on this side. Okay, I hope it is clear. UG, tell me, is it fine? So I told you that on this point zeta can be minus 0.6. Now let's come to this question. Tell me guys, tell me which option is correct for this question. Do it fast. The root locus of open loop transfer function. This is my open loop transfer function. I need to calculate the point of intersection of the root locus with the imaginary axis. Imaginary axis. What is the point of intersection? Tell me everyone. Obviously, he is asking about the frequency of oscillation. If the system becomes oscillatory, then what will be the frequency of oscillation? Because this point represents the frequency. At this point, if the closed loop poles lie on this point, system will become oscillatory. If the system is oscillatory, then what will be the frequency of oscillation? He is asking that. So tell me which option is correct. Tell me which option is correct. Tell me which option is correct. There are two methods to solve it. One is using route. Okay. One is using route. Tell me everyone, it's a 2-mark question. Do it fast. Subodh is saying Delhi. Krishna Veni Delhi. Okay. Manoj Kumar Bombay. Rishabh is also saying Bombay. Okay. Siva Calcutta. Okay, let's see. There are two methods. There are two methods. Which method you are applying? Are you applying the route criteria? Route method? Tell me everyone. Are you applying route method? Are you applying route method? Are you applying the route method? Auxiliary equation method? Okay, using route method you are doing. Okay, let's try this using route method and then I will tell you one more method to solve it. A simpler method. Okay, but first let's come to the route method. Using route method, the characteristic equation. First you have to write the characteristic equation. And the characteristic equation is 1 plus GSHS equal to 0. Okay, so if you put 1 plus GSHS equal to 0, then you will get, and you have to simplify it. So from using this, 1 plus GSHS equal to 0, you will get S into S square plus 4S plus 5 plus K into S plus 5 equal to 0. You will get this. I hope it is clear to everyone. You just add 1 to it and take the LCM and make it equal to 0. So the denominator will go to 0 because it will be cross multiplied with this 0, then it will become 0. Only the numerator will left behind. So this is my characteristic equation. I hope it is clear. Now it will be S cube plus 4S square plus S into 5 plus K plus 5K equal to 0. This is my characteristic equation. Now you can apply route on this. If you apply route on this, it will become S cube and S square. Now this will be 1 and this will be K plus 5. Okay. And then it is 4 and this is 5K. Is it clear guys? Tell me. So I have applied route. I think everyone know about route criteria. Now I need to write S to the power 1. What is the coefficient of S to the power 1? If you look at the coefficient of S to the power 1, then it will be 4 into K plus 5 minus 5K divided by 4. Is it clear guys? And the second term will be 0. So this will be my S to the power 1 and S to the power 0 will be 5K. I hope it is clear. Now to make the system oscillatory, you need auxiliary equation of the second order at least. So this will be auxiliary equation if this becomes 0. If I make this equal to 0, then this will become auxiliary equation. So let's put this equal to 0. If I put this equal to 0, then the entire row will become 0. Na? If entire row becomes 0, then the upper row will act like an auxiliary equation. Is it fine? So you make this entire row equal to 0. If I make this entire row equal to 0, it will become 4k plus 20 minus 5k divided by 4 equal to 0. Is it clear, guys? Tell me. I hope it is clear. 4k plus 20 minus 5k divided by 4 equal to 0. Now you can solve it. You can write it like this. 20 minus k equal to 0. So from here, k will become equal to 20. So I have calculated that k is 20. Is it fine? Now this equation will become auxiliary equation. So what is the auxiliary equation now? Auxiliary equation will become 4s square plus 5k, and k came out to be 20. So 5k is 100 and make it equal to 0. So s square came out to be minus 25. S is equal to plus minus j5. I hope it is clear. So this is the frequency of oscillation. Okay. So the frequency of answer is Bombay. Answer is Calcutta. Answer is Calcutta. Okay. Plus minus j5. Answer is Calcutta. Calcutta option is correct. How to write 5k characteristic equation? How to write 5k characteristic equation? Oh, which 5k? Okay. I have multiplied with this na. Ks plus 5k. Okay. That's why I will get 5k and ks. That s coefficient I have taken common. So it will be 5 plus k. I hope it is clear how I have written this characteristic equation. There is one more method, guys. There is one more method for this question. And what is that method? Let me tell you the other method also. Okay. Let me erase this. Let me erase this. Let me tell you one simpler method. One more simpler method. I think everybody know about polar plot. Okay. We know this is GSHS, and we want to calculate the frequency when the root locus will cross this imaginary axis. That frequency I need to calculate. Okay. And that frequency will always be omega PC. Remember this. Omega PC. When the root locus crosses the imaginary axis, remember, that frequency will become equal to omega PC. Okay. So if using polar plot, if you can calculate omega PC, phase crossover frequency, okay, that frequency will be this frequency. Just remember this. Okay. I'm not going to tell you the proof of this, because proof can be understood only if you are analyzing the polar plot and the root locus. If you are mixing the polar plot and the root locus, then you will get this information. Just remember that this point will always be omega PC. Now, how to calculate omega PC? Using root locus, using polar plot, you can calculate the omega PC. Omega PC is the frequency at which the angle of this quantity become minus 180. So calculate the angle. Put s equal to j omega. Put s equal to j omega. So it will become k j omega plus 5 divided by j omega into, this will become minus omega square plus j 4 omega plus 5. Now I need to calculate the angle of this quantity and make it equal to minus 180 and calculate the frequency. That frequency will be omega PC, and that frequency will be the frequency of oscillation when the root locus will cross this imaginary axis. Okay. Now, what is the angle of this quantity? Angle is minus 90. Due to this quantity, the angle is minus 90. What about this angle? This will be plus 10 inverse of omega by 5. Okay. What is the angle of this quantity, guys? This angle will be 10 inverse, minus 10 inverse of imaginary part upon real part. Real part is 5 minus omega square. Okay. Is it fine? And you have to make it equal to minus 180. Okay. But remember, I have assumed this in first quadrant. That's why the angle of this is this 10 inverse of 4 omega divided by imaginary part by the real part. Since it was in the denominator, that to take it in the numerator, I have to take it negative. I have to assume that the angle of this quantity is in the first quadrant, because I am assuming that this 4 omega and 5 minus omega square, this lie in the first quadrant. It means I am assuming that omega is less than root 5. If omega is less than root 5, then only you can say that it will lie in the first quadrant. Anyway, if omega is greater than root 5, then this real part will be negative and the imaginary part will become positive. The quadrant of this complex number will become second. Okay, then I have to change the angle. I hope it is clear to everyone, but don't worry. Let's assume that this is in the first quadrant and this is the phase of this quantity. Okay, I have calculated the phase and this phase has to be equal to minus 180. I need to calculate the omega at which this phase become minus 180. Now what you can do is you take this minus 90 on this side. If you take this minus 90 on this side, it will become tan inverse of omega by 5 minus tan inverse of 4 omega divided by 5 minus omega square is equal to minus 90. Is it clear, guys? It will become equal to minus 90. Now what you can do is you can calculate the omega from here. You can calculate omega from here. Okay. Is this trick applicable for any kind of system or limitations? No. You can apply this everywhere. Okay. You can apply this everywhere. Now, at least try this and calculate the omega value. Calculate the omega value, and I think you will get the answer as omega equal to root plus my. Okay, let's try this. Let's calculate omega from here. Is it possible to calculate omega? Because there are two possibilities here. Let me tell you guys, there are two possibilities here. This angle you have written is not correct. This angle is applicable only if omega came out to be less than root 5. Why? Because if omega is less than root 5, this will be positive. The real part of this will be positive and the imaginary part will also be positive. It will lie in the first quadrant. But if omega is greater than root 5, what will happen? If omega is greater than root 5, this will become negative and this will become positive. If it is negative, the real part is negative and the imaginary part is positive. It means the quadrant will be second quadrant. If this lie in the second quadrant, then this phase which I have written is not correct. Then what should I write? I should write minus 90 plus tan inverse of omega by 5, tan inverse of omega by 5. And then what is the angle if it is in the second quadrant? If the omega greater than root 5, if the omega is greater than root 5, what should be the angle of this quadrant? This lie in the second quadrant, and in the second quadrant the angle is pi minus tan inverse. So angle is pi minus tan inverse of imaginary part is 4 omega divided by the real part. Real part is, tell me guys, real part is, since this will become negative, na, pi minus omega square. Pi minus omega square will become negative. So negative sign I have taken out. So it will become omega square minus 5. Is it fine, guys? Okay, this will be the angle of the denominator. And if you take it in the numerator, you have to take it negative sign. This has to be minus 180. Okay. So there can be two possibilities, either this or this. This possibility lies if omega is less than root 5. If omega is less than root 5. And this possibility will lie if omega is greater than root 5. Okay. If omega is greater than root 5, you have to write it like this. This minus 180 will cancel from here. Okay. You take this minus 90 on this side. So you will get tan inverse of omega by 5 minus 10 plus tan inverse of 4 omega divided by omega square minus 5 is equal to 90. Okay. This equal to 90. I hope it is clear, guys. I hope it is clear. And using this expression, you can calculate omega. You can calculate omega and you can check your answer. I hope it is clear to everyone. And you can see that if you put omega equal to 5, if you put omega, you can put the options, na? If you put omega equal to 5, it will become 45 plus 45, it will become 90. Answer is Calcutta. Okay. So you have to calculate omega PC, phase crossover frequency. If you get the phase crossover frequency, that will be the answer. Remember this point. Okay. It's a simple case. You just need to calculate omega PC. You can apply the route. If you are not comfortable with this now, if you are not comfortable with this omega PC, then you can apply route, because there are many students who are confused with the angle of this quantity. Why I have written the angle, how I have written the angle. This can be in first quadrant. If this is positive, or it can be in second quadrant. If this is negative, and this is positive, because it can be negative also, na? So the angle of this complex quantity can be in the first quadrant or in the second quadrant. Then accordingly you have to write. So this is the first condition and this is the second condition. Now in the first condition and the second condition, you can put the options. You can put the options and you can calculate omega PC. Don't try to calculate omega from here. Don't try to solve for omega. Okay. Just put the options now, and you can check whether this is satisfied by this or this or this. It will not be satisfied with any options. You can check it. Okay. Even this is satisfied with this. Okay. So that's why answer is Calcutta. I hope it is clear. Now let's come to the next question. This is my next question, and the question is, consider the following system, the magnitude of the sensitivity of overall system with respect to feedback path. I need to calculate the sensitivity of overall system with respect to the feedback path HS. Okay, I need to calculate that, and in that I need to put omega equal to 1. Sir, we can use the trick of third order characteristic equation. Omega n is the coefficient of s to the power n. Okay, you are using third order. Omega n is the coefficient of s to the power coefficient of s term. No. Okay, you are writing that this is okay. Yes, you can do it. But I'm not pretty sure about your method. Please send me on my number so that I can check your method. Okay, my number is 750-8211-721. You can WhatsApp me, okay, and I'll check your method. Okay, I'm not pretty sure which method you are saying. I think you are writing the polynomial equation, and then you are calculating the omega n. Omega n is not the frequency of natural oscillation. Okay, let me tell you guys. Because many students think that the second order equation, if you take the second order transfer function, in the second order transfer function, this distance is omega n, and they are treating this same omega n as this frequency. It's not like that. Okay, I mean that may be wrong. Okay, but let me check which method you are saying. Oh, okay, then I will comment on that. Okay, let's come to this question, guys. So I need to calculate the sensitivity of TS with respect to HS, and I need to put omega equal to 1 radian per second. Now tell me, yes, I have the Telegram channel also. You can WhatsApp me on this number. I'll send you the link, 750-8211-721. Okay. Now tell me about sensitivity, guys. What is the sensitivity of TS with respect to HS? Do it fast. Do it fast, everyone. And this question is of 2 marks. This question is of 2 marks. Do it fast. Let's see how many of you can solve it. You have to apply the sensitivity method. Yeah, there is one more method. There is one more Telegram channel, and I will send you the link. Don't worry. So you can send me on this WhatsApp number. Do it fast, guys. Do it fast. Let's see how many of you can solve it. Tell me what is the correct answer? Yes. 25 divided by s into s plus 2, and this is 1 by 4, 0.25. Okay. Elon. Now you can check it. Do it fast, everyone. Do it fast. It's a simple question. Do it fast. It's a simple question. Do it fast, everyone. Let's solve it. Now first tell me, what is the sensitivity of T with S? How to calculate that? T with H. That is del T by del H into H by T. You have to take the derivative of T with respect to H. Okay? Multiply by HS by TS. What is this TS? TS is GS divided by 1 plus GSHS. Okay? I have to take the derivative of DTS with DHS. Okay? Now it will be 1 plus GSHS. Take the square of that. Take the square of that. In the numerator, you have 1 plus GSHS into the derivative of this. This will be 0 minus GS into the derivative of this term with HS. So you will get GS only. Okay. So you will get minus GS square divided by 1 plus GSS. Please check it, guys. This is the derivative of TS with respect to HS. Now what you can do is, now you multiply this term with HS over TS. So minus GS square into HS divided by 1 plus GSHS into TS. And TS is, what is TS? TS is GS divided by 1 plus GSHS. You can check it, okay? You have square here. Okay, tell me. So this is my DTS by DHS. Whatever this quantity is, in the numerator you multiply with HS, in the denominator you multiply with TS. TS is GS divided by 1 plus GSS. So this 1 power cancel with this, and this 1 power cancel with this. So you will get the answer as minus GSHS divided by 1 plus GSHS. Is it clear, guys? So you'll get this expression. I hope it is clear. Now you put the value of GSHS and put S equal to J omega, and omega is 1. Okay. Now if you put this value minus GSHS, GS is this, HS is 1 by 4. So in the numerator you will have minus of 25 divided by S into S plus 2 into 1 by 4 divided by GS into HS. I have put the value 1 plus GSS. 1 plus GSHS is 25 divided by S into S plus 2 into 1 by 4. I hope it is clear. Now you can simplify this and you will get minus 25 divided by S square plus 2S into 4. S square plus 2S into 4 plus 25. I think you will get this. Okay, guys? You will get this value. Minus 25 divided by, this will cancel with the denominator, no? S square plus 2S into 4 plus 25. I think you will get this. Okay, now what you can do is, sir, this derivation is standard equation or it changes. No. The derivation is simple. You have to take derivative of TS with respect to HS. Okay, you are saying this is a partial derivative. Okay. Yes, it's a partial derivative, but I mean, the function is like this now, so you have to take it with respect to HS. So it will convert into full derivative with respect to HS. Okay, so you can do it like this. So tell me, this is my sensitivity expression. Now in place of S, you put J omega. If you put J omega and then calculate the magnitude of this sensitivity. Okay, so it will be minus 25 divided by 4 into, if you put S equal to J omega, then it will become minus omega square plus 2j omega plus 25. Is it clear, guys? You can write it like this. And omega is 1. You put omega equal to 1. So it will become minus 25. If you put omega equal to 1, you will get minus 4 here plus J8 plus 25. You can see that. Is it fine, guys? Minus 4 plus J8. Omega is 1. No? Plus 25. So you will get minus 25 divided by J8 plus 21. So you can write it like this. Now you can calculate the magnitude of this quantity. Tell me, what is the magnitude, guys? because I need the magnitude, the sensitivity in magnitude it is asked. Okay, so the magnitude of sensitivity, So tell me, what is the magnitude here? Tell me guys, is it 1.11? Answer is Delhi then. If it is 1.11, then answer is Delhi. Okay, so this was a simple question. This was a question based on the sensitivity. Okay, so you just need to apply the formula. The sensitivity of T with H, that is del T by del H into H by T. It's a simple formula, and using that formula you can solve it. Okay, let's come to the next question, guys. This is the question on signal and system. Okay, now it's time for the signal and system. So let's try this question. The Fourier transform of x omega is 1 over 1 plus omega square, and the signal yt is defined as, okay, yt is defined as, this would be y omega, this would be yt. I think this would be yt. Let me check the original file. Let me check the original file so that I can tell you. Okay, in this question, this is yt. This is not y omega. This is yt. This is yt. Yt is equal to this. Then I have to calculate. I have to calculate y, capital Y pi. Capital Y pi. Okay, and y omega. What is y omega? Y omega is the Fourier transform of yt. It is the Fourier transform of yt. And in place of omega, I have put the value pi. I need to calculate y pi, capital Y pi. Okay, x omega is given to you. This is my x omega. Yt is given as this. Now I need to calculate y omega first, and then put omega equal to pi. Okay, this is the question. This is 1 mark question, guys. This is 1 mark question. Do it fast. Do it fast. Let's see how many of you can solve it. It's a very simple question. Do it fast, everyone. Use the properties. Use the properties. Shifting and differentiation property. Do it fast. Let's see how many of you can solve it. Kranti Naga Satish is saying Calcutta. Okay. Let's see. Let's see what the other student says. Do it fast, guys. Everyone. Do it fast. Do it fast. The Fourier transform of xt is x omega. Of xt is x omega. Okay. The Fourier transform of xt is x omega, or x omega is provided to you. The signal yt is defined as yt equal to d square xt minus 2 divided by dt square. Then what is the value of capital Y pi? And capital Y omega is the Fourier transform of yt. Now tell me which option is correct. So which option is correct? It's very simple. We know that yt is equal to, I think we should not devote much time in this question because it's a simple question. You just apply the properties. It is d square x of t minus 2 divided by dt square. Okay. Now what is the Fourier transform of this? If you want to calculate y of omega or y of j omega, tell me guys, what is y of omega? That will be equal to j omega square into, because you are taking double derivative. So if you take single derivative, you have to multiply with j omega. For double derivative, you have to multiply with j omega square into x of omega into e to the power minus j2 omega. I have applied frequency shifting property. For xt, you have Fourier transform as x omega. And if this xt is shifted by 2, then the Fourier transform will look like this. Now you can put the value of x omega. X omega is 1 over 1 by omega square. So it will become minus omega square. This is minus omega square divided by x omega is 1 plus omega square. Okay. And e to the power minus j2 omega. This is my y omega, guys. I have calculated the Fourier transform. Now you put omega equal to pi. It's simple. You put omega equal to pi. If you put omega equal to pi, it will become e to the power minus j2 pi. E to the power minus j2 pi is always 1. Okay, it will become 1. It will become minus pi square over 1 plus pi square. Answer is Delhi. Answer is Delhi. Is it correct? Have I done any mistake? Have I done any? There will be minus sign, no? There will be one minus sign. Is it clear, guys? There is one minus sign, j omega square. J square is minus omega square. You can see that. Is it fine, everyone? So that's why answer is Delhi. D answer is correct. Okay. I hope it is clear. Y omega is given as this. No? Y omega is the Fourier transform. We call it Y omega. So in place of omega, you are putting pi. You are putting pi. Is it clear, guys? I hope it is clear. Let's come to the next. Okay. So answer should be Delhi. Let's come to the next question. Yes. What is the inverse Laplace transform of this? Please calculate the inverse Laplace transform of this function. Do it fast. E to the power minus j pi. Where? E to the power minus j2 pi you will get, na? E to the power minus j2 pi. Omega is pi, na? E to the power minus j2 pi is always 1. Okay, Manoj. It's not e to the power minus j pi. It's e to the power minus j2 pi. Okay, let's come to this question, guys. What is the Laplace inverse of this? What is the inverse Laplace transform of this function? Do it fast. Let's see how many of you can solve it. Do it fast. It's again 2 marks question. It's again 2 marks question. Do it fast. It's a 2 marks question. Do it fast. It's a 2 marks question. Do it fast, everyone. Let's see how many of you can solve it. Ajay is saying Delhi, Raghuram Agra, Ashok Calcutta, Sahil Agra. Okay. Now, do it fast, everyone. It's not that much long question. That much. It's a simple question. You can easily solve it. It's a simple question. Use the properties. Okay. If you use the properties, you can easily solve it. The inverse Laplace transform of x is equal to log of s into s plus 1 divided by s square plus 1. Okay, let's try, because you are putting so much time in this. It's a simple question. What you can do is you take log, na? So if you take the log, then you can write it like this: log s plus log s plus 1 minus log s square plus 1. You can write it like this. Okay. Now take the derivative, dxs by ds. Dxs by ds is 1 by s minus 1 over s plus 1 minus 1 over s square plus 1 into 2s. Okay. You can write it like this. What I have done is I have taken derivative with respect to s. Now what you can do is you can take the Laplace inverse. The Laplace inverse for this function is minus txt, because we know that if you multiply txt, then the Laplace of txt is d by ds of xs with minus sign. Okay. So I have taken this minus sign on this side. So on this side you have txt is equal to Laplace inverse of this is ut minus Laplace inverse of this is e to the power minus tut. Okay. Now what is the Laplace inverse of this? It will be minus 2 cos of tut. Is it fine, guys? Take this ut common and calculate xt. If you calculate xt and take this ut common and take this minus t in the denominator, then which option is correct? Tell me, guys, which option is correct? I think okay, there should be plus here. There should be plus, otherwise you can't solve it. Okay, this is plus. No, actually I made a mistake. This should be plus. Yes, that's correct. So now which option is correct? You can see that answer is Calcutta. Answer is Calcutta. Calcutta answer is correct. Okay. Yes, it should be plus here. Okay, so it should be plus. Is it fine now? Tell me, guys. Is it fine now? Okay, so the answer came out to be Calcutta. Answer came out to be Calcutta. Okay, you can see that this should be plus sign, you know? This should be plus here. Okay, let's come to the next question. Question number 9. Question number 9, do it fast. The Nyquist rate of the signal xt is omega naught. This is the Nyquist rate of the signal. What is the Nyquist rate of xt minus x of t minus 1? And xt into cos of omega naught t. We need to calculate the Nyquist rate of this function and this function respectively. This is 1 mark question. Do it fast, guys. This question is 1 mark. Do it fast. Let's see how many of you can solve it. Do it fast. Yes, I will change the network soon because this Geo network is creating so much problem. Okay, I understand that. Do it fast, guys. Do it fast. Let's see how many of you can solve it. Do it fast, everyone. This is a simple question you can easily solve. Tell me the answer. Everyone, do it fast. It's a simple question. So the Nyquist rate of the signal is xt. And if you are shifting the signal and just subtracting it, what is the Fourier transform of this? The Fourier transform is x omega minus x omega into e to the power minus j omega. Now if you can plot it, it will be x omega into 1 minus e to the power minus j omega. You can plot this. You can plot the magnitude. If you look at the magnitude of this plot now, x omega is, let's say x omega is between this minus omega naught and omega naught. Okay, is it fine? Now you can see that due to shifting, it is not changing. I mean, the magnitude will remain same. Only the phase quantity will change. Only the phase of this quantity will change. The magnitude will remain same. Okay, the magnitude will remain same. So you can say that the Nyquist rate will not change. The Nyquist rate will not change. Okay, so what you can do is the Nyquist rate for the first one is omega naught itself. I think it's clear. For the first case, Nyquist rate is omega naught itself. Nyquist rate will not change because whatever the x of omega is, that will not change. No? I mean, the length will not change. The length will not change. Is it fine? If you take the Laplace, if you take the Fourier transform, it will become like this. And if you plot this Fourier, if you plot the magnitude of this, it will remain same in the same width. Okay, that will not change. But if you are multiplying it with x of cos of omega naught t, then if you take the Fourier transform of this, it will become xt into 1 by 2 e to the power j omega naught t plus e to the power minus j omega naught t. Okay. Now if you take the Laplace transform, you will get x of omega minus omega naught plus 1 by 2 x of omega plus omega naught. I hope it is clear. Okay, it will become like this. It means this x omega is shifted on two sides. This x omega is shifted. One is shifted around omega naught and one is minus omega naught. I hope it is clear. Now I need to calculate. Now I need to calculate the Nyquist rate. Now what is this length, guys? This length has to be omega naught by 2. Okay, omega naught by 2. So now you can see that because the Nyquist rate for this is omega naught now. So this has to be omega naught by 2, omega naught by 2. So now you can see that this is, what is this length? This length is omega naught plus omega naught by 2. And you take the double of this. You take the double of this. Okay. Then what will be the answer, guys? Tell me. The answer will be 3 omega naught, I suppose. Answer is Agra. Is it clear? Okay. Yes, this is actually I made a mistake here. This should be minus omega naught by 2 and omega naught by 2. So the Nyquist, how to calculate the Nyquist rate? Look at the function first. Look at the x of omega and look at the range in which this x omega lies. Let's say x omega lies from this point to this point. So just multiply this range, this outer point, you just multiply with it. So you'll get omega naught. So the Nyquist rate is omega naught for xt. Now, if you are using this operation, then this function, if you plot the magnitude of this function, the magnitude of this function will remain here. The only change will be the phase. Okay, the function will remain at this position itself, and the only change is the magnitude. It means the shifting does not change the bandwidth or the position. Okay, the shifting does not change the position. If the position is not changed, it means the Nyquist rate for this signal will remain as omega naught itself. But if you look at this function, cos of omega naught t, now you can see that xt is multiplied with e to the power j omega naught t plus e to the power minus j omega. Now you can see that the Fourier transform of this function is this. Okay. So now x of omega is shifted at minus omega naught and plus omega naught. Now this is the entire function. Look at this highest frequency term. Whatever the highest frequency term, you just multiply it with 2. So the highest frequency term is omega naught plus omega naught by 2. Okay. Multiply by 2, you will get the Nyquist rate. Is it clear, guys? Is it clear? So you will get 3 omega naught. So answer is Agra. I hope it is clear to everyone. Let's come to the next question. Tell me what is the answer. This is again 1 mark question. Again 1 mark question. Question number 10. Do it fast, everyone. Do it fast. Do it fast. Let's see how many of you can solve it. Which property you are going to apply here? Tell me. Which property you are going to apply here? Which property you are going to apply here? Tell me, everyone. Which property you are going to apply? Yes, duality. Duality. Now, what does duality say? The duality says if xt has Fourier transform of x of omega, then if you put omega in capital X of omega, if you replace this omega with t, then the Fourier transform will be 2 pi x of minus omega. Okay, this is the property, we call it duality property. If xt has Fourier transform x of omega, now in this capital X of omega, if you replace omega with t and further take the Fourier transform, then it will be 2 pi into, in this small xt, you replace t with minus omega. Okay, this is the duality theorem. Using the duality, you can solve it. Now, how to solve? We know this x of t. Now, you can assume this x of t as capital XT. Why? Because if you can replace this t with omega, if you replace this t with omega, you will get 1 over a plus j omega, and this is a familiar term. So that's why I call it capital XT. So that if you replace t with omega, you get the familiar term j omega plus a. Okay, I need to calculate the Fourier transform of xt. To calculate the Fourier transform of xt, calculate the inverse of this. So inverse of this will be, tell me what is the inverse of this function? It will be e to the power minus at ut. So we get x of small x of t. Now we need to find this function now. So that function will be 2 pi into x of minus omega. In place of t, you just put x of minus omega. So it will be e to the power a omega, because in place of t, you just put minus omega. So it will become e to the power a omega into u of minus omega. And u of minus omega is u omega itself. Okay. So it will become 2 pi e to the power a omega u omega. You can write it like this. Okay. I hope it is clear. I hope it is clear. So answer is Calcutta. Answer is Calcutta. Okay. U of minus omega is same as u omega. So whether you write it u of omega, minus omega or u omega, both are correct. Okay. So answer is Calcutta. Is it fine, everyone? It should be Calcutta. Please check it. So it's a simple question. Let's come to the next question, guys. So again, it's a 1 mark question. Again, it's a 1 mark question. Do it fast. Let's see how many of you can solve it. A signal Zn equal to 0, minus 3 and plus 3. I mean, it's a discrete signal. And the Z transform is Gz, okay. it is given that gz can be represented at minus z to the power m gz inverse. Then what is the value of m? I need to calculate the value of m. Do it fast. Let's see how many of you can solve it. Do it fast, everyone. Do it fast. Do it fast. It's a simple question, 1 mark question. It's a very simple question. Do it fast. Kranti is saying 1 or 2, I think. You think, eh? You don't want to solve, you want to think, eh? You're just putting a guess. Don't put any guess. Okay. Try to solve the question. It's a 1 mark question, guys. It's a simple question. Don't forget to like this session. Those students who have not liked it, please like this session. At least make a half century, na? At least make a half century of likes. Do it fast, everyone. Okay, let's try this. I think it's time over. Okay, you cannot put much time in this question. It's a simple question. Zn is given to you. Now, what is Zz? Can you calculate Zz from here? It's a simple. I think Zz can be calculated easily. It will be 3z minus 3z inverse. How I have calculated this Zz? You know that Gz is equal to summation of Zn z to the power minus n from minus infinity to infinity. You can open it. So when n equal to 1, it will become minus 3 and it will become z to the power minus 1. So minus 3z to the power minus 1. When n equal to minus 1, it will become 3, it will become z to the power plus 1. I hope it is clear. And this function lie at only 2 point, 1 and minus 1. So I have written it like this. So Zz, I know that. Now, what is Z inverse? Gz inverse. That will be equal to 3z inverse minus 3z. Okay. In this expression, I replace z with z inverse. So I'll get this. And you can see that this is opposite to that, minus of Zz. You can see that Gz inverse is minus of this. Okay. And it is given that Gz inverse is equal to, take this minus zm on this side, minus z to the power minus m. Oh, wait a minute. I think it's correct. I have taken this minus z to the power m on this side. Can I write like this? Tell me, guys. Can I write like this? I think it's correct. I have taken this on the other side, no? So it will be in the denominator. So I have taken in the numerator and you will get this. So now Gz inverse, according to this relation, Gz inverse has to be equal to this. But we know that Gz inverse has to be minus Gz. It means if you compare these two relations, you can say that minus z to the power minus m has to be equal to minus 1. It means z to the power minus m has to be equal to 1. It means m has to be equal to 0. Okay? M has to be equal to 0. Answer is 0. Is it clear? Answer should be 0. So let's come to the next question, guys. 0. Ajay has given the correct answer. Now let's come to the next question, guys. Now we start with the power electronics. So now we have some questions on power electronics. This is the first question. If the commutation angle of a diode rectifier is mu, commutation angle means overlapping angle. Actually, it's overlapping angle. Then the inductive voltage regulation. Okay, I need to calculate the voltage regulation. Actually, this question is not completed. Not complete. Let me complete this question. Let's say I have this circuit. And there is a source inductance. Okay, the circuit is like this. In this question, he is saying that the overlapping angle of the diode is mu. Okay, overlapping angle of the diode is mu. What I need to do is, I need to calculate the voltage regulation due to Ls. What will be the voltage regulation due to Ls? Tell me, guys. Okay, due to source inductance, there is a overlapping angle of mu. What is the voltage regulation? Tell me guys, what should be the correct answer? Do it fast. Without source inductance, the output average voltage will be equal to 2 Vm by pi. It will be 2 Vm by pi. Okay. Now, with the effect of the source inductance, this voltage will change. Now, can you tell me what will be the new voltage due to the source inductance? What will be the new voltage? Tell me guys. What will be the new voltage? Obviously, it will be decreased. The new voltage will be decreased. Now, I have to calculate that new voltage. Do it fast. Let's see how many of you can solve it. If you remember the formula, then it's well for you. Then it's good for you. But if you don't remember the formula, you have to solve it. You have to analyze it. Okay? You have to analyze it. Do it fast. Let's see how many of you can solve it. Do it fast, everyone. Do it fast. It's a 1 mark question. It's a 1 mark question. Do it fast. Delhi. Payas is saying Delhi. Ritik Delhi. Siva Agra. Okay, let me tell you guys what will happen. If there is no source inductance, this is my supply voltage. The output voltage will be like this. The output voltage will be like this. Okay. But due to the source inductance, what will happen? There will be a 0 voltage during this interval. During this mu interval, there will be a 0 volt. Here also it will be a 0 volt, and here also it will be a 0 volt. Okay. So there will be 0 volt during this interval. So average volt value will reduce. Now the question is, how much average value will reduce? To calculate that average value, what you can do is, this is Vm. The average output voltage will look like this. The output voltage waveform will look like this. Okay. This is mu. This is pi. This is pi plus mu. Okay. Now we need to calculate the average value of this. What is the average value of this? Period is pi. So 1 upon pi integration from mu to pi Vm sin omega t d omega t. This is the average value. Now we can calculate that this will be Vm by pi, and the integration of sine is minus cos, upper limit minus lower limit. It will become 1 plus cos mu. Okay. So this is the new average output voltage. So we get the new average output voltage. The previous average voltage was this. Now we need to calculate the voltage regulation. So 2 Vm by pi minus Vm by pi into 1 plus cos mu divided by 2 Vm by pi. I hope it is clear. Okay. Now take this 2 Vm by pi common. So if you take 2 Vm by pi common, it will be 1 minus 1 by 2 into 1 plus cos mu. Okay. You will get this value. I have taken 2 Vm by pi common from this. So this will cancel. And in the numerator, you will left with this. So if you simplify it, you will get 1 by 2 into 1 minus cos mu. This will be my answer. Answer is Delhi. Okay. So D is the correct option. It's easy peasy. So this was 1 mark question. Let's come to the next question, guys. Consider the chopper circuit shown in the figure. We have a chopper circuit in the figure. Okay. The chopper operates at 50% duty cycle. Okay. Now the load current remain constant at 10 ampere. So the load current remain constant at 10 ampere. Okay. This remain constant at 10 ampere. Assuming that the input voltage is 200 volt DC. Okay. This is 200 volt DC. And the devices are ideal. Turn of time available for the thyristor Tm. This thyristor turn of time. This is 2 microfarad. This capacitor is 2 microfarad. And this inductor is 1 millihenry. Okay. This inductor is 1 millihenry. I need to calculate the circuit turn of time for this thyristor. Do it fast, guys. This is 2 marks question. Many students remember the formula for this. Okay. Many students remember the formula for this this diagram. But I don't recommend you to remember the formula. You can use the wave shape concept, and using that concept you can solve it. Do it. It's a 2 mark question. Tell me what should be the correct answer. Do it fast, everyone. Do it fast. Let's see how many of you can solve it. Do it fast. It's a 2 mark question. सर effective T on find करना है. No. Circuit turn of time. The circuit turn of time for the thyristor Tm, that you need to find. Okay, the circuit turn of time for Tm. Okay, now tell me everyone, what should be the correct answer for this question? Tell me what should be the correct answer for this question. Do it fast. I think it's a simple question. Let's assume that the capacitor is initially charged with this voltage, 200 volt. So if you are going to fire this, what will happen, guys? There will be two current. One is 10 ampere and there is one more current which is a sinusoidal current. So after pi root LC time, this capacitor will oppositely charged. After pi root LC, this capacitor will charge with the opposite polarity. Okay, and at 200 volt. And then this path will stop conduction. So this path will conduct only for pi root LC time. After pi root LC, this capacitor will charge with the opposite polarity and then it will stop conduction and this path will keep on conducting. So now, once this capacitor is charged with the opposite polarity, what will happen, guys? Then after that, this current will go zero and this path is not working anymore. Now this 10 ampere will go from this thyristor only. Now what will happen? If you are going to fire it, if you are going to fire this thyristor now, auxiliary thyristor, then as soon as you fire it, what will happen, guys? This 200 volt will come in anti-parallel with this. I mean, it will reverse bias the main thyristor. You can see that this positive will appear here and the negative sign will appear here. So this thyristor will get turned off. If this thyristor get turned off, then this entire current 10 ampere will pass through this capacitor. Okay, it will pass through the capacitor. So you can see that the capacitor is oppositely charged. The capacitor is oppositely charged at minus 200 volt. And this thyristor will also get reverse biased with this voltage, with this capacitor voltage. This thyristor will also get reverse biased. Now, since the constant current is going through the capacitor, the capacitor will charge linearly. So it will take some time to come to zero level, and after that it will become positive. As soon as this capacitor voltage become positive, this thyristor will get under forward blocking mode. But during this interval, when the capacitor voltage was negative, the voltage across the thyristor will also remain negative, and we call this time as circuit turn of time, TC. Is it fine now? Now you can calculate this TC time. How to calculate it? You just write the equation for the capacitor voltage. So the capacitor initial voltage is minus 200 plus 1 by C integration. So the current coming is 10 ampere, 10 dt, 0 to t. I hope it is clear. So it will be minus 200 plus 10 by Ct, make it equal to 0. Because I need to make this voltage equal to 0. This is the capacitor voltage, VCT, okay? The initial voltage of the capacitor is opposite, negative. We call it negative voltage. And the same voltage will appear across the thyristor. So you can say that the voltage across thyristor is also negative. As soon as the capacitor is charging, the voltage across the thyristor will also be becoming positive. At this instant, after this instant, this voltage will become positive. The thyristor will be under forward blocking mode. But during this interval, thyristor will remain reverse biased. After switching it off, once it is off, then during this interval it will remain reverse biased. We call it circuit turn of time, and that time can be calculated by taking this VCT and make it equal to 0 and calculate the time in which this voltage is becoming 0. That time will be equal to 200 into C by 10. This is my circuit turn of time, 20C. And what is the value of C? C is 2 microfarad. So you just multiply with 2, it will become 40 microfarad. Okay, so the answer is 40 microfarad. Is it clear, guys? I think it's easy peasy. Answer is 40 microfarad. This was 2 marks question. I hope it is clear to everyone. Don't try to cram any formula, just try to understand the concept. Okay, but if you know the formula, then again it will be easy for you, but will not help you. Okay, I hope it is clear. Okay, guys, so I told you that sometimes they replace this load with a resistor. If they replace this load with a resistor, then the formula will not help you. Okay, then the formula will not help you. In this case, you can remember the formula because this current is constant at 10 ampere. Let's come to the next question. Question number 14. Now you can see that In middle for few seconds buffering, sir. Oh, I repeated, na? I repeated that statement again. So tell me, what should be the answer for this question? A single phase full bridge converter with a freewheeling diode feed an inductive load. So we have a full bridge converter. Okay, we have a converter with a freewheeling diode. Resistance is 15 ohms, an ideal 230 volt. So this is RMS value is 230 volt, 50 hertz. Okay. For the firing angle delay of 60 degree, if alpha is given as 60 degree, the input power factor will be, what is the input power factor? I need to calculate the input power factor. Tell me guys, what is the input power factor? We need to calculate the input power factor. There is a buffering, guys. There is a buffering which is. Tell me guys, is it fine now? Oh. Is it fine now? Tell me everyone. Please try to solve this question. It's saying that this current remain constant, and the resistance is 15.53. Firing angle is 60 degree. What I need to do is, I need to calculate the input power factor. What should be the input power factor? Do it fast. It's a 2-mark question. It's a 2-mark question. I need to calculate this. Do it fast, everyone. Do it fast. Is it fine now? Tell me everyone, is it fine? Is it fine? Tell me everyone. I think it is fine now. Okay. Okay. So let's try this question, guys. Let's try this question. In this question, look, this is my source voltage. If there is no freewheeling diode and alpha is 60 degree, then the output voltage will look like this. Then the output voltage will look like this. Output voltage will look like this. Okay, this will be my output voltage. This is alpha, this is pi plus alpha. This point is 2 pi. Okay, so this will be my wave shape of the output voltage if there is no source inductance, if there is no freewheeling diode. Okay, during this interval T1 T2 will conduct, and then T3 T4 will conduct, and then T1 T2 will conduct. Okay, so now what you can do is, since there is a freewheeling diode, in case of the presence of freewheeling diode, remember one point, and the point is this will not conduct. Okay, I mean the voltage cannot be negative. Okay, the voltage cannot be negative. It means the output voltage has to be like this. Output voltage has to be like this. From alpha to pi, the voltage say will go like this, and then from pi to pi plus alpha it will be 0, and then pi plus alpha to 2 pi, the output voltage will be like this, and then 2 pi to 2 pi plus alpha, it will, so the voltage shape will look like this. T1 T2 and then freewheeling diode, then T1 T2 freewheeling diode, T1 T2. I hope it is clear. Okay, so this will be my output voltage. This will be my output voltage. Now what will happen is, if you get the output voltage and if you know the interval during which the thyristors are conducting, what about the current? What about the source current? If you look at the source current, then the source current from alpha to pi, T1, T2 is conducting. It means the source current will be positive. Okay, the source current will be positive and it will flow through T1, T2. So this I naught current will flow through the source and will be positive. Now from pi to pi plus alpha, prevailing diode is conducting, no source is involved. So now the source current will be 0. From pi plus alpha to 2 pi, T3, T4 are conducting. If T3, T4 are conducting, then the current will be negative. Is it fine, guys? And then again, from 2 pi to 2 pi plus alpha, it is positive again. I hope it is clear. Okay, I hope it is clear. Now what I need to do is, I need to calculate the input power factor. How to calculate the input power factor? How to calculate the input? It's very simple. If you know how much active power is supplied by the source, divide by the apparent power supplied by the source. How to calculate the active power supplied by the source? The power absorbed by the resistance is called the active power supplied by the source. How much power is absorbed by the resistor? To calculate the power absorbed by the resistor, we need to calculate this I naught. Let's calculate I naught. How to calculate I naught? This is my output voltage wave shape. Now what is the average output voltage? To calculate the average output voltage, we know that the period is pi. So 1 upon pi, from alpha to pi, Vm sin omega t. This is my average output voltage. And the value came out to be Vm by pi. Integration of sine is minus cos, upper limit minus lower limit is 1 plus cos alpha. This is my average output voltage. Vm by pi cos 1 plus alpha. Okay, so this is my average output voltage. Divide by the resistance value, you will get the average output current. Now can you tell me the average output current value? What is this I naught? So I naught came out to be Vm by pi. Vm is 230 root 2. 230 root 2 divided by pi into R. R is 15.53 into 1 plus cos alpha, cos 60. Now tell me the average value of this output current, I naught. What is the average value of this output current, guys? Tell me. What is the average value of this output current? Do it fast, everyone. Tell me what is the average value of this output current? What is the average value of this output current? Do it fast, everyone. What is the average value? Cos 60 is half. So it will become 3 by 2. Okay. Now you just multiply it with this quantity and calculate the average out. It came out to be 10 ampere. Perfect. It came out to be 10 ampere. Okay. So this average output current is 10 ampere. And we know that this will remain constant at this value. Average output current remain constant at this value. Okay. Now what we can do is, we can calculate the active power supplied to this resistance. That will be equal to 10 square into 15.53. Because this remains constant. If it remains constant, then the RMS value of this current will also be at 10 value and the average value will also be at 10 value. Because it is ripple free. I am assuming that this current is ripple free. So it is constant. If it is constant, the RMS value will also be 10 ampere. Now calculate the power absorbed by this. That is IRMS square, which is 10 square into R. 10 square is 100, okay, into R. So the power absorbed will be 1553 watt. Okay, 1553 watt is the power absorbed by the resistance, and that same power is supplied by the source. So you can say that the active power supplied by the source is this. Now divide by the apparent power. I need to calculate the apparent power. How to calculate the apparent power? Apparent power is RMS value of the source into RMS value of the source current. 100 by pi into, what is this difference? Pi minus alpha. That is 5 pi by 6. 5 pi by 3, I suppose. Okay, because alpha is pi by 3, na? So pi minus pi by 3 is 2 pi by 3. 2 pi by 3. Okay, and take the root of this. Is it fine, guys? So we have calculated the RMS value of current. That is 10 root 2 by 3. This is my RMS current. 10 root 2 by 3. I hope it is clear. Okay. So you can see that the RMS value of the current, supply current, is 10 root 2 by 3 and the RMS value is 230. So the apparent power supplied by the source, is the product of this RMS voltage and this RMS current. This will be my apparent power, and active power is this 1553. Now you can calculate the ratio. To calculate the input power factor, you have to calculate the ratio. So the ratio will be 1553, that is active power, divided by the apparent power. And the apparent power is 230 into RMS current of the supply 10 root 2 by 3. Can you calculate this ratio, guys? Can you tell me this ratio? This is my power factor, input power factor. Do it fast. It is 0.826. So 0.826, answer is Calcutta. Is it fine? So now you can calculate. So it's a simple idea that I have applied. I have applied the simple idea, and the simple idea is power factor equal to active divided by apparent power. So I have calculated the apparent power supplied from the source and the active power supplied from the source. How I have calculated the active power? Active power is the power absorbed by the resistor. So on the output side, the power absorbed by the resistor is I RMS square into R. This is the power absorbed by the resistor. The same power is supplied by the source. So using this method, I have calculated the active power of the source divided by the apparent power. Apparent power is RMS value of this volt into RMS value of the source current. Okay. Sir, in the question, if resistance is not mentioned, can you put V naught into I naught if load is highly inductive? Yes. Then you can do it, because if the current remain constant, then the average value is responsible for power delivery. Okay. If resistance is not given, let's say, then the problem, and I naught is provided to you, then you can even calculate the resistance also, because you know the average value of the output voltage, you know the average value of output divided by the average current, you will get the resistance value. Okay, no problem with that. Praneeth, I hope you understood it. Or directly you can multiply V naught and I naught, because if I naught is constant, it means I naught is fixed DC. So the power absorbed by the load will be using the DC component of the voltage. It means the average component of the voltage, and the average component of the voltage is this voltage. So this voltage multiplied by I naught will be the active power. You can do it. You can calculate like this. No problem. No problem in this. Okay. So I hope you understood it. How to calculate the input power factor. Let's come to the next case. In the next question, a single phase bridge inverter shown in the figure. We have a bridge inverter. You can see that there are anti-parallel diodes. So it's a single phase bridge inverter shown in the figure, has ideal transformer. It's an ideal transformer with the primary turns N1 equal to 10. This N1 is 10. It is given to you. Okay. For obtaining fundamental frequency output voltage of 240 volt. Here the fundamental frequency output voltage is 240 volt. The number of secondary turn N2 in the transformer should be. Okay. Take pi equal to 3. Why you need to take pi? Just do it. Remove it. Pi equal to 3. Why should I take pi equal to 3? Pi is always 3.14. Okay. But I think the answer will match only if you take pi equal to 3. Okay. That's why you have to take pi equal to 3. Otherwise, there is no point of assuming pi equal to 3. Okay. But anyway, let's solve it. Do it fast. Do it fast, guys. It's a 2-mark question again. It's a 2-mark question. Do it fast. Let's see how many of you can solve it. Do it fast. It's a 2-mark question. Let's see how many of you can solve it. Do it fast. Do it fast. And don't forget to like this session. At least make a half century of likes. Make half century of likes. Do it fast, everyone. Make half century of likes. Okay, do it fast. It's a simple question. It's a simple and very good question. This transformer is ideal. This transformer is ideal. Do it fast, everyone. Is it Calcutta? Okay. Anyone else? Praneeth, Calcutta. Okay. Anyone else? Do it fast, everyone. It's a simple question. It's a very simple question. I think I should try now. Okay. Look at this. First, plot this voltage, no? V naught T. We know that it's a full bridge inverter, single phase bridge, full bridge inverter is there. So the output voltage will be square wave. It will be plus 12 and minus 12. Output voltage will be square wave. If I am assuming this switch is to be ideal, then this will be my output voltage. Or you can say This voltage will be the input of this transformer. Now, what is this voltage on the secondary side? If this is the voltage on the primary side, what will be the voltage on the secondary side? On the secondary side, you just multiply this voltage with N2 by N1. N1 is 10. So N2 by 10. So if you multiply this with N2 by 10, you will get the voltage on the secondary side. And the fundamental component of this voltage, is provided to you. The fundamental component of this voltage is 4 into 12 N2 by 10 upon pi. This is the peak value of the fundamental, 4A upon N pi. A is this height, na? So 4A upon pi is the peak value of the fundamental component, and it is given as obtaining the fundamental frequency output voltage of 240 volt. 240 root 2. Why it's root 2? Because 240 is the RMS voltage. Because if nothing is mentioned, so we have to take it as RMS. So this 240 is the RMS voltage. Okay. So now you can calculate the value of N2. Okay. So now N2 will be equal to, tell me the value of N2, guys. N2 will be equal to 240 root 2 into 10 divided by into pi divided by 48. Is it fine? Tell me, guys. Now you take this pi as 3. If you take pi as 3, then this will be cancelled with 16. Okay, and then further cancel this. So this will be cancelled with 4. And this will be cancelled with 15. So it's 150 root 2. Answer is Calcutta. 150 root 2. Is it fine, guys? Answer is Calcutta. So the number of turns on the secondary side N2 will be 150 root 2. Obviously, number of turn cannot be in fraction, but options are provided to you. That's why we will select among the options. So answer is Calcutta. Okay. So let's come to the next question, guys. This was simple question. Let's come to the next question. In this question, in the chopper circuit shown in the figure, so this is the buck boost converter. Okay, or you can say it's a chopper circuit. So a chopper circuit shown in the figure, the switch S is switched at 10 kilohertz. So the frequency is 10 kilohertz. The frequency of this switch is 10 kilohertz. The circuit is operated in steady state and the inductor current is at boundary of the continuous conduction. It is at the boundary. So the current is just continuous. Okay. In an IGBT, so we have the switch is IGBT, let's say. In an IGBT, a conduction drop of 0.5 volt is used in place of switch. Okay. If an IGBT with a conduction drop of 0.5 volt is used in place of switch, okay, he's saying that in place of the switch, if I am using the IGBT, which give you a conduction drop of 0.5 volt, whenever it is conducting, the voltage drop of 0.5 volt is happening across this IGBT, the approximate conduction loss in the switch will be. What will be the conduction loss in the switch? We need to calculate that conduction loss. Now, first, let's plot the voltage across the inductor. VLT. Tell me, guys, what should be the answer? Let's wait for some time. Let me give you 2-3 minutes. Do it fast. Let's see how many of you can solve it. Do it fast. Do it fast. At least you have 2 minutes. Do it fast, everyone. Only 2 questions are left. So after that we can solve for 17 and 18, and then Rathi sir will continue. Okay. After that Rathi sir will continue. So only after that only 2 questions are left from instrumentation. Okay. So do it fast. Do it fast, everyone. Do it fast. Let's see how many of you can solve it. It's a simple question. He's saying whenever the IGBT is conducting, then the conduction loss is 0.5 volt. Now we need to calculate the power loss in the switch. What will be the power loss in the switch? Do it fast, everyone. Do it fast. What will be the power loss? First, you have to plot the current of the IGBT. If you know the current of the IGBT, during the conduction, the voltage across this IGBT is 0.5 volt. Then calculate the power loss in this IGBT. It's a simple question. The basic idea is again very simple. So do it, guys, do it fast. To plot the current, First, you need to plot the inductor current. How to plot the inductor current? First, you need to plot the VLT, the voltage across the inductor. Let me try this. Let me solve it for you. Let me solve it for you so that it can be solved in less time and you'll understand it. So VLT, during this T on time, when the switch is on, you can see that the voltage across the inductor is 100 volt. It will be 100 volt. Fine. It will be 100 volt. And during the off time, this circuit will conduct. Whatever the current has developed, this circuit will conduct. And you can see that the voltage across the inductor will minus 400 because it will come in parallel. So the voltage across inductor will be minus 400. Is it fine? It will be minus 400. I hope it is clear. Okay. So this is the voltage of inductor. Now the current of inductor is like this. It's just continuous. So current will be like this. It will come to zero. It's just at the boundary. So the current is continuous. So the current will look like this. Now the problem is, what is this peak value of the current? We need to calculate that. For that, I need to calculate this time. This time is dt. Now how to calculate the duty ratio? Tell me guys, how to calculate the duty ratio? We know that the average voltage across inductor has to be 0 under steady state. So this area and this area has to be 0. This is dt, this is t. So tell me, what is this area? This area is 100 dt. And what is this area? Minus 400 into 1 minus dt. Okay, this length is 1 minus dt. And make it equal to 0. So that t I have taken common and it will go to 0. And this will be 100d minus 400 plus 400d equal to 0. You can calculate the d value. D value came out to be 0.8. Is it clear guys? So d came out to be 0.8. You can see that. D came out to be 0.8. Duty ratio is 0.8. So this point is 0.8t. This time is 0.8t. And time period is given as t is equal to 1 by f. 10 into 10 raised to power 3. Okay. So this came out to be 10 raised to power minus 4 second. Fine. So I know the time period. I know the d. So now you can calculate this IL peak. This IL peak will be equal to 1 by L. Initial current is 0. 1 by L. L is 100 microfarad. 100 into 10 raised to power minus 6. 1 by L integration. Voltage across inductor is 100 and 0 to dt. Okay. You just integrate it and you will get the IL peak. This peak current. Now what is the IL peak value? So it will be equal to 1 upon. This will be 10 raised to power minus 4 into 100. 100 I have taken common into dt. D is 0.8. D is 0.8 into t, time period. And the time period is 10 raised to power minus 4. Okay. Into 10 raised to power minus 4. So minus 4 is cancelled. So you will get 80 ampere. This height is 80 ampere. Okay. So we can find easily that this height is 80 ampere. Okay. Now I need to plot this IGBT current, the switch current. The switch current will be, whenever the switch is on, during that period only, the switch will conduct. So you can say that from 0 to t on, the switch current is like this. And it will be up to 80 ampere. And then from t on to t, the switch current will be 0. And then again, it will be like this. I hope it is clear. This is my switch current. And the voltage across the switch is 0.5. 0.5 volt during this interval. During this interval, voltage is 0.5 and current is this. So what I can do is, I can multiply this voltage and this current. Under one period, if you look at this, under one period, only during this interval, the voltage is 0.5. During this interval, the voltage is 0 because the IGBT is not conducting. During the conduction, this will give you 0.5 volt drop. So what is the power loss inside that? Instantaneous power. First calculate the instantaneous power, PT. And the PT will be equal to VT into IT. Now what is the equation for this current? The equation for this current is, what is the slope? Slope is 80 upon dt into t. Okay. This is the equation for this. What is the value of dt? What is the value of dt? Okay, we will put it later. So the equation for this line is 80 upon dt into t. This is the equation for this line and the voltage is 0.5. So you just multiply it. So the power PT will be equal to the instantaneous power absorbed by this IGBT. the instantaneous power absorbed by this IGBT will be equal to voltage into the current. And the voltage is 0.5, current is this. So it will be 40 upon dt into T, okay? This is the instantaneous power, 40 upon dt into T. Now I need to calculate the average power loss. So the average power loss is, take the area of this, but this PT exists between 0 and dt time only. Take the area, divide by the time period is T. So the average power loss, PT average, let me write it here. PT average will be equal to 1 by T, integrate from 0 to dt, and the instantaneous power is 40 upon dt into T dt, okay? This way you can calculate the average power loss, okay? That will be equal to 40 upon dt. And in the denominator you have T outside. I have taken this 40 upon dt outside, so it will be T square by 2. If you put the limit, you will get dt square upon 2. Is it fine? 1 dt is cancelled. So you will get 40 into dt divided by 2t. T is cancelled. And this will become 20. And in place of d, you have 0.8. So 20 into 0.8. So you will get 16. You will get 16 watt. Is it fine, guys? You will get 16. Answer is Bombay. Okay? I think it's clear. Is it clear, guys? Tell me. Answer is Bombay. Let me repeat this. Let me repeat this question because this question was very good. So in this question, whenever the IGBT was conducting, the voltage drop was 0.5 volt. And the current shape is like this. The current shape is like this. During the conduction time, the switch current, the IGBT current, whatever the inductor current is, same will be the switch current. Because we know that whenever the IGBT is on, the diode will be turned off and the current was flowing like this. So whatever the inductor current is, the same will be the switch current. So during this T on time, this will be my switch current, and we have calculated the equation for this current. And the equation for this current is the slope. The slope is this height minus this height divided by this time. So it will be 80 upon dt. This is the slope into T. So this is the equation for this current. So this is my switch current. In one period, this is the switch current only during 0 to T on time. Now, whatever the switch current multiply by the voltage drop across the switch, that is 0.5. That will be the instantaneous power, PT. PT is VT into IT, na? So VT is 0.5 and IT is this, 80 by dt. So I multiply this and I'll get PT as this. Now I need to calculate the average power. This is my instantaneous power. To calculate the average power, what you are doing is, what you need to do is, you need to take the area under one period, area under one period. But this product exists for 0 to dt, 0 to dt only. That's why I need to integrate it from 0 to dt, okay? That will be the area of this. Divide by the time period, you will get the average power. It came out to be 16 watt. I hope it is clear. Okay? So, it's easy peasy. Answer is 16 watt. Let's come to the next question, guys. So, this question came from instrumentation. Do it fast. The simultaneous application of signal xt and yt to the horizontal and vertical plates respectively of an oscilloscope produce a vertical figure of 8. Okay. So this is the shape which is produced on the oscilloscope. Okay. A simultaneous application of the signal xt and yt to the horizontal and the vertical plate respectively of an oscilloscope produce a vertical figure of 8. Okay. If P and Q are constant and xt equal to this is my P sine of 40 plus 30, then yt will be equal to, tell me, what is the yt? Tell me, guys, what is yt? Only the frequency you need to check. Only the frequency you need to check. Tell me, guys, only the frequency you need to check. What should be the correct answer? And the phase difference, obviously. Do it fast. Let's see how many of you can solve it. This is instrumentation question, guys. Do it fast. Let me check the original file also. Please tell me which should be the correct answer. Okay, xt is given to you, know, yt I need to calculate. Yt I need to calculate. Just calculate the frequency, because only changes the frequency. Only changes frequency. Okay. the signal which is provided on the x-axis on the horizontal plate is this. Okay, it has the frequency 4. Now, what is the frequency of the signal which is provided on the vertical plate, y-axis? Tell me, guys, how to calculate the frequency? How to calculate the frequency on YT? The signal which is provided on the vertical plate. Tell me, guys, what should be the frequency? You can use the Lessage's pattern and the tangent. You look at the tangent. If you look at the tangent, then it is touching at 1 point and it is this y-axis touching at 2 points on this 8. So now tell me how to calculate the ratio of frequency of x-axis to the frequency of y-axis. Tell me, guys, what will be this value? What will be this value? How many times it is touching on y-axis? It is touching 2 times. And how many times it is touching on x-axis? It is 1 time. So the ratio will be opposite, na? Is it fine? So from here you can see that Fy came out to be 2. Is it clear, guys? Because this Fx is 4, na? Fx is 4. So Fy came out to be 2. It means answer is Bombay. Is it clear, everyone? Is it clear? Answer is Bombay. I think it's easy peasy. Let's come to the next question, guys. The last question. And let me contact Rathi sir also so that he can continue from this point onward. So please solve it, and there will be a glitch of like 10-20 seconds and then Rathi sir will continue. But before that, please try to solve this question. Do it fast, guys. Let me read this question first. A galvanometer is tested in the circuit where E is 1.5. Okay, this is E 1.5 and this is the galvanometer. We want to test it. Okay, R1 came out to be 1 ohm. Okay, and R2 is 250. R2 is 2500 ohm. R3, this is R3. R3 is variable. It is variable. Okay, R3 is variable. This is R3. This is R1. This is R2. Okay, this is R2. Now it's saying that we set R3 at 450 ohm. R3 is set at 450 ohm. Okay, the galvanometer deflection is 140 mm with R3 set as 950 mm. Okay, wait a minute. With R3 set at 450 ohm, the galvanometer deflection is 140 mm. Okay, he's saying that if R3 is 450 ohm, then the galvanometer deflection is 140 mm. 140 mm. Now, if R3 is set to 950 ohm, then the deflection is 70 mm. Then this deflection is 70 mm. The resistance of the galvanometer. We need to calculate the resistance of the galvanometer. What will be the resistance of the galvanometer? Do it, guys. Do it fast. It's an instrumentation question, so do it fast. Let me contact to Rathi sir also, so that I can tell him that now it's his turn, and Rathi sir will join maybe after this question. Obviously, maybe there will be 10-second glitch. So don't leave the class, guys, because Rathi sir will continue with the analog electronics part. So please solve this question and then Rathi sir will continue. Okay. Tell me, guys, what should be the correct answer? Have you done it? Have you done it? Do it fast. I think it's time to solve. Since we know that we have the galvanometer, in galvanometer, the deflection is proportional to the current. Okay, the deflection is proportional to the current. Now you can see that in the first case, let's say the galvanometer resistance is Rg. In the first case, we need to calculate this current Ig1. Let's call it Ig1. Now what is that Ig1? How to calculate that? Okay, we know that this voltage is 1.5 and we need to calculate this Ig1. How to calculate this Ig1, guys? If we know the total current, then we can apply the current division rule here and we can calculate this Ig1. Okay. Now, can you know the total current? Obviously, the total current cannot be found. Why? Because this Rg is unknown. So you cannot calculate the entire resistance. Okay. Equivalent resistance you cannot calculate. And if you cannot calculate the equivalent resistance, then you cannot calculate the current. But there is a catch. And the catch is, we know that this is, in the first case, it is 450 and in the second case, it is 950. Plus this Rg. It parallel with the 1 ohm. So now we can assume that the equivalent of this path and this path is approximately 1 ohm. It is approximately 1 ohm. Is it fine? The equivalent of this resistance and this resistance is approximately 1 ohm. Now we can calculate the current value. So the current value will be 1.5 divided by 2500 plus this equivalent value. And this equivalent value will be even less than 1. So we can neglect it compared to this 2500 ohm. So now you can calculate this current has to be 1.5 divided by 2500. This will always be the same. I mean, whether you take 450 or 950, this current will remain approximately constant. Okay. Why? Because the equivalent of this will be less than 1 because you are taking parallel 1 ohm and this ohm in parallel. So the parallel equivalent of this resistance and this resistance will be less than 1. And this is 2500 ohm. So 2500 plus this equivalent resistance, which is less than 1, this will be the total resistance. So we can neglect this resistance compared to this 2500. So you can say that the current will be 1.5 divided by 2500. Okay. Now what is this current, guys? It will be 1.5 divided by 2.5 milliampere. Okay. So you can calculate this as 3 by 5 milliampere. Is it fine, guys? 0.6 milliampere. So this current is 0.6 milliampere. Is it clear, guys? Tell me. Say yes or no. Okay, so we have calculated this current as 0.6 milliampere. It will not change whether you are changing this R3 as 450 or 950. Whether you are taking this R3 as 450 or 950, this current will remain constant. I hope it is clear. Okay. Now what we can do is we can apply the current division rule on this current and calculate the Ig1. So Ig1 in the first case will be equal to 0.6 milliampere into 0.6 milliampere into this resistance divided by the total resistance. This resistance is 1 divided by the total resistance is 1 plus 450 plus Rg. Okay. This is the first case current. Now in the second case, let's call it Ig2. This current will remain same as 0.6 milliampere into 1 divided by 1 plus 950. This resistance is changed to 950 plus Rg. Is it fine, guys? So I have calculated the current Ig1 and Ig2. I have applied the current division rule. This is my 0.6 ampere. So 0.6 into this resistance 1 divided by the total resistance. So the total is 1 plus 950 plus Rg. Okay. Now what you can do is you can take the ratio. You can take the ratio. And this ratio has to be equal to the ratio of the deflection. And the ratio of the deflection is 2. In the first case, it was 450. In the second case, it was 70. So this ratio has to be equal to 140 divided by 70. That is 2. Okay. This ratio has to be equal to 2. I hope it is clear. Now what you can do is, if you take this ratio, this will be cancelled. This has to be equal to 2. So this will cancel. Now if you take this ratio, then it will be in the numerator. So you'll get 1 plus 950 plus Rg divided by 1 plus 450 plus Rg equal to 2. Okay. From here you can calculate the value of Rg. Is it fine, everyone? Now you can calculate the value of Rg. Let me check the answer. Answer came out to be 49. Okay. Answer came out to be 49. Please check it. Answer came out to be 49. Okay. I think you can easily calculate. Answer which is provided to me is 49, I suppose. Yes, it's 49. Please check it, guys. It should be 49. Praneeth. Just multiply with 2 and calculate the value of Rg. Is it correct, guys? Answer is 49, I suppose. So do the calculation. The calculation part is very simple now. Okay. I think it's simple. So this was all about instrumentation, power electronics, signal and system, and control system. I hope you guys enjoyed this session. From so there will be a glitch of maybe 10 seconds. Don't leave the class, because from now this point onward Rathi sir will continue. But before that, let me tell you guys, you can join the test series provided by the BYJU'S Exam Prep, and in this test series there is a there are full length mock tests are also there, the subject wise tests are also there, and the link is given in the description. So you can go to the link and then you can join this test series. In this test series you will get 60 plus tests, including the full length mock test and the subject wise test. There will be virtual scientific calculator. Virtual calculator is exactly same as which is provided by the GATE exam. So you can join this test series, and there will be all India open mock test, and there will be questions of approximately 4,000 plus. So it means lots of questions are there. So you can practice with this test series. You can join it and check your mistakes, check your speed and accuracy. Okay, so I'm stopping the session, and from this point onward Rathi sir will join. Don't forget to subscribe and like, because I want the half century of the likes. Only 45 likes are there. So at least before joining of Rathi sir, at least make it half century, na? At least make it 50. Okay. So don't forget to subscribe the channel and like this session. Make sure that you install our mobile app, BYJU'S Exam Prep. So you go to the Google Play Store and install it, and you can watch the free sessions there on the mobile app also. Okay, so let me stop the session. There will be a glitch of 5-10 seconds, and then Rathi sir will continue. Okay, so just wait, guys.
Hello guys, very good afternoon and welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. How are you guys? To Raghuram, Praneeth and all Ashish Kumar, all other students, you have given the proper response. Now it is time to solve questions from digital, network and your favorite subject, that is what? Analog. Okay guys, are you ready? Everyone, very good afternoon. I am fine. How are you? And what about your preparation? Now it is the last lap, countdown already started. So this is a mock test on electrical engineering on your demand, and we are going to discuss MCQ, MSQ and numerical answer type questions. And this is my introduction, myself Sanjay Rathi. I am having around 21 plus years of teaching experience. Okay, after so many days. Oh, thank you dear. Now Prabhakar, it's very nice. Okay, good. Everyone, very good afternoon. Now, and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ESE 2005, AIR 21 in ESE 2008. And I have mentored more than 1 lakh students for this exam. According to my experience, we have around how many days? Around 7 to 8 days for electrical electronics student, computer science student. तो इस लास्ट टाइम में कॉन्फिडेंस नहीं छोड़ना है, क्विट नहीं करना है, मेंटली प्रिपेयर्ड रहिए, राइट, एंड डू डेली 10 मिनट मेडिटेशन एंड प्लीज शेयर द लिंक ऑफ दिस सेशन सो दैट स्टूडेंट विल ज्वाइन. ओके गाइस, नो डोंट वरी अबाउट द एग्जाम, डोंट फील टेंस, राइट. इफ द पेपर अगर टफ है, इट विल बी टफ फॉर ऑल द स्टूडेंट. If it is easy, then easy for all the student. Don't worry about the results, don't worry about the paper, but give 1 or 2 mock tests and how to use the scribble pad and how to use the virtual calculator and how to recall the concept. These 3 things are very, very important one. Okay, don't worry about that. Okay guys, now that is the mega workshop by Rakesh Talreja sir, 7 golden rules to secure the single digit rank in GATE 2024. अगर आप हैं for GATE 2024 तो आप ज्वाइन कीजिए, अदरवाइज सेंड द लिंक टू योर जूनियर्स ऑन BYJU'S Exam Prep app. Please note the time, 29 Jan at 12:30 PM. Okay guys, so this is a digital electronics. First of all, questions from digital electronics. Everyone quickly try to give me the response. Okay, first question, that is on multiplexer. That is on multiplexer. Everyone, what will be the answer? Tell me. Yes. 2 minutes more than sufficient. Everyone try to give me the answer. This is a 4x1 mux. The logic function implemented by the circuit below is ground implies a logic 0. For electrical student, it is a bonus mark, okay? Digital or what, sometimes you are getting straightforward questions from analog, right? Directly you can solve. So please, everyone try to solve this question. The logic function implemented by the circuit below is, that is on combinational circuit 4x1 mux, and this is the inverter, that is the inverter, and this is I0 is connected here, and selection line is what? PQ, I0, I1, I2, I3. I think question is clear to you. Okay guys, one student has given Ajay has given the answer that what D, it is equivalent to XOR of P and Q. Okay, Prayagraj Pandey, you have given the answer D. Okay then, other students please. Now remember, with the help of multiplexer, with the one student have given the XOR, XOR, you are saying that XOR, na? Yes. Now with the help of multiplexer, we can implement the Boolean function. It is a 2 variable Boolean function, P and Q only, right? Or with the help of 4x1 mux, we can also implement 3 variable Boolean function with inverter gate. If suppose if I want to use one inverter, then I can also implement the 3 variable Boolean function. I can also implement the 4 variable Boolean function, but for 4 variable Boolean function, extra gates are required. Extra gates other than inverters are required. Okay. Okay then, but last 8 seconds, 7 seconds. This is a very, very easy question. Yes, now time over. Finished. Okay then, next one. Now how to solve this question? Very simple. Make a multiplexer table. Right, or no need to write the multiplexer table, directly you can write this is the selection line. What is the output? F is equal to S1 S0 bar bar, this is the I0, plus S1 S0 I1 plus S1 S0 I2 and plus S1 S0 I3. Very simple. Now this is 0 here, this is 1 here, this is 0 here, this is 1, and that is 0. So this first term will become 0 plus I1. This is nothing but P bar Q plus P Q bar plus I3 is again 0. And this is P bar Q plus P Q bar. P exclusive OR with Q. It is nothing but XOR gate. Right answer, that is the D. Now next question. Consider the circuit given below with initial state Q0 is equal to 1, Q1 and Q2 is equal to 0. The state of the circuit is given by the value 4Q2 plus 2Q1 plus Q0. Which one of the following is the correct state sequence of the circuit? This is again a MCQ. MCQ means 2 mark MCQ. Okay, tell me. Which is this is a sequence generator. We can say what is the sequence or what is the counting of this, right? What is the actual counting when we are considering this weightage condition, this weight. Now, please read the question and try to give me the answer. Yes, please. Two mark question. Okay, again, what are the important topics? One is what combinational circuit, one is what sequential circuit, and sometimes in electrical branch, straightforward question on K-map, prime implicants, essential prime implicants, reduced prime implicants. So we have solved number of questions on this topic, MSQ by Rakesh Talreja sir, right? So please try to give me the answer. यार एक बार जरा इसे शेयर कर लीजिए एंड आस्क योर फ्रेंड टू ज्वाइन द सेशन. Consider the circuit given below with initial state Q0 is equal to 1, Q1 is equal to Q2 is equal to 0. The state of the circuit is given by this value. which one of the following is correct? This is the MCQ. There will be the negative marking. Remember, 2/3 negative marking. This is the D2, Q2, D1, Q1, D0, Q0. And this is the XOR gate. This is the MSB, and this is what LSB. It is a tricky question. अगर एक भी, if you are getting the 3 sequence, then you can judge which answer is correct. No need to find all the options, all the answer, all the sequence, all complete sequence. Time up. Time up. Okay. Which answer is correct? Raghuram. Now try to understand if it is given. I think the question is visible to you, everyone. First of all, write simply. Q2, Q1, Q0, D2, D1, D0. D0. Now what is the D2? D2 is connected to Q1. What is the D1? D1 is connected to Q0. And what is the D0? Q2 exclusive or with the Q1. Q2 exclusive or with Q1. That is the output. Okay. Then first sequence it is given here. 0, 0. This is the Q1, Q2, 0, and this is Q0 is 1. Okay. Now from this, what is the value of the D2? It is equal to Q1. So that is the next counting, 0. And what is the D1 Q0? It is 1. And exclusive OR of Q2 and Q1. Exclusive OR of Q2 and Q1, it will be 0. So this is the D is nothing but, what is the D flip-flop? QT plus 1 is nothing but the D. So what is the next counting? 0, 1, 0. So this is 0, this is 2. This is 1 and that is 2. 1 and after that 2. Now what is the Q1? Q1 is 1 here. What is the Q0? 0 here. Q2 exclusive or with the Q1. That is 1. Next counting is 5. 5. After 5, what is the Q1? 0. What is the Q0? 1, 0, 1. Directly you can write 0, 1 here. And then 1, 0. What is the exclusive OR of 1, 0? 1, 3. Now 1, 1. Directly you can write 1, 1 here. And 0, 1. What is the 0, 1? 1. That is the 7. 7, 1, 1. You can directly write 1, 1 here. And what is the exclusive OR of 1, 1? 0. So that is the 6. Right, so which is 1, 2, 5, 3, 7, then what, 6. Okay, and finally this is 1, 0. And that is 1, 1 is what? 1, 1 is 0. That is 4. 1, 0, 0. Repeat this 0, 0 here. And what is 1, 0? 1. And what is the next counting? 1. Okay, repeat. 1, 2, 5, 3, 7, 6, 4. 1, 2, 5, 3, 7, 6, 4. B is the B for Bombay is the correct answer for this question. I think now it is very easy. Right. Very, very simple. Directly in one step you can solve it. In one step you can solve it. But that is the approach. Directly write so that we can avoid the silly mistake. This is the present state and that is what? Next state. Present state, next state you can find. I think this is a complete hint about this question. Next one, network theory. So around 3 marks question from what? Digital. Normally we are getting this type of questions in what? Digital, in electrical branch. Now network. First question. 1 mark question, numerical answer type. That is based on what you can say mesh analysis or what simple KCL, KVL, basic question. What is the answer? Battery unknown EMF. Okay, try to give me the answer for this question. Please. Read question. battery unknown EMF is connected across the resistance as shown in the figure. This is the voltage drop across 8 ohm resistance is 20 volt. What is the unknown voltage? We have no idea. Okay, no problem. But the voltmeter connected across the 8 ohm resistor, what is the reading of that voltmeter? 20 volt. The current reading in ammeter is, where is the ammeter is connected? Here the ammeter is connected. Okay, tell me what is the answer? What is the internal resistance of voltmeter? Ideal condition. Voltmeter. Right, and what is the resistance of ammeter? Voltmeter is connected in parallel and ammeter is connected in what? Series. So what is the ideal value of the internal resistance of the voltmeter and ideal value of the internal resistance of ammeter? Okay. भाई ऐसे क्वेश्चन आएंगे ना, यस रिमेंबर, ऐसे बेसिक क्वेश्चन आएंगे. व्हाट इज द रीडिंग ऑफ एमीटर मींस दिस इज द एमीटर. टाइम अप. 2 minutes more than sufficient, guys. 2 minutes more than sufficient. What is the answer for this question? Very simple, 1 mark question only. Right, try to understand. Internal resistance of a meter is what? A voltmeter is what? Infinite, and that's why there will be the no current through this. But what is the voltage here? 20 volt. Reading of this voltmeter is 20 volt. We have no idea about this Vs. Okay, no problem. Now, what is the internal resistance of a meter? 0, because it is connected. It is connected in what? Series. Now I am going to find the value. Okay, numerical answer type question. Everyone give your answer because there is no negative marking. Then which answer is correct? I think Pratmesh, Pranit, your answer is correct. Krishna Vanit, please check your answer. Ajay, people, please check your answer. It is a very easy question. Okay. Now, if it is the 20 volt, what is the current? 20 is equal to what? 8I. So, what is the I? That is the current through this resistor. 20 divided by 8. That is nothing but 2.5 ampere. If this is the 2.5 ampere, this current, this is nothing but these two paths are connected in parallel. So this is divided into two parts, I1 and I2. Now this is the I2. At this point again I, and that is the distribution of the current. You have to find the reading. So current division rule. What is the current division rule? I2 is equal to 2.5 divided by, what is this resistor? 11. Plus, what is this resistor? 15 plus 13. What is the 15 plus 13? 28, because these two are in series, 28. And we want resistor in this branch. So according to current division rule, you have to multiply with the 11. So everyone please find the value. 2.5 into 11 divided by 39. And that is the answer. I think 0.705. 0.705. Okay. This is a very, very easy one. 2.5 into 11 divided by 39. 0.705 ampere. .705 ampere. To check your calculation. Again, this is a 1 mark question. Next one. Next question. Now tell me. MSQ only 1 mark question. MSQ 1 mark question only. Right. For a parallel RLC circuit, which one of the following statement are correct? Are correct. This was also 1 mark question. This is again MSQ only 1 mark. So within, read all these points and try to give me the answer. More than sufficient time. Read all these points carefully and give me the answer. A and D. Okay. For a parallel RLC circuit, which of the following, which of the following statement are correct? It may be one or it may be more than one. You are giving Raghuram A and D. Okay, other students? It is talking about the parallel RLC circuit, right guys? Standard parallel RLC. We have the two standard circuit. One is called series RLC circuit. Other one is called parallel RLC circuit. So which are correct? One may be correct or more than one may be correct. It is MSQ. Okay. Ashok, you are saying that A is correct, C is correct. Directly give me the answer. You are giving the partial answer. Bell baj gayi bhai, time up. Now try to understand, read this point. I have taken one session on what scribble pad, how we can use the scribble pad effectively. So for this type of question, no need to use what scribble pad, okay? But again, sometimes it is required, theoretical question, but formula. For a parallel RLC circuit, which of the following statement are correct? Try to understand. Parallel RLC circuit means this is R, this is L, and this is C. Okay, R, L, C. It is connected here. Now, the bandwidth of the circuit decreases. What is the, in case of parallel RLC circuit? Always remember the bandwidth is given by omega naught by Q. Right? What is the omega naught? Resonant frequency. Resonant frequency is 1 by root over LC. And what about the quality factor? Quality factor is given by omega RC. Omega RC. This is the quality factor. So when I am using this quality factor, okay, the bandwidth will become 1 by RC. Bandwidth will become 1 by RC. So what about the first point? The bandwidth of the circuit decreases if R is increased. Yes, that is correct. R increases, bandwidth decreases. A is correct one. The bandwidth of the circuit remains same if the L is increased. My dear friend, it is independent of L. That is also correct. RC 1 by RC parallel. I am talking about the parallel RLC circuit 1 by RC. So this is also correct. L independent of RC. At resonance, input impedance is real quality. Yes, at resonance it is a real quality because this will act as what? Open circuit. The combination of L and C at parallel resonance will act as what? Open circuit. And that's why we are having the pure resistor here only. Impedance is resistive, purely resistive, or admittance is also what? That is the purely resistive, or right? Conductance only. Conductance only. So we are having minimum value of conductance. Minimum value of conductance. So what about the resistance? Maximum. Admittance is minimum. Admittance is minimum. So what is the impedance? Maximum. This is the maximum because these two will act as what? Open circuit. Open circuit means what is the resistance? Impedance? Infinite. So maximum. So this is correct. Real quality. At resonance, the magnitude of the input impedance attain its minimum value. Wrong. Input impedance attain maximum value. Okay, Mayur, Das, Ashok. यार कोई भी सही आंसर नहीं दिया. Raghuram, now it is clear. This answer is what? Which are correct? A, B, C. A, B, C are correct. So everyone please revise this, that concept. Series resonance, parallel resonance. Series RLC circuit, parallel RLC circuit. Very easy. Within 10 minutes you can revise all this concept. Okay. A, B, C are the correct answer. And that is the formula for the quality factor, resonance frequency and bandwidth. Okay guys. Next question, next one. I think no doubt. Ready for next everyone? Ready for next question? यार एक बार आप लोग इतने लोग अटेंड कर रहे हैं, अपनी अटेंडेंस तो दे दीजिए. एवरीवन प्लीज लाइक द सेशन एंड also subscribe our channel because just we are going to take one or two more important session, that is in evening we are going to take what? Super 11 and so on. Right now the value of y11, what is the y11? That is one of the y parameter for the given electrical circuit is in Siemens. Siemens or mho we can say. Mho, sometimes it is written as like this. So that is the arrow for the Y11 parameter. For the given electrical circuit, this is the circuit, only 1 mark question, na guys. That's why only Y11 is required. Up to 2 decimal places. You have to give me the answer up to 2 decimal places. Sir, one is independent and how it increases? Which one is independent? Which one is independent? The bandwidth of the circuit decreases if the R is increased. The bandwidth of the circuit remains same if the L is increased. So independent of L, so how it will increase? The bandwidth of the circuit remains same if the L is increased. So here it is independent of inductor. So sahi to hai, that is the right statement. At resonance, input impedance is real quality. So what is the problem here? And it depends upon the R, inversely proportional to R and C. Prabhakar Tiwari, thank you dear. Now tell me what is the answer. The value of Y11 for the given electrical circuit is, I'm going to start your timer bhi to start karna hai. 1 minute. Yes. Y parameter. What I'm going to give you, please everyone try to solve this question. New students, just I'm giving you the hint. What is the Y parameter? It is a short circuit parameter. First of all, write down the equation for Y parameter and then only focus on Y11. Only focus on Y11 because only Y11 is required. Only 1 mark question. We can't waste our time. It is a numerical answer type question. Already we have solved one MCQ. Already we have solved one MSQ and then numerical answer type question. No negative marking. That's why everyone give me the response. 4 ohm, 12 ohm, 4 ohm it is written. This is the I0 and this is the 2 I0. Dependent source is connected here. $16 Siemens. Okay. Raghuram, other students, give me the answer. Check your calculation also. अच्छा टेल मी, ये टाइमर आपको प्रेशर क्रिएट करता है क्या? एग्जाम लाइक माहौल, मतलब जैसे टाइमर चल रहा है सर, टाइम बीता जा रहा है, बनाना है फटाफट, तो ये गलती हो रही है क्या इसके कारण? बिकॉज ऑफ दिस टाइमर वी आर नॉट एबल टू मेंटेन द एक्यूरेसी. इज इट दिस इज द प्रॉब्लम, राइट? यस. तो दैट इज इन एग्जाम माय डियर फ्रेंड, वी हैव टू सॉल्व द क्वेश्चन, राइट? गलत भी हो सकता है सर, और सर चेक करता हूँ. यस ना? हाँ, तो यही तो है ना. तो दिस इज जस्ट आई एम गोइंग टू स्टार्ट. यू हैव द टाइम. अभी भी रेस्पॉन्स दो ना, 2 मिनट से ज्यादा हो गया मुझे डिस्कस करते हुए. आप दीजिए ना रेस्पॉन्स. नाउ ट्राई टू अंडरस्टैंड हाउ वी कैन सॉल्व दिस क्वेश्चन. ओके, देखिए जरा. राइट, फर्स्ट ऑफ ऑल y parameter is required. Always write v1 is dot v1 because it is a y parameter. I1 is equal to what? Y11 V1 plus Y12 V2. No need to write the second equation because only Y11 is required. Otherwise, you can write Y21 V1 plus Y22 V2. Just we are wasting our time when we are writing the second equation. From first equation, what is the Y11? Y11 is nothing but I1 by V1 with V2 is equal to 0. V2 is equal to 0. V2 0 means output is short circuited, and that's why it is called short circuit parameter. So make it short circuit. Let this is the short circuit. Okay, now try to understand. This is short circuit. When I am making it short circuit, V2 will become 0. I2 is not 0. Remember that. Now V1 by I1. I1 by V1 is required. I1 by V1 is required. Okay. Now everyone please focus on the board. Now this is the I1. So what is the current here? I0. What is the current here? I0. I can write I0 is equal to, what is the voltage at this point? V1. And what is the resistance? It will become V1 by 4. I0 will become V1 by 4. Okay, no problem. Now what is the current here? I1. What is the downward current? I0. So what is the current here? I1 minus I0. Now at this point, what is the current in this branch? I1 minus I0 minus 2I0. It will become I1 minus I0 minus 2I0. That is nothing but I1 minus 3I0. 3I0. This is the current in this branch. In this branch. Okay. Because already we have, so this is called KCL. We are applying the KCL, Kirchhoff's current law, on diagram itself. Now only one, you have to apply out only one KVL. Fast apply the KVL. Then 1 minute. Okay. Apply the KVL from this point to this point. So what is the KVL here? V1 is equal to V1 is equal to 12 times of I1 minus I0 plus 4 times of I1 minus 3I0. 0. Now it will become V1 is equal to 12I1 minus 12I0 plus 4I1 minus 12I0, or it will become 16I1 minus 24I0. This is the equation number 2. What is the equation number 1? V1 by 4. Put here V1 by 4. 16I1 minus 24 into V1 by 4. This is the value of this V1 by 4 I0. So it will become 6 V1. It will become 7 V1 is equal to 16 I1. So my dear friend, what is the value of I1 by V1? That is nothing but Y11. I1 by V1 is equal to 7 by 16. 7 by 16. So up to 2 decimal places. What is the answer? 7 divided by 16.4375. I think now it is clear. My calculation is correct. Check my calculation. Check my calculation, and that is the answer. Right? That is the answer for this particular question. Okay. Okay guys, that is the 7 by 16 mho or 7 by 16 Siemens. Next question. 0.43 up to 2 decimal places, it will become 0.44. 0.44. Next one. Now, the two network of the, this is a 2 mark MSQ, 2 mark MSQ. कोई बात नहीं, तो कोई this is a question on 2 port. Please revise all this concept and try to avoid the silly mistakes. यहाँ तो student जवाब ही नहीं दे रहे, कम से कम आप जवाब दे रहे हो. Give me the answer for this question. Quickly give me the answer for this particular question. Again, it is a standard question. Inductor is given, capacitor is given. It is a figure number A. So the two network of the figure be equivalent, means these two figures are equivalent with respect to the pair of the terminal, which are identified as A or B. 1 1 dash, 1 1 dash, right? 1 1 dash, 1 1 and dash. Means the Z equivalent of this and Z equivalent of this should be equal. And that's why these two diagrams are equivalent. Okay. 1 Henry is given, 1 Farad is given, and what is the value of C1, L2, C3, L3? This is the L3 and this is the C3. And that is asked. And this is the MSQ, multiple select question. Which answers are correct? These are correct. Okay. Try to solve this question. In number of session I have given, this is the standard question from standard textbook, that is what Van Valkenburg. And when inductor and capacitor we are connecting, what is the method? Sometimes low value of inductor is not possible and high value of capacitor is not possible, and that's why we want this diagram, but actually we are designing like that, because low value of inductor is not possible and a high value of the capacitor is not possible. So in this case, we are increasing the value of inductor, we are decreasing the value of the capacitor, and ultimately this diagram will be equivalent to that diagram. Then in a very simple way, that is asked, what is the value of L and C? What is the value of L and C? Ajay, you are giving the A, B and C. Yes sir, 3 answers are correct. Okay, I will check. Other students, please. Raghuram, you are giving the answer A and C. Ajay, you are giving the answer A, B, C. It is visible. This is the L1. L1 value is given as 2 Henry. You have to find the L2, you have to find the C3, you have to find the L3. These are the answers. Time up. And Prabhat, you are given the A and C. Raghuram, Ajay, you have given the A, B, C. Okay. Now I have got the 3 answers. So other student, try to give me the answer. Now what is the answer for this particular question? Try, if these 2 diagrams are equivalent, what is the method here? Suppose it is L given, C is given. Now it is the L1, C1. So always the product L1, C1 is equal to L2, C2 is equal to L3, C3 is equal to what? LC. That is the method to solve this equivalent diagram. So L1, C1. What is the L1, C1? 2 into C1 is equal to LC. What is the L and C? 1, 1. 1 and 1. So that's why the C1 is become 1 by 2 farad. C1 will become 1 by 2 farad. So C1 is 1 farad is given. So that is the wrong answer. This is the wrong answer. D is wrong. Now second, L2, C2. This is the L2 and C2. So what is the L2, C2? L2 into 1 by 3 is equal to again 1, because LC is equal to 1. So what is the L2 is equal to? 3 Henry. L2 is equal to 3 Henry. It is given. Yes, A is the correct one. Now the value of C3. My dear friend, we have L3, C3 is equal to 1. But now L3 is not given, C3 is not given. How we are going to find? Now what is the parallel combination of these 3? The parallel combination of these 3, always remember, the inductor is given by because of inductor SL1 plus because of the capacitor 1 by SC1. 1 by SC1. And that is the value 1 by SL1 and 1 by SC1. Now when I am choosing, for example, first one is what? L1. L1 is what is the value of L1? 2, and what is the value of C2? 1 by 2. So it will become 2S plus 2 by S. So you can take 2 as a common, S plus 1 by S. Second one, 3S plus 3 by S. 3S plus 3 by S, because it is a 3 Henry, it is a 1 by 3. So it will become 3S plus 1 by S. Next, we have no idea that X is the value of inductor and 1 by X is the value of the capacitor. Then it will become XS plus what? X by S. You can take X as a common, S plus 1 by S. And what is the parallel combination of all these? The parallel combination of all these impedance is nothing but S plus 1 by S. Wow, this is S and this is what? 1 by S, because the capacitor value to S plus 1 by S. This is the parallel combination of this. S plus 1 by S. Then from this, what is the parallel combination of these 3? We can take S plus 1 by S as a common, remove it. So what is the parallel combination of 1 by 2 plus 1 by 3 plus 1 by X? That is equal to 1 by 1. From this you can find the value of what? X. From this you can find the value of X, because 1 by 2, 1 by 3, it is what? 6, and this is 3 plus 2 plus 1 by X is equal to 1, and that will become 5 by 6. 1 by X is equal to what? 1 minus 5 by 6. This is nothing but 1 by 6. So what is the value of the X? 6. Once you will get the value of 6, means the value of the L3 is 6 Henry and the value of the C3 is 1 by 6 farad. 1 by 6 farad. This is the correct one. C3 is 1 by 6 and value of the L3 is what? 6 Henry. And that is the right answer. A, B, C is the correct one. So Raghuram, everyone check your answer and try to solve like this. Try to solve like this. Okay then. Okay, I think now it is clear. Next question. Next one on transient. For IT for t greater than 0 for the below given electrical network, what is the answer? What is the answer for this part? It is a tricky question. Get the idea and everyone give me the answer. What is the answer for this one? No, fast. Find IT for t greater than 0 for the below given electrical network, and that is given as IT is equal to 4 plus 2 e raised to power minus 10t, 4 plus 2 e raised to power minus 2.22t and 2 plus 2. Only it is a RL circuit. What is the initial value of the current and what is the final value of the current and what is the time constant you have to find. Find the initial value, find the final value and then get the time constant. Use this formula. T by tau. So what is the final value? Means at t equal to infinite. What is the initial value? Means at t equal to 0. Remember, inductor does not allow sudden change of current. You have to use this formula. Okay, time up. Now in this case, what is here? At t equal to 0, the switch is open. It is given in the symbol. Means for t less than 0, the switch was closed. So exactly at t equal to 0 negative, inductor will act as short circuit. This is the 10 ohm. This is the 6 ampere. And since this switch is closed, that's why it will make the 5 ohm is short circuited by this. So what is the current here? The 6 ampere current. What is the current through the 10 ohm? 0. The complete current will pass through this path. So what is the initial current through the inductor? 6 ampere. Initial current through the inductor is 6 ampere. Now what is the final current through the inductor at t equal to infinite? Now the switch is open. When the switch is open, this is inductor will act as short circuit. This is the 6 ohm. And now 5 ohm it is connected here. So what is asked here? Below electrical network, what is the IT? IT means current through the inductor. So exactly at t equal to infinite, now the switch is open. Again the inductor will act as short circuit. 10 and 5. Please current divide rule and find the value of the I. At infinite, it will become 6 divided by 5 plus 10 into 10. That is nothing but 6 into 2 by 3. 4 ampere. 4 ampere. Check my calculation. I think this is the 2 by 3 and this is the 2 and 2 to 4 ampere. This is the final current. Now what about the time constant, my dear students? What is the time constant of this circuit? Now try to understand. The time constant of this circuit is to find the time constant. First of all, make the current source is equal to current source is equal to 0. That is open circuit. Now we are having inductor and 2 resistors. These 2 resistors 5 and 10 ohm and this is the 1.5 Henry. That is connected in series. So what is the R equivalent? 15. What is the L? 1.5 Henry. What is the time constant? L by R equivalent. 1.5 divided by 15, that is nothing but 0.1 second. Am I correct? 0.1 second. So we have the final value, we have the initial value. Then what is the formula, my dear friend? IT is equal to, what is the final value? 4. What is the final value? 4. What is the initial value? 6. E raised to power minus t by tau 0.1. So it will become 4 minus plus 2 e raised to power minus 10t. Now tell me which answer is correct. You are giving the answer D, or some student have giving the D. How? D. If exactly at t equal to 0, when I am putting the t equal to 0, this will become 4 plus 4. And what is the 4 plus 4? It will become the 8 ampere. How it is possible? A is the correct answer. Because maximum current is 6 ampere, that will pass through the inductor. How it is possible? Are you getting my point? Everyone, this is the A is the correct answer. Next one. Next question. तो MCQ 2 marks, 0 mark, negative marking. जितने लोगों ने गलत जवाब दिया ना, 2/3 नेगेटिव मार्किंग हो गई. 2/3 नेगेटिव मार्किंग. It is a MCQ. Okay then. No problem. Try to avoid all this. Now the find the V naught T for the T greater than 0 for the below given electrical network. Below given electrical network. You can also use the Laplace for this or any other method. 3 ohm, 1/2 Henry, V naught. You have to find a V naught. Remember, read question carefully. Below network, again it is a MCQ. MCQ. Okay. Everyone, I'm giving you the hint. Try to solve this question. Find V naught T for T greater than 0 for the below given electrical network. There are 4 options. MCQ, there will be the negative marking, 2/3 negative marking. And then inductor is given no initial condition because the 7 UT. What is the meaning of the 7 UT? Means for t less than 0, circuit is unenergized. So what is the initial current through the inductor? 0. Current through this inductor as well as current through this inductor is 0. 0, 0. Now you have to find the value of the V naught with the initial 0 condition. Initial 0 condition. Okay. So that is the meaning. Now what is the Laplace of the UT? You have 1 by S. You can find the Laplace transform of that. You can find the Laplace of inductor is what SL. Laplace of this is what SL. And then you can apply 1 watt nodal analysis, that is the KCL. Laplace inverse, you will get the answer for this question. It is not a standard RLC circuit, series RLC or parallel RLC, but it is a second order equation. And we are going to get the 2 different roots. You have 10 to 20 seconds. Give me the answer. I'm going to solve it, but you can give your answer on comments box. Now, time is up. Time up. Now, how to solve this question? First of all, this is the V naught S. I'm writing the Laplace. It will become SL. So what is the S by 5? And this will become S by 2. This is the 3, it will remain 3, and this will become 7 by S, and the 1 will remain 1. Now write down the KCL at this point. So you can write the V naught, no need to put the S, minus 7 by S upon 3 plus S by 2 plus V naught by 1 plus V naught divided by S by 5. S by 5 is equal to 0. I am writing the KCL at this point, V naught minus this and so on. Now you can multiply this S here. It will become S V naught minus 7 into what? 2. This is the 2. And here it is divided by S into 6, S plus 6. S plus 6 here. This S is multiplied and this 2 is multiplied above. Then that is the value. Plus V naught by 1 plus 5 V naught by S. Now you can take a LCM S into S plus 6. S into S plus 6. So it will become 2S V naught minus 14 plus V naught into S square plus 6S, S square plus 6S plus 5 V naught into S plus 6 is equal to 0. Okay. Now it will become 0. Here you are going to get the 2S V naught plus S square V naught plus 6S V naught plus 5S V naught plus 30 V naught is equal to 14. This 14. Okay. Because it is already become 0 and that is a 14. Now you can take the V naught as a common. 2S plus 6, 18 plus 13S. This is the S square plus 13S plus what? 30 is equal to 14. Now you can find the root. It will become 14 divided by what? S plus 3, S plus 10. These are the roots. 3 and 10 are the roots for this. 3 and 10 are the roots for this. Now find the partial fraction. V naught is equal to what? 14 divided by S plus 3, S plus 2. S plus 10. A divided by S plus 3 plus B divided by S plus 10, and you will get A is equal to, put the here minus 3 plus 10 and that is here 2, and B is equal to 14 divided by, put here minus 10 plus 3, it will become minus 2. And that's why finally you are going to get 2 by S plus 3 minus 2 by S plus 10. Take the Laplace inverse. 2 e raised to power minus 3t minus 2 e raised to power minus 10t. 2 e raised to power minus 3t minus 2 e raised to power minus 10t. Which answer is correct? This one. A is the correct answer for this particular question. Overdamped response, because we are having the real and distinct roots. Real and what? Distinct roots. Overdamped response. Okay, then next one. I think now it is clear to you, everyone. A is the correct answer. You have, I think, number of students have given the A option. Okay, then A. Next question. Find the Thevenin's voltage and the resistance RTH across A and B. Thevenin's theorem is the important. Norton's is important. There will be the question on dependent sources. 3 VAB, 2 kilo ohm, VTH. This is a MSQ, 2 marks. No negative marking. Everyone try to attempt this question. 3 VAB is given. It is the VAB. This is given as VAB. 1 kilo ohm, 2 kilo ohm, 10 volt battery is given. 2 kilo ohm resistor is given. You have to find the VTH and RTH. Now, Thevenin's voltage means what? Open circuit voltage. Already it is opened. RL is infinite. VAB. On VAB there is a dependent sources. When we are making it VOC, it will also become VOC. Between two nodes, if we are having the voltage source, you have to apply the super mesh analysis or super nodal analysis. Or directly you can find the voltage at this point. And then you can apply the KVL at this point, KCL at this point, or KCL at this point. And then you can find the value of VAB or VOC. And then we can find the value of ISC also. Okay. 2 minutes more than sufficient. चलिए now guys, what is the answer given by you? Yes, previous question is what? Overdamped response. Yes, now try to understand. This is the 3 VAB. First approach is 1 minute. This is the VAB open circuit voltage. So VOC, it will become VOC. Then 10 volt, 2 kilo ohm. There is a one resistor, 1 kilo ohm. Then 2 kilo ohm. This is VAB will become VOC. And what is the value? 2 kilo ohm, 1 kilo ohm, 2 kilo ohm. Plus minus 3 VOC. It is also become 3 VOC because it is a VAB. So what is the voltage at this point? 3 VOC plus VOC. This point the voltage will become 4 VOC. Write down the KCL supernodal analysis. Supernodal analysis means it will become 4 VOC minus 10 divided by 2. 4 VOC minus 10 divided by 2 plus 4 VOC divided by 1 plus VOC divided by 2. I am writing the supernodal analysis is equal to 0. Now from this you can find the 2. You can take the 2 as a LCM. It will become 4 VOC minus 10 plus 8 VOC plus VOC is equal to 0. We are taking the 2 as a LCM. Now it will become 8 plus 4, 12, 13 VOC is equal to what? 10. So what is the VOC is equal to 10 by 13 volt. And you can find that is the 10 by 13 means 0.769 volt. A. Now already we have the VOC. Then what is the short circuit current? Find the RTH. When I am making the output short circuited, everyone, when I am making the output short circuited, 3 VAB is equal to 0. This VAB will become 0. Once the VAB will become 0, this will also become 0. So this is the 2 kilo ohm, 1 kilo ohm. So what is the diagram actually? This is short circuited. This is already short circuited. So this is short circuited, this is short circuited. So this is the 10, this is the 2. So this current will pass here and this current will pass here, and that is nothing but ISC. What is the current here? 0. What is the current here? 0. Because it is short circuited. So what is the ISC is equal to 10 divided by 2, that is 5. And what is the RTH now? RTH is nothing but VOC upon ISC. VOC upon ISC. So you can find the value 10 by 13 divided by ISC. What is the ISC? 5. That is nothing but 2 by 13. 2 by 13, you will get the 0.1538 kilo ohm. So what is the answer in ohm? 153.8 ohm. 153.8 ohm. Okay, 1 mark question. Easy guys. MCQ 2 mark question. MSQ 2 mark question. Try to give me the answer. RTH, VTH, open circuit voltage, short circuit current. And then you can find the value of RTH. Now, this is the question on what? Steady state analysis of the sinusoidal signal. 2 mark question, but it is a very easy question. We are having the 2 signal. One is called DC signal, one is called AC signal. For the circuit shown in the figure, the time constant RC is given. The input voltage is given. The output voltage V naught T is equal to. Output voltage V naught T is equal to. चलिए बनाइए. आप आंसर नहीं दे रहे हैं. इसको तो आप विद इन 1 मिनट में बना लेंगे। ओके, तो यस रघुराम, नाउ आई थिंक एवरीवन दैट इज द प्रीवियस क्वेश्चन इज क्लियर टू यू। यार देखो, बहुत ज्यादा आप ना ये दिमाग मत लगाओ कि बहुत ज्यादा टफ आएगा पेपर या बहुत ज्यादा इजी, कुछ भी आप सोच कर मत जाइए, बस आपको पेपर बनाना है, राइट। रिपीटेटिव क्वेश्चन आ सकते हैं, कुछ प्रीवियस ईयर क्वेश्चंस पर बेस्ड आ सकते हैं क्वेश्चन, माइंड एकदम सही रखिए, आपकी तैयारी अच्छी है। For the circuit shown in the figure, the time constant RC, R and C, multiplication of R and C is given as 1 millisecond. The input voltage is VIT, 2 plus root 2 sine 10 to the power 3t. We are having the two frequency. One DC is the 0 and second one omega is 10 to the power 3 radian per second. The output voltage V naught T is equal to. In that case, we have to apply what? Superposition theorem. No other option. We have to apply the superposition theorem. So Ajay Paul, you have given the B answer. It is a MCQ, right? It is a MCQ 2 mark. Or what is the negative marking then? 2/3. Leading or lagging circuit? What is this? RC circuit is leading or lagging? Very basic concept. Simple. This is ours. When I am taking the output across the C, it is called low pass filter. Low pass filter. Your answer is conceptually. What is the method to solve this question? First of all, we are having the two signal, 2 plus root 2 sine of 10 to the power 3t. So what is the omega? 10 to the power 3 radian per second. And what is the, this is the second frequency. And what is the first frequency? This is the frequency for the DC, that is the 0. For 0 frequency, capacitor act as open circuit. We are applying the superposition theorem. We are applying the superposition theorem. What is the DC output? This is the DC input. So exactly equal to DC output. That is the output is 2. 2. Because at that time the capacitor act as what? Open circuit. And now second, when we are considering this for second signal omega 2, that is nothing but root 2 sine of 10 to the power 3t. It will become 1 by SC. So what is the V naught by V in? V naught 2 by V in. It will become 1 by SC upon R plus 1 by SC. That is nothing but 1 upon 1 plus SCR. Now you can put 1 by 1 plus J omega RC. What is the value of the omega? 10 to the power 3. What is the value of the RC? 10 to the power minus 3. That will become 1. Because RC is given as 1 millisecond. 1 second. It will become 1 second. And that's why the gain will become 1 upon 1 plus J1. And what is this? The magnitude is root 2 and phase is minus 45 degree. Phase is what? Minus 45 degree. Now finally, what is the output? Output is magnitude is multiplied with the magnitude of the input, and we have to add the phase here. So what is the magnitude? 1 by root 2. What is the magnitude of input? Root 2 sine of what is the omega t? 10 to the power 3t. And what is the phase? Minus 45 degree, not plus 45. This is the minus 45. So it will become sine of 10 raised to power 3t minus 45. This is the second output. Add first one, that is the 2. Which answer is correct? B or A? 2 plus sine 10 to the power 3 minus 45. Lagging circuit. RC circuit is what? Lagging. This RC circuit, low pass filter. This is the leading circuit. This is the high pass filter. This is the lagging circuit. That's why this answer is not correct. This answer is not correct. You have to change only the phase and you are getting the 45. Right. And this answer is not correct because this is the DC is not the same value. So my dear friend, within 10 seconds I can solve this question. Within 10 seconds. Okay. Because the DC will remain same and that should be what? Positive. Okay then. Next one. That should be, angle should be negative. Lagging circuit. Now, my dear friend, All India Open Mega Mock Test is waiting for you, and it is from the 24th January to 30th January. You can register here and give the mock test, 1 or 2 full-length mock test, right, with virtual calculator. The link is given in the description box. You can register now. Okay. And we are going to start what GATE Super 11 series, top 11 questions of every subject on electrical, electronics, instrumentation and computer science. From the 27th Jan, already Rakesh sir have taken one session. Now I am going to take one important session, that is on EDC. So this is a GATE 2023 exam analysis 4th and 5th Feb 1 p.m. and second session is on what 6 p.m. For proper exam analysis just after the GATE exam, subscribe our channel and so that you will get the notification about this session. Okay, just after the exam, we will provide you the complete analysis of a GATE paper. Authentic with detailed solution of each and every question for electrical, electronics and computer science branch. Please note the time. Now, analog electronics. Last one. After that, Ashutosh Saxena sir will join. Okay, so please give me the answer. The function of the bleeder register in a rectifier with LC filter is to. What is the function of the bleeder resistance? Theoretical question. Now I am not going, I will not give you the time. Try to solve this question. Bleeder register means when we are using the filter here. For example, it is a rectifier, half-wave rectifier. Here I am connecting the filter. Center tapped transformer type. Then this is RL. I am connecting a bleeder resistance here, RB. L. So what is the purpose of the bleeder resistor here? What is the purpose of the bleeder resistance here? It is a MCQ 1 mark question. The function of the bleeder resistor in the rectifier, maintain the minimum current through the C? No. It will not maintain the minimum current through the C. Why we are connecting the bleeder resistance? Please go through the theory. We are connecting the bleeder resistance. Suppose any user will remove the RL. Then suddenly the current through the inductor will become 0 and the voltage across the inductor will be very, very high. Very, very high suddenly. And that's why it may damage the circuit. It may damage the circuit. It may damage the diodes. To avoid this EMF, that is called back EMF, we are connecting the RB. And what is the basic purpose of RB? To provide a minimum current through the inductor for proper functioning of the inductor. That is the correct one. Maintain the minimum current necessary for the optimum inductor operation. Maintain the maximum current, that is not right. Charge the capacitor, no. No doubt it is also used to discharge the capacitor when the supply is turned off. When the supply is turned off and there is no RL, definitely the capacitor will discharge through this resistor. Discharge through this resistor to avoid accident. To avoid accident in this power supply. And that's why it is not the correct. Charge the capacitor, that is not the correct. Only the B answer is correct. Get the theory about what bleeder resistance, because this time MSQ. Okay. So this answer is B. Maintain the minimum current necessary for the optimum inductor operation. So रीड ऑल दिस पॉइंट. अगर आपको मालूम था तो अपने आप को एक पॉइंट दीजिए, एक नंबर दीजिए. नेक्स्ट वन. नो, दिस इज अ क्वेश्चन ऑन व्हाट द PNP transistor. For the circuit shown in the figure, assume beta is equal to 75, VEB active, because in PNP VEB active 0.7. What is the value of the emitter to collector voltage? VECQ. VECQ, you have to find the 0.2, 13.61, 14.16, 15.16. Right, guys. It is a PNP transistor. So try to solve this question. Give me the answer in comments box. I am going to solve it. PNP transistor. Okay. Now, first of all, for DC analysis, because when VECQ, this is the Q point, DC analysis, this capacitor will act as open circuit. Remove the capacitor, everyone. Please remove this capacitor, because this capacitor will act as open circuit. Then second, apply the Thevenin's equivalent. Apply the Thevenin's equivalent here. Okay. When I am going to applying the Thevenin's equivalent, it will become 12 divided by 3 plus 12 into VCC. That is the VTH. So it will become 12 divided by 15 into 20. That is 4, that is 3, and this is the 16 volt. And what is the RTH? These two resistors are in parallel. 12 parallel with the 3. That is 36 divided by 15, 2.4 kilo ohm. 2.4 kilo ohm is the Thevenin's resistance, 16 volt and so on. Now we can make a diagram. This is the Thevenin's equivalent. Now you can connect this transistor, 1 kilo ohm, and this is the 2 kilo ohm. 20 volt battery is connected here. Already we have solved this. And what is the value here? 16. And what is the RTS? 2.4 kilo ohm. Now, what is the current distribution? This is important. Here we are having the I. I is nothing but 1 plus beta times of what? IB. Here it is the IC. What is the IC? Beta times of IB. And what is the current outside? IB. This is the inside and that is the outside. And what is this voltage? This is called VEB. VEB is nothing but 0.7 volt. It is given in the question. It is given in the question. VEB active is 0.7. What is the value of the VECQ? Yes, potential divider we can say. Now you have to find the VECQ. Now you can write a KVL here. You can write a KVL from this point to this point. When I am writing the KVL here, it will become 20 is equal to 2 times of 76 times of IB. Why I am writing 76? Because it is a beta. What is the beta given in the question? 75. So it will become 76 times of IB. It will become 75 times of IB. We are writing the KVL from this point to this point. What is the voltage from this? 0.7 plus 2.4 times of IB plus what? 16. From this you will get the value of the IB. 20 minus 16 minus 0.7 divided by 76 into 2 plus 2.4. Plus 2.4. Everyone give me the value of the IB. Otherwise I will give you the value of IB. Right. 3.3 divided by 154.4. That is the value of the IB. That is the value of the IB. Once you will get the IB, you can find the IC. 75 times of IB, that is 3.3, 154.4. This is the 152 plus 2.4 is what? 154.4, 154.5. This is the value of IC. Now what is the value of IE? 76 times of IB. Find the value, find the value. Finally, you have to find the VECQ. Write down the KVL from this point to this point. Write down the KVL from this point to this point. At the output, you will write that 20 is equal to 2 times of IE. This is the 2 times of IE plus VECQ plus ICQ into 1. You have the value of ICQ. This is the ICQ and this is the IEQ. And from this you can find the value of VECQ. Just I am giving you the hint. VECQ. Right. Yes, 1.6 ampere, 1.6 milliampere. And IE is 1.624 milliampere. 1.624 milliampere. And approximately you are going to get 15 point something VECQ. Okay, so just I am giving you the hint because we have limited time. So my dear friend, I think that is clear to you. You are how to apply the Thevenin's in case of PNP transistor, and that is the method. And then my dear friends, this diagram is important. Once write the KVL here, you will get the value of IB. From this KVL, you will get the value of VECQ. VECQ. Okay. Then next one. If VECQ is greater than 0.2 volt, it is what? It is in active region. Okay. Next question is MSQ. Next question is what? MSQ of 2 marks. Okay. So this is the MCQ. This is the MCQ. Now tell me. Missing कैसे? चलिए बताइए. To achieve the slew rate greater than or equal to 2 volt per microsecond. What are the possible input signal frequency and peak amplitude of the output signal? Peak amplitude of the output signal, everyone. What is the answer? To achieve the slew rate greater than or equal to the 2 volt per microsecond, what are the possible input signal frequency and peak amplitude? Slew rate. What is the slew rate? That is given by maximum rate of change of output voltage. Or what is the another formula? The closed loop gain into what? Maximum rate of change of input voltage. Normally for maximum value of this, maximum value of frequency of operation, we are normally taking closed loop gain, let it tends to what? 1. If the closed loop gain is 1, that is for voltage follower, then the slew rate will become maximum. If closed loop gain is not given, you can take it what? 1. Then for example, to achieve the slew rate, what are the possible input signal frequency and peak amplitude of the output signal peak amplitude, right? Or that is the case. Otherwise, slew rate is equal to mod of ACL into what? Rate of change of output voltage maximum. Now, if it is given, let the VI is equal to Vm sin omega t. So what is the rate of change? It will become Vm omega cos of omega t. So what is the maximum? When it is 1 omega. This is called maximum. When I am putting here Vm and this is the omega because I am putting the maximum value. This ACL Vm, this complete will become, this is the amplitude of the input signal and this complete will become amplitude of the output signal. Amplitude of the output signal. This is the maximum amplitude of the output signal into maximum frequency of operation. This is called maximum frequency of operation. Now, which will satisfy this condition? What is the slew rate here? It should be greater than or equal to a 2 volt per microsecond. Means this product should be greater than or equal to 2 into 10 to the power 6 volt per second. Convert the microvolt per second into volt per second. Then which condition? Check the condition. 1.6 into 10 raised to power 5. This is given in hertz. This is given in hertz. Convert it into what? Omega m. What is the amplitude? 2 into 2 pi into what? 1.6 into 10 raised to power 5. Check this whether it is greater than. If it is greater, then it is satisfied. Second option, check this. Only 1 volt is given. It is satisfied. I think it will not satisfied. It will satisfied. I think it will not satisfied. So answer is what? A and C. MSQ. So what is the method, my dear friend? Why I am giving so solution? This is because it is a formula based question. To achieve the slew rate greater than or equal to this one, always convert it into what? 2 into 10 raised to power 6 volt per second. And remember, slew rate is ACL into dVi by dt maximum. When ACL is multiplied with the amplitude of the input, it will become amplitude of the output. Amplitude of the output into omega. Omega is the maximum frequency of operation. This is the maximum frequency of operation. And you have to satisfy the condition here. Okay. Any doubt? Give me 1 minute. Next one. Okay. This is again MSQ of 2 marks. MSQ of 2 marks. Everyone try to solve this question. This is a very important question on symmetry gear. This is a very, very important question on symmetry gear. Take your time and give me the answer. Okay, guys. A, C, D. A, C or D. Now, this is a very important question. Now try to understand. This one, in a hysteresis loop, always remember one thing. For example, it is a symmetrical circuit, right? It is for a hysteresis curve in the voltage transfer, the symmetrical circuit. Which of the following options is are correct? Right? First of all, find the voltage at this point for positive value and for negative value. But what is the voltage at this point? VA. What is the voltage at negative terminal? First of all, find this. So we can write how we can find this voltage. You can write the KCL. So when I am writing the KCL, no need to make that 0. It is a Vn minus Vin divided by 10 plus Vn minus 2 divided by 20 is equal to 0. This is the 10 and Vn minus Vin divided by, or first of all find this value. So it will become, you can take the 20 as a LCM, 2Vn minus 2Vin plus Vn minus 2 is equal to 0. 3Vn is equal to 2Vin plus 2. It will become Vn is equal to 2 by 3 Vin plus 2 by 3. That is the value of negative terminal voltage. That is the value of the negative terminal voltage. Now, what is the positive terminal voltage? Positive terminal voltage we have because there is a positive feedback only. That's why the output has two levels, plus Vset and minus Vset. So, what is the positive terminal voltage? The positive terminal voltage will become 5 divided by 25. 5 plus 20, that is the 25 into V0. Since we have the two values of the V0, so what is the value of the Vp1? 5 divided by 25 into what 10, it will become 50 divided by 22 volt. And when I am taking the negative value, 5 divided by 25 into minus 10 volt, it will become minus 2 volt. And that is the value of the positive terminal voltage. Or my dear friend, when the negative terminal voltage will cross the positive terminal voltage, there will be the change in the output. So what is the negative terminal voltage? It is not the V in, it is the 2 by 3 V in plus 2 by 3. So you have to equate it. 2 by 3 V in plus 2 by 3. You have to equate the negative terminal with the positive terminal. First of all, equate it with the 2. You will get V in is equal to 2 minus 2 by 3 multiplied with 2 by 3. So this is nothing but 1 by 3 into 2 by 3. 1 by 3 into 2 by 3. Am I correct? No. Not correct. It will become 6 minus 2 by 3 into 2 by 3. Now I think this is correct. Oh, sorry. Sorry for that. 2 by 3 Vn is equal to 2 minus 2 by 3. That is nothing but 6 minus 2, 4 by 3. And what is the V in will become 4 by 3 into 3 by 2. That is the 2 volt. So this is the value of the first threshold. This is the value of the first threshold. Again, you have to equate the 2 by 3 V in plus 2 by 3 is equal to minus 2. So what is the 2 by 3 V in? Minus 2 by 3. It will become minus 6 minus 2 by 3. That is minus 8 by 3. Minus 6 minus 8 by 3. And what is the V in then? Minus 8 by 3 into what? 3 by 2. What is the answer? Minus 4. So first threshold value is 2 volt. When the V in cross the 2 volt, there will be the change in the output. And what is the second threshold value? Minus 4 volt. When the V in cross this value, there will be the change in the output. 2 volt and minus 4 volt. And what is the hysteresis voltage? Upper threshold minus lower threshold. So hysteresis voltage will become 2 minus of minus 4. That is nothing but 6 volt. 6 volt. Which answers are correct? Upper threshold level is 2 volt. Yes. What is the lower threshold voltage? Minus 2 volt. Wrong. What is the lower threshold voltage? Minus 4 volt. The hysteresis width is 6 volt. Yes, this is the hysteresis width is what? 6 volt. Right, guys? Hysteresis means clear. So which answers are correct? Tell me. A is correct. B is correct. D is correct. So what are the answer given by A, B and D? Yes, one student has given the answer. Krishna Vedi, you have given the A, B and what? D. And Raghuram, you have given the A, C, D. It is not the correct one. A, C, D. Right. Just Asutosh Saxena sir will join after this. Okay then. Okay, sir. So this is all about the analog. And now, my dear friends, GATE and ESC, this is the test series. Get unlimited access to the full length mock subject wise test. Description is given in the that is box. Okay, just आप जाइए, link वहां पर है आपके पास, and please go through that link so that you will get the all detail about this test series. Okay, guys. Why? Because 60 plus test, detailed mock analysis, virtual scientific calculators available, created by GATE expert, all India open mock test, 4000 plus practice क्वेश्चन. कोई भी छोड़िएगा नहीं. जस्ट मैंने यहां से लीव किया और आशुतोष सर ज्वाइन करेंगे. यू आर ऑन बायजूस एग्जाम प्रेप, द मोस्ट कॉम्प्रिहेंसिव ऐप फॉर ऑल एग्जाम. And go through this QR code, scan this so that you will get the link for our Telegram channel where you will find PDF for all this session. Thank you for your cooperation. बहुत ही पेशेंस के साथ आप लोग पढ़ रहे हैं. थैंक यू वेरी मच. बस 2 मिनट बस, बिल्कुल वेट करने की जरूरत नहीं है. 10 सेकंड में आशुतोष सर ज्वाइन कर लेंगे. 1 मिनट दीजिएगा.
Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining live with me, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. So I think my audio and visual quality, everything is clear. Hi everybody, welcome to the session. I hope you are enjoying the session since morning. First Ashu Jhangra sir, then Sanjay Rathi sir. Now I will be taking some part of the questions from power system, machines and verbal ability part, and after me Rakesh Talija sir is going to join you. So be there, have some patience, and it's like if you are sitting in the real gate examination, because the way this question paper is drafted, we have taken care that it's going to be at the same level as that of your real gate examination. It's not too difficult, it's not too easy, it's a balanced paper. So just see some more questions from my side. I hope everybody is okay with that. Shall we start? Some of you may be joining me for the first time, so very briefly, I will just introduce myself. My name is Ashutosh. As you can see on the screen, this is my brief profile. Now, everybody's favorite and my favorite, Rakesh Talija sir, is going to conduct a mega workshop on 29th of January, 12:30 p.m. 29th of January, that is tomorrow, and it is 12:30 p.m. in the afternoon. 7 golden rules to secure a single digit rank in GATE 2024. So if you have any juniors, colleagues, or you yourself interested, then you can join this workshop. You have to register yourself in BYJU'S Exam Prep. Now, All India Mega Mock Test for GATE 2023 is conducted between 24th of January and 30th January. So if you have missed it, register yourself and appear for this Mega Mock Test. It is going to give you a lot of confidence. Hi Ashok, Raghu, everybody. So we have started one more series from 27th, that is yesterday, GATE Super 11, where we are discussing top most 11 questions of every subject for EC, electrical, instrumentation, computer science. Subscribe to BYJU'S Exam Prep so that you do not miss any of these sessions. One of the most awaited sessions throughout the year, the live GATE exam analysis we are bringing once again for electrical, electronics, and computer science on 4th and 5th of February, 1 p.m. in the afternoon and 6 p.m. in the evening. So subscribe to BYJU'S Exam Prep. Everybody just quickly hit the like button, hit the bell icon, and subscribe to BYJU'S Exam Prep. Let us see the first question. So first we are talking about power system. Consider a 3-core, 3-phase, 50 Hz, 11 kilovolt cable whose conductors are denoted as RYB. So figure is not mentioned, so no problem. I think it is missed. So it is something like this. It is a 3-phase core cable. So this is basically the diagram. It is a standard diagram, so there is no confusion here. Okay. So he is saying the interface capacitance is C1. So this capacitance is going to be C1. Any two phases, sorry, C1. This is going to be C1. This is A, this is B, and this is C. And the capacitance between the sheath and any individual phase is suppose C2. Okay. So he is giving you the values of C1 and C2. C1 is given as 0.2 microfarad and capacitance C2, each line conductor and the sheath is given as 0.4 microfarad. He is asking what is the per phase charging current. So basically you have to find the per phase capacitance. Once you know the per phase capacitance, very easily you can find the charging current, because charging current is going to be how much? It is going to be V phase multiplied by 2 pi F capacitance per phase. Yes or no? Yes. How to find the per phase capacitance? If you are not aware, just see here. What I will do, if you see this C1 capacitances which are forming a delta, I am going to transform it into a equivalent star. So if you transform it into equivalent star, it is going to look something like this. A, B, C, this is the neutral point. So you have transformed it into the equivalent star. This is connected to the ground. This is A, this is B, this is C, and this is the neutral point. Now you see the sheath and the neutral point both are at the zero potential. So what I can do is I can remove this point from here and I can connect it back to the sheath because it is at the same potential. Similarly for B also we can do the same. Similarly for C also we can do the same. So if you see capacitance per phase in terms of A, B and C phases is going to be what? This star is going to be 3 times C1. Yes or no? Because when you go from delta to star, capacitance is multiplied by 3. Resistance and inductances, they are divided by 3. So capacitance per phase becomes 3C1 plus C2. Just put the value. What is C1? 0.2. What is C2? 0.4. So it becomes 3 दूनी 6, 0.6, 6 4 10, so 1 microfarad. Yes or no? Yes. Now you can write the charging current. Charging current you will always find per phase. So V phase 2 pi F capacitance per phase. What is the per phase voltage? is giving the line RMS voltage as 11 kilovolt. So it becomes 11 kilovolt multiplied by 2 pi f. So it becomes 314 into 1 10 to the power minus 6. Now just calculate this value and tell me what is the answer you are getting, everybody. Ajay is getting A option. Please solve this. I don't have a reference answer for this. You have to solve it. Please cross check this calculation. Raghu is saying 3.454. How you are getting 2 amperes, Mr. Ajay? Everybody is getting 3.454. So we can assume D is the correct option, most closest. So it is 3.454 amperes. I hope everybody is okay with the answer. See the next question. A fault occurring at the terminals of an unloaded synchronous generator operating at its rated voltage has the result in the following values of current and voltage. So zero sequence, positive sequence and negative sequence components of the A phase currents are given, and all the voltage sequence components, positive, negative and zero sequence for A phase, they are same. Is given as 0.237 per unit. He is asking the type of fault. Now please understand, half of the part is not visible. Okay, just one moment. Let me hide myself. Now just read the question once. Now I think it's okay. It's quite easy question. So one thing you have to understand, how you have to approach these type of questions. The first thing you have to check whether zero sequence is present or not. If zero sequence is present, it means it can never be a line-to-line fault. It can never be a line-to-line fault. Yes or no? So it cannot be a line-to-line fault. Now there are two possibilities, three possibilities. Either it can be line to ground fault, or it can be double line to ground fault, or it can be three-phase symmetrical fault. But it cannot be a three-phase symmetrical fault because positive and negative sequence both are present. So three-phase symmetrical fault is also not the possibility. Now you may have line to ground fault or double line to ground fault. Yes or no? Now line to ground fault, you know, all the sequence components of the current, they are same. Yes or no? So it cannot be line to ground fault also. If you see the double line to ground fault, it has circuit like this. Positive sequence, negative sequence, and just a moment. So there was a load shedding. I hope you understand. Day-to-day problems. Yeah, it's a day-to-day problem for power system engineers. You understand that. Okay. Whenever you are getting some problems in your life, you please be happy, because it means the God is with you. You are in the right direction. If you are having everything good in your life, it means there is some problem. you are on the wrong path. But if you are getting back-to-back problems, it means you are in the right path. So whatever is going to happen, we are not going to lose our commitment and we will do the questions. So we are assuming that fault impedance is 0, so it is a bolted fault, and neutral impedance is 0, so it is a solidly grounded neutral. So all of them, they are connected in parallel like this. This is the circuit A, Z1, Z2, and this is Z0. So you understand that the positive sequence, the negative sequence, and the zero sequence component of the voltages, they are same. And at the same time, IA1 must be equal to IA0. Once again, give me a moment. Sorry for the disturbance. Once again, we are on the right path because back-to-back electricity problem is there, but no problem. So I hope you got the answer that how you should approach these type of questions. First, you have to check whether ground is involved or not. If the ground is involved, directly you can understand line-to-line ground cannot be there. Then check for the three-phase symmetrical fault. If both positive and negative sequence are present, it means it cannot be three-phase symmetrical fault. Now comes line to ground fault and double line to ground fault. Now line to ground fault, all the sequence components of the current must be same. Whereas for double line to ground fault, the summation of, because IA is going to be 0 na, so the summation of IA0, IA1 plus IA2, it has to be 0, and that is you can cross check it. Okay, if you add this IA0 and IA2 and IA1, it is going to be 0. Good afternoon, Payash. So everybody is comfortable with this question? I hope it's very easy, direct question. See the next question. A three-phase transmission line supplies a delta connected load. The conductor C of the line develops an open circuit fault as shown in the figure. The currents in the lines are as shown on the diagram. The positive sequence current component in A phase is going to be. Now please understand how you are going to write the zero sequence, positive sequence, and negative sequence currents. It is going to be 1 by 3, and this is going to be IA, IB, IC. This is going to be 1, 1, 1, 1, alpha, alpha square, 1, alpha square, alpha. Okay? But you have to understand when you are writing the positive, negative, and zero sequence currents, you have to write the phase currents. Okay? So if you see IA, IB, IC, they are given as unbalanced. IA is given as 10 angle 0. -10 ∠0°. IB is given as 10 angle 180°, and IC is suddenly becoming 0. Yes or no? So what you can do is you can assume in terms of phase current that this is your A to B current, this is your B to C current, and this is your C to A current. Now, because IC is going to have an open circuit, okay, it means current IAB and IBC is going to be same. Yes or no? So you can simply uh, divide these two currents in such a way so that you can find ICA, IB, and IBC. Can you do that? Once you do that, you just put the values here. IAB, IBC, and ICA, and corresponding to the AB phase, you can say you will be getting the positive, negative, and zero sequence of the current. But he is asking in the question basically the positive sequence current. Or he's asking in the line. Okay. So don't go to the phase because he's asking in the line. So directly you can go to the line. So no need to do this. I was thinking he was asking in terms of phase. So no need to do this. Is it okay? He's asking in terms of the line only. So just put IA, IB, IC here directly. You will be getting IA1. Can anybody solve this quickly? If he would be asking here in terms of phase current, then you have to be careful for the delta connection. Okay, you have to change it. Can anybody do it quickly? Can you cross check it so that we get the right answer? What is going to be IA1? It becomes 1 by 3 IA plus alpha IB plus alpha square IC. Now IC is 0, so take it 0. So it becomes 1 by 3. What is IA? 10 angle 0. 10 angle 0 degree plus alpha is 1 angle 120 degree. What is IB? It is 10 angle 180. 10 angle 180 degree. Can you cross check it and tell me what is the positive sequence component of the current you are getting for line A? Just do it fast. Use your calculators fast. Should I wait for your answer or move on? Anybody is getting option A, B, C, D, any option? .66 Raghu is getting. Anybody else? Can you cross check this 4.66 angle minus 0.79 degrees? Raghu, I think there is something wrong with your calculation. Please do the calculation part as your homework. Okay. Let us go to the next question. A 500 MVA 50 Hz three-phase turbo generator produces power at 22 kilovolt. The generator is star connected and its neutral is solidly grounded. So it means neutral reactance is 0. It's okay, Ajay, you can do it as your homework. Okay, do the calculation part. Now their sequence reactances are mentioned as X1, X2 and X0 mentioned. It is operating at the rated voltage and disconnected from the rest of the system. That means it is on no load. The magnitude of the sub-transient line current for a single line to ground fault for the generator terminals in per unit. So basically he is asking the sub-transient line current, that is nothing but the fault current. So you know the fault current you can write as 3 times EA for a single line to ground fault as Z1 plus Z2 plus Z naught plus 3Zn plus 3Zf. Now he is saying the neutral is solidly grounded and fault impedance is not mentioned. I think it's not mentioned. So you can take both neutral and fault impedance as 0. So simply your fault current is going to be 3 times, okay, because it is given in per unit, so it is better you write EA as 1 only. You have to write it per unit. Z1, Z2, Z0 is going to be 0.15 plus 0.15 plus 0.05. So just solve this. What is the answer you are getting? 2.857. 2.857 per unit. So everybody is getting A option. Easy question. See the next question. Three-phase transmission line is drawn in the figure or shown in the figure. The voltage drop across the transmission line is given by the following equations A, B, and C. In terms of the matrix, having the diagonal elements at ZS and Zm is the off diagonal elements. Now, if you observe with the diagram, with this diagram, very easily you can understand that it is a standard case where the three transmission lines, their self-reactance is XS and their mutual reactance is XM. Yes or no? If you write the equation, you will get the same. And you know that positive and negative sequence impedances, they are mentioned as XS minus XM, whereas the zero sequence is XS plus 2XM. Last year, 2022, there was a question on this concept. Oh, it's okay, Ashok. What is this 8.5? So he's giving you the positive and zero sequence impedance, that is 15 and 48. So you have basically two equations, XS minus XM. He is giving you 15 and XS plus 2XM is given as 48. So can you solve this? Just multiply it by 2, so it becomes 2XS plus 2XM. Sorry. Just give me one moment again. So you see a lot of problems. It means we are on the right path. Yes or no? So it becomes 30. Just add these two equations. It becomes 3XS is equal to 8, 4 3, 7. 3 निकलना 3, 3 दूनी 6, 18, 3 6, 18. So XS becomes 26. And what about XM? XM becomes XS minus 15. So 26 minus 15, it becomes 11. So 26 and 11. Okay. So it is a multiple, actually it is a multiple select type question. So B and D, both are going to be the correct. Is it clear, everybody? Raghu, both B and D are correct, na? ZS is 26 you are getting. See the next question. In an unbalanced three-phase system, phase current IA and negative sequence IB2 and zero sequence IC0 is given. He's asking what is the magnitude of phase current. So basically, it's a little twisted question. You know the concept, how to write IB. How you can write IB? You can write IB as IB0, IB1, and IB2. Okay. Now IB naught, how you can write? See here, IB naught is going to be same as IA naught or same as IC naught. So IC naught is given in the question, so why not use it? IC naught is given, so better we can write IC naught. IB1. Now see here, he is giving you IB2 already. IB2 is mentioned. So IB2 is mentioned. The only effort you have to do is you have to find IB1. How to write IB1? Now see here. If you see, the A phase current is given. Yes or no? A phase current is given. So you can write A phase current as IA naught, IA1, IA2. Yes or no? Now IA naught you can write as IC naught. This is the same thing. Now can you write IA1 in terms of IB1, because I only need IB1. IB naught I have written and IB2 also I have. So I want IB1. So you can write IA1 in terms of IB1. How? For positive sequence, the phase sequence is same as the original phase sequence. That is ABC. Yes. So you have to write positive sequence having the same sequence as that of the original phase. So can you write VA1 in terms of VB1? Yes. So VA1 you can write as alpha times VB1. Yes or no? Alpha is just one operator. If you multiply any phasor with alpha, then it is going to be rotated by 120 degree, whereas magnitude is not going to be changed. So VB1, if you multiply by alpha, it becomes VA1. Or if you want, you can write in terms of current also. Yes or no? So can you write IA1 now? You can write it as alpha IB1 plus IA2. Now you don't know IA2. So can you write IA2 in terms of IB2? Yes. For the negative sequence, if this is IA2, then this is going to be IB2 and this is going to be IC2. The phase sequence is reversed now. So can you write IA2 in terms of IB2? Yes. If you have IB2, just multiply it by alpha square, alpha and alpha, you will get IA2. So IA2 becomes alpha square IB2. Yes or no? Now see very carefully here. You know what is IA given in the question. You know what is IC naught given in the question. You know what is IB2 given in the question. Can you find IB1? Find IB1 and put it in the previous equation. Everybody is getting that or not? Though it's look like simple, but it's little lot of calculation. And if you know how to simplify in terms of the positive and negative sequence components in terms of multiplying with factor alpha. Everybody is getting the idea how to do this problem now. And there can be n number of ways also. This is how you want to proceed. This is just one way of doing it. So please do the calculation part again for this question also. So just read this question also. I will give you the complete picture. I'm just hiding myself for one moment. So I think it's done. Now see, basically he's asking you that the single phase line to ground fault current, its limiting case is given as 3.75 per unit. It should not be more than this, 3.75 per unit. This is the limiting case. How you can write the single phase line to ground fault current? It is 3 times EA upon X1, X2, X0 plus 3XN. Fault impedance is not mentioned because so fault impedance is 0. So it is a bolted fault. So it is going to be 3.75. EA you are going to take as 1 per unit. Put the values of x1, x2, x0. So it becomes 3 and it becomes 3.75. X1, x2 is mentioned as 0.2, 0.2. So it becomes 0.4 plus what is x0? X0 is 0.1. So it is 0.1 plus 3xn. So you can simplify it as 3 upon 3.75 minus, it becomes 0.5. Okay. 3xn. Just cross check the calculation. I think everything is okay. Because 3 upon 3.75 minus 0.5, it comes out to be negative. It should not be negative. Let me cross check the values. Please check. Just cross check whatever the calculation I'm doing, it's okay. Everybody is getting 0.1, but it should be coming negative now because this is 3 upon 3.75. It should be, oh, I'm sorry. It is going to be less than 0.5 now. More than 0.5. Okay, sorry. I was a little confused. 3 upon 3.75. You must be getting very close to, I think, 0.9 something. So that's okay. So how much you are getting as xn? 0.1. Perfect. Just put the correct answer. See the next question. So this was about the power system. Now we are starting with machines. Machines, we are going to have 6 questions. 3 1 mark and 3 2 mark questions. Let's read the question carefully. Machine questions, I have taken little lengthy questions. Okay, so don't be afraid of the length of the question. If you know the concept, you can do it. Sometimes this trick is also followed in the real gate examination also. Machine question, they're not asking difficult, they're asking lengthy questions. So he's saying there is a 220 volt 50 kilowatt 1000 rpm shunt motor with armature resistance and has a rated line current 68 ampere and a rated, it is a field current. It is a field current of 2.2 amperes. He is saying the change in field flux required to obtain a speed of 1600 rpm while drawing a line current of 52.8 amperes and a field current of 1.8 amperes. So one beautiful thing with this question is that for both the cases, case 1 and case 2, he has already mentioned what is the line current and shunt field current. So if you see the shunt motor, if you see the shunt motor, this is the terminal voltage. This is from where the line current is coming. This line current provides the armature current and the shunt field current. This is the shunt field resistance. This is the armature resistance. This is the back EMF. Yes or no? So in the first case, can you tell me what is the armature current? It is going to be the line current in the first case and shunt field current in the first case. So IL1 is given as 68 amperes. One is the shunt field current is given as 2.2 amperes. It is 2.2 amperes. Just solve this. Because once you get very quickly, Ashok, you solved it. That's great. So just solve this IA1 and tell me what is the value you are getting, and you can find EB1. It is going to be V minus IA1 RA. Why we are relating the back EMF? Because if I have to relate the speed, then always I have to relate the speed with respect to the EMF only, back EMF only, or EMF only. So the terminal voltage is mentioned as 220 volts, is mentioned as 220 volt minus IA1 how much? 65.8. And what is the armature resistance? 0.25 ohms. Can you solve this? In the second case, the armature current is going to be the line current in the second case minus shunt field current in the second case. So line current in the second case is 52.8 minus what is the shunt field current? 1.8. So it becomes 51 ampere. Back EMF Raghu and Krishna both are getting 203.55, 203.55. And what about the back EMF in the second case? It should be V minus IA2 RA. So 220 minus 51 into 0.25. Yes, what is EB2, back EMF for the second case? Now, if you see the speed also, speed is 1000 RPM for the first case, and speed is 1600 RPM in the second case when he is saying the field flux is changing. So, can you write the back EMF? Yes, it is K phi omega, where K is Pz upon 2 pi A. So, how you relate back EMF as phi into N? So, if you write EB2 upon EB1, it becomes phi 2 N2 upon phi 1 N1. N2 speed is 1600 RPM. N1 speed is 1000 RPM. EB2, EB1 you have just solved. Can you relate phi 2 and phi 1? Yes or no? EB2 is 207.25 as per Raghu. Others also please cross check. 207.25 volt. So just put all these values and you will be getting the relation between phi 2 and phi 1. So can you tell me the percentage change? Yes or no? Can you solve this? Put the values for EB2 and EB1, N2 and N1 and find the ratio for phi 2 and phi 1 and find the percentage change. Because the speed is increasing, so just by logic you can say the flux must be reducing. N1 is 1000, na? N1 is 1000. Ashok has calculated 0.1818 decrease. So I think he is correct. He must be getting this. Increase is automatically cancelled because you know the speed is increasing means definitely the flux is reduced. Anyways, so you can find it like this: phi 1 minus phi 2 upon phi 1. See the next question. A 4-pole separately excited wave-wound DC machine with negligible armature resistance is rated for 230 volts and 5 kilowatt at a speed of 1200 rpm if the same armature coils are reconnected to form a lap winding. What is the rated voltage and power? So this question simply requires your understanding in terms of the machine, how it is constructed. So when it is wave connected, first case, when it is wave connected, then what is the situation? There are two parallel paths. Are you getting that? Something like this. Now is giving you the rated voltage, that is 230 volts, and power is 5 kilowatt. So it is 230 volts, and current is going to be, suppose here, IC and IC, current in one parallel path, and total current is going to be the armature current. So armature current is here is 2IC. Now when you have the lap connected winding, armature winding, number of parallel paths is equal to number of poles. How many number of poles? 4. Yes or no? Now you understand what is the voltage available for this one coil only. It is going to be half of 230, that is 115. So this is 115 volts. But if you see in terms of current, now the current in each parallel path is going to be IC here, IC here. So it becomes 4IC. Now 4IC is what? Armature current is 2 times IA1, the current armature current in the first case. Yes or no? But you understand one thing. When the voltage is reduced to half, the current is 2 times, current is doubling. It means the power is not changing. Whatever reconstruction you want, you can do. You can connect it as wave, you can connect it as lap, but the power you can't change. Either you can increase the voltage or decrease the voltage. Either you can increase the current or decrease the current. Voltage increases, current decreases. Current increases, voltage decreases. But power you cannot change. Yes, Vijit, I will share the PDF. Don't worry. Okay. Yesterday I could not do it, but today I will do it. So from the options now easily you can calculate that power is not going to change. So power will remain same as 5 kilowatt. These two options wrong, and EMF is going to be 150. Is it clear, everybody? It's okay. It's okay. See the next question. Just read this question carefully. Is it visible to all of you? Question is visible to all of you. Now this is a good question, good quality question. I hope the question is visible to all of you. Options are not visible. Question is visible now. Yes, Rohit. Okay. I can also watch it parallelly on my YouTube, so don't try to fool me. Okay. Let's see what the question is saying. A 250 volt 50 kilowatt shunt motor has a maximum efficiency of 88%. At this time, the speed is 700 rpm. And at this point, it is delivering 80% of the rated output. 80% of the rated output. The resistance of its shunt field is mentioned as 100 ohms. He is saying determine the efficiency when the motor draws a current of 78 ampere from the mains. See, whenever you want to calculate the efficiency, what are the important things you require? How you calculate the efficiency? Output power upon input power. How you can write input power? You can write input power as output power plus losses. Yes or no? Now losses you are going to divide into two parts. Losses are going to be two types, that is variable losses and constant losses. Now variable losses are going to be I square R losses and the constant losses are going to be rotational losses and shunt field loss. Shunt field loss. So if you know all this information, then you can calculate efficiency at any load. So do you know what is this R? Do you know what is this R? You don't know the armature resistance. So the first thing you have to do is you have to find the armature resistance. Then do you know the constant losses in terms of rotational losses and shunt field losses? You have to find it. Yes or no? So let us first write. Suppose you got the efficiency. Okay. You got the efficiency and output power. Can you tell me the losses? Yes. Efficiency you can write as output upon output plus losses. When I say losses, it means total losses. So you can write it 1 upon eta like this. You can simplify it as 1 plus losses upon P output. So losses becomes P output times 1 upon eta minus 1. Can I write like this? What is P output? P output is 80% of the rated output. What is the rated output? 15 kilowatt. So it becomes 15 kilowatt into 0.8 because it is 80%. 1 upon what is the efficiency? It is 88%. 0.88 minus 1. Can you calculate the total losses here? Can you calculate the total losses? Everybody just tell me. Calculate it. Krishna, what is the problem? You tell me exactly what is your doubt. So you must be getting 1636 watt. But this total losses again comprises variable losses and constant losses, and at the maximum efficiency condition, variable losses is equal to constant losses, and that is equal to 1636. 1636 divided by 2, because they are equal na. So total losses divided by 2 is going to be that much. So it is going to be how much? 2 8 16, 2 एकम 2 16, 2 8 16, 818 watts. Now constant losses, okay, we are okay with that. Constant losses, if you write in terms of variable losses are going to be IA square RA loss, that is given as 818 watts. Yes or no? And what is the armature current? Can you tell me? What is the armature current? Armature current you can find from here, from the line current. Line current is going to be 15 kilowatt. Just a moment. Wait. That is the output now. So first we have to find the input power. Input power means the power taken by the motor from the supply. So what is going to be the input power here? Input power is going to be output power plus losses, yes or no? So it becomes 15 kilowatt multiplied by 0.8 because 80% of it, and total losses is 11636, yes or no? So it becomes how much total? As per my reference, it should be 13636 watts. Yes or no? Now you know the voltage and you know the input power. Can you calculate the line current? Yes. Line current is going to be 13636 divided by the voltage is mentioned as 250 volts. Okay. 250 volts. So what is the line current you will be getting? As per my reference, you must be getting 54.54 amperes. Now, do you know what is the shunt field current? Because it is a shunt motor. So terminal voltage is 250 and shunt field resistance is mentioned in the question. That is 100 ohms. So easily you can find it. It becomes 100. So it becomes 2.5. So what will be armature current? Line current taken from the supply minus shunt field current. That is 54.54. 54.54 minus 2.5. So if you solve this, armature current you will be getting as 52.04. Yes, everybody. Now this armature current is the armature current for the first case. So you can put it here in this equation and you will get the armature resistance. So armature resistance you will be getting as losses is 818 divided by IA1 square. So 52.04 square. To solve this, you must be getting 0.301 ohms. Everybody just tell me up to now, is it clear or not? Up to now, everybody is okay. Now, once you get the armature resistance, for any current, any line current, you can calculate what is the variable loss. Constant losses will remain constant, so you can calculate efficiency at any point. Now, what is the line current in the second case? The line current in the second case is when the motor draws a current of 78 ampere from the mains. So in the second case, the line current is 78 amperes. What is the armature current? 78 minus shunt field current is 2.5. It is not changing. Field resistance not changing. How did you write the input power? Input power I have written output power plus losses, total losses. Output power is mentioned 80% of the 15 kilowatt is the output, rated output, plus 1636. Are you getting, Mr. Ajay? Yes or no? Okay. Okay. So, can you calculate what is IA2 now? And if you can calculate IA2, Can you calculate variable losses IA2 square RA? Please calculate it. Constant losses, you know. Can you calculate the efficiency now? For the second case, what is going to be the efficiency? Yes, everybody. What is the current armature current in the second case you are getting? 0. Sorry. It is 0.5. Okay. And 75.5. So if you calculate this, it becomes 75.5 whole square multiplied by 0.301. So you will get the variable losses somewhere around 1718 watts. So now can you write the efficiency? Efficiency will be output upon input. Now input this time, you can clearly write like this also. 50 volt is the voltage and 78 ampere is the current taken from the line. Output you can write as 250 volt multiplied by 78 minus losses. Input minus losses will be output. What are the total losses? Variable losses plus constant losses is 818. Constant. Multiply by 100, you will get the efficiency. As for my reference, you must be getting somewhere around 87%. How many people are getting this confidently? Everybody is getting now. Any doubt you can ask me. Okay, let's go to the next one. So I'm hiding myself, just read the question carefully. This is also a little lengthy question. I'm hiding myself, just read the question carefully. So everybody done with the question reading? Everybody done with the question reading? So I hope it's okay. Now just see what the question is saying. The question says 230 volt 1150 rpm DC motor equipped with compensating winding has armature resistance is mentioned. I'm writing here armature resistance is mentioned 0.188 ohms. Operating as a shunt motor, the rated output is obtained with the line current is mentioned 74.6 amperes and It should be shunt actually, okay? Because he is talking about the shunt motor, so it should be shunt, not series. So current in the shunt field winding is going to be 1.6 amperes. He's saying the same constant torque is to be supplied. It means torque is going to remain as constant. Torque will remain constant. When this machine is arranged to operate as a long shunt cumulatively compound motor. Long shunt cumulatively compound motor. At this load condition, the series field winding having resistance. So in the second case, this was the first case as a shunt motor. In the second case, series field winding resistance is 0.06 ohms. Contributes a 25% increase in the pole flux. So phi 2 is 1.25 times phi 1. Yes. He's asking what is the speed of the compound motor. Now please understand. This is case 1 when it is as a shunt motor. Very easy question, just it's a little lengthy. In the second case, it is a compound motor. It is a compound motor. And it's not just a compound motor, it's a long shunt cumulatively compound motor. Okay, so what is the meaning of long shunt? Compound means both shunt and series fields are present. This is armature. This is series field. This is the terminal. This is the shunt field. Now when it is long, long means both the armature and the series field it has to cover. So it is connected like this. Is it clear, everybody? Okay. So suppose in this case, the line current taken is IL2. So it will divide into again two parts, ISH2 and this is IA2. Is the same current which flows through the series field winding, and this is the armature winding IA2, this is RA, this is shunt field resistance, and this is the back EMF in the second case. Everything must be crystal clear now. Now for the shunt machine, for the shunt motor, so this is your terminal voltage. It is going to supply some line current in the first case. This line current will provide the armature current. And this is the shunt field current. Shunt field resistance. And this is the back EMF in the first case. Yes or no? Everybody is getting that or not? Now, see, basically, what we have to do, you find the back EMF. And you know back EMF is directly proportional to flux and speed, because flux is changing, speed is changing, back EMF you have to relate. So you have to write EB2 upon EB1 as phi 2 N2 upon phi 1 N1. Are you getting that? Do you know the relation between phi 2 and phi 1? Yes. Phi 2 is 1.25 times phi 1. Do you know the relation between N2 and N1? No. Because N2 you have to find. The speed of the compound motor you have to find. So N2 you have to find. What is N1? N1 is 1150 RPM. So N1 is 1150 RPM. N2 you have to solve. Yes. Phi to phi 1 relation you know, N2 you have to find, N1 you know. EB2, EB1 can you write? Yes. Now what is the armature current here? IA1. Can you tell me? It is mentioned, everything is mentioned. In the first case, line current is mentioned, shunt field current is mentioned. What is the armature current? IL minus ISH. It is IL minus ISH. What is IL? 74.6 minus 1.6, it becomes 73. 74.6 minus 1.6, it becomes 73 amperes. So you know what is IA1. What is the armature resistance mentioned? Yes, 0.188. So very easily you can write what is the back EMF in the first case. Terminal voltage. What is terminal voltage? 230 volts. So it is 230 volts minus IA1, that is 73, into what is armature resistance? 0.188. So if you solve this, EB1, how much you are getting? I think you must be getting 216.28 volts. Everybody please confirm. And in the second case, what is given? Okay. So series field resistance is mentioned. Okay. Series field resistance is mentioned. So if you know the terminal voltage, can you write EB2? Yes. It is going to be V minus IA2, that is RA plus R series. So you know what is the terminal voltage? Terminal voltage is mentioned 230 volts. So it becomes 230 volts. You don't know what is the current. How to find the current? You have to relate the torque. T2 is equal to T1. Phi 2 N2 is equal to phi 1 N1. Okay. Now you know. Sorry. It should be current. It should be current. It should be phi 2 IA2, phi 1 IA1. So you can write IA2 as IA1 upon phi 2 upon phi 1, which is 1.25 times. Is it clear, everybody? So you can put the value of IA. What was IA? 73 amperes, 1.25. So you can find what is IA2. So as per my reference, you must be getting IA2 as 58.4 amperes. So if you get the IA2 very easily, you can calculate EB2, and this is 0.188 plus, and the series field winding resistance is mentioned as 0.06. It is 0.06. Solve this. You must be getting EB2 as 215.516 volts as per my reference. So now you get the back EMF for both the cases. You know the flux relation. Very easily you can find N2. As per my reference, you must be getting N2 as 916.79 RPM. Is it clear, everybody? Ashok 916.6. Perfect. So what is the correct option? C is the correct option. You might not be able to view it behind me. Okay. See the next question. This is visible for everybody. Yes, C is the correct answer. Approximately you are getting. Just see this question. I hope it is okay. Let's read the question carefully. Is it clear, everybody? I hope it is visible. So there is a three-phase star connected 220 volts 7.5 kilowatt 60 hertz 6-pole induction motor has the following parameters per phase referred to the stator. So already they have given you the referred value. The rotor side values they have already referred. So you don't need to do anything in terms of referring the rotor side quantities to the stator side quantities. Core losses and friction and windage losses are mentioned as independent of the load and for a slip of 2%. Okay, so now slip is 2%. He is asking determine the efficiency when the motor is running at a rated voltage and frequency. Now this type of question, you see the data is given in a very discrete manner. He is asking you efficiency. You know what is the slip. Parameters are mentioned. Core loss and friction and windage losses are mentioned. So can you write first the equivalent circuit? First you draw the equivalent circuit because that will make your life little easy. So once you refer it to the stator side, it becomes like this. So basically the idea here is why we are taking the magnetizing reactance only, not the resistance. Because if you include the resistance now, it becomes quite bulky and it becomes very complex. So that we have separated as core losses because that represents the core loss. So core loss we are taking separately now. So you see here, this is going to be short circuited all the times. And this is your rotor and this is R2 dash. This is R2 dash upon S and this is X2 naught dash. This is R1 JX1 and this is JXM. So the first thing that you can do is you can find what is this parallel combination. Suppose you call it as ZP. So ZP is going to be how much? It is going to be the parallel combination JXM parallel R2 dash upon S plus JX2 naught dash. Okay, if you solve this, it's going to be a little lengthy, so I'm giving you the reference values. You can cross check it later on. 5.42 plus J 3.11. Otherwise, we'll not be able to complete the session in time. Okay, that is the reason. So just see this parallel combination. You will be getting the parallel combination net impedance like this. Now you see, if you have this R1 and JX1, this is also mentioned. You know what is the per phase stator voltage applied. Can you tell me what is the current per phase current? Yes or no? Can you write the per phase current here as I1 is equal to, this is suppose Z1, okay, stator per phase impedance. So it becomes V1 upon Z1 plus ZP. Yes or no? What is V1? What is V1? 220 volt, it is line RMS. So you can write what is V1. 220 angle 0 degree. But because it is three phase now, so you have to divide it by root 3 also to make it per phase. 220 divided by root 3 angle 0 degree. Now Z1 and Z2, sorry, Z1 and ZP, you know. ZP you have just calculated. What is Z1? So Z1 is given here 0.294 plus J 0.503 in terms of ohm. Yes or no? So if you solve this, you find this current I1, you will be getting it as per my reference 18 0.79 angle minus 32.31 amperes. The power factor becomes 0.845 lag. Because it is lagging, minus that is 1. Is it clear, everybody? Now, once you have the current, then you can write the rotor copper losses. How you are writing the rotor copper losses? It is 3 times I1 square, and it is going to be R2. Sorry, it's not R2 basically. You have to write the equivalent resistance for this parallel connection. That is 5.42 ohms. Okay. So right here, 3 times I1 square, 5.42. Now this is the this is the rotor copper loss. Yes or no? Sorry. This is not the rotor copper loss. This is the air gap power. Just a moment. It is the air gap power. Why we are saying air gap power? Please understand once. After this stator, whatever power is going here, this is air gap power. Now, air gap power will be divided into two parts, the rotor copper losses and the mechanical power developed. Then mechanical power developed will be divided into two parts, the final output at the shaft of the motor and the rotational losses, windage and friction loss, friction and windage losses at the rotor. Okay, so this is air gap power. So this air gap power, I think everybody is okay with this explanation. Please remember this. When you are directly finding it with the rotor resistance, then it will be rotor copper losses, but we are not finding in terms of rotor resistance. We are talking in terms of this equivalent circuit of this, okay? Apart from the stator, whatever is remaining. So you know what is the I1 value. You can calculate this air gap power PG. As per my reference, you must be getting it 5740.82 watts. Okay. Now this is the air gap power. The slip is given as 2%. Slip is given as 2%. So can you directly write the mechanical power developed? Can you directly now write the mechanical power developed if you have the slip and if you have the air gap power? Yes. Use the formula here. The mechanical power developed is going to be Pg1 minus S. It is 5740.82. 1 minus 0.02. To simplify this, as per my reference, you must be getting 5626 watts. What is the final output power? It is the mechanical power developed minus rotational losses. Now, rotational losses are mentioned in the problem. Core losses and friction and windage losses, 403 watts, independent of the load. And that is the reason we have separated them and we have not shown them in the equivalent circuit. So it is 5626 minus 403. So the output power final which you are getting is 5223 watts. I hope you are getting this. If you want, for sake of your reference, I can tell you the power input to the three-phase induction motor I am saying. Okay, so it has two components. That is the copper loss in the stator. So whatever is remaining is air gap power. Air gap power you are dividing into two parts. That is rotor copper losses and mechanical power developed. Mechanical power developed, again, output shaft power and rotational losses. This is the complete picture. So you have the final output. So can you write the efficiency now? Yes. So efficiency is going to be output, that is 5223 divided by under root 3. Voltage is there, 220 volts. Current is there, 18.79. That is the I1 value, 18.79. And you know the power factor also, 0.845. That is the total input power. You know the output power. Multiply 100, you will get the efficiency. So as per my reference, you must be getting 86.33% as the final efficiency. Please cross check this value and tell me if you are able to follow this. It is 6.32. Perfect. Yes, 86.32. See the next question. A three-phase, two-pole, 3000 RPM star-connected cylindrical rotor turbo generator has 60 slots. Maximum flux density in the air gap is 1.32 Tesla. Mean air gap diameter. Effective axial length. Number of turns per phase is 10. Calculate the line-to-line voltage if coil span is 150 degree. Now this is a synchronous generator question basically. So basically if you have to find the EMF, what is the procedure? If you have to find the EMF, what is the procedure? You write the EMF per phase as, that is the winding factor, okay, multiplied by root 2 pi f phi, and this is number of turns per phase. Yes or no? What is winding factor? It is multiplication of pitch factor and distribution factor. So separately you have to find the pitch factor and distribution factor. Frequency you know, okay. 2 pole 3000 RPM. So what is frequency? Number of poles, synchronous speed divided by 120. So 50 hertz. You know the frequency. Do you know the turns per phase? Yes, number of turns per phase is 10. You know that. Do you know the flux? You don't know the flux. This is the main twist of this question. If you're not aware with this, you may do the mistake. The flux that you are writing, you have to write in terms of average flux multiplied by the area. Multiplied by the area. Area per pole. How you are writing the average? If you know the peak value, okay, if you know the peak value, then you can write the average value as 2 times Bm upon pi. So it becomes 2 by pi Bm. And what is the area per pole? The total area becomes pi dl and divided by number of pole is P. So from here you can calculate the flux which you are using in this equation. You can solve this. I don't have a reference value for this. Now what is Kp? Please understand. Kp is pitch factor is cos alpha by 2. How we are finding alpha? Pole pitch is 180 degree. What is the coil span? It is 150 degree. So 180 minus 150 degree, it becomes 30 degree. So it becomes cos 15 degree. You can solve this. What is the distribution factor? It is sine m beta by 2 upon m sine beta by 2. What is M here? Number of slots per pole per phase. So 60 number of poles per phase, 3. So it becomes 10. Now what is beta? 180-degree electrical number of slots per pole. So it becomes uh, slots per pole. So it is 2. So you can solve beta. So it becomes 6 degree. You have to just put the values now. So you will be getting Kp and Kd. You have this phi also you have calculated. So Kw is Kp into Kd that you have got. You have all the values, you can just put it. But what you are getting is the EMF induced per phase, and he is asking line to line voltage. So at the end, you have to multiply by root 3. Can you do this? Everybody. Can you do this, everybody? So if you put the values, if you solve, you must be getting C as the correct option. That is 15.75 kilovolts. Is it clear? So now we'll be talking about the verbal ability part. In this, I have 5 questions, 1 question of 2 marks, and 4 questions of 1 mark. Okay. But stay connected because after me, Rakesh sir is going to bring a lot of interesting questions. So let me just inform him because verbal ability is going to be very small. Okay. It's okay. It's okay. See, we have to take care of that. No? You have to take care of the total marks. That is why. So everybody just stay connected. I have informed Rakesh sir. Just 5 more minutes from my side, and then you will be directly facing Rakesh Talreja sir, and he is going to take some more important questions from his subjects. So this is basically a reading comprehension question passage. He is saying mosquitoes pose a threat to human health. Controlling mosquitoes using chemical may be undesired consequence. For example, in Florida, authority position have used genetically modified mosquito to control the overall mosquito population. It remains to be seen whether these novel approaches has any negative consequences. Okay. Now he's asking which one of the following options is correct logical inference based on the intervention in the passage. Option A. Using chemical to kill mosquito is better than using genetically modified mosquito because genetic engineering is dangerous. So nowhere in the passage, whenever you are solving the questions related to the reading comprehension, you please be very careful. Don't add information from your side. Whatever is written within the passage, that is going to be correct. So anywhere it is not written that chemical is better than genetically modified because genetic engineering is dangerous. So option A is wrong. Option B, using genetically modified mosquito is better than using chemical to kill mosquito because they do not have any side effect. No, this is wrong because throughout the passage he is saying we are not aware what is going to be their side effect for the genetically modified methods. Option C, using chemicals to kill mosquitoes may have undesired consequences, but it is not clear to using genetically modified mosquitoes has any negative consequence or not. So see, he's saying controlling mosquitoes using chemical may have undesired consequences. So it means there is no clarity about the genetically modified consequence. Yes, 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 yes. But I have to explain others also now. So C is going to be the correct option. But still you check D also. Both using genetically modified mosquitoes and chemicals have undesired consequences and can be dangerous. So this is also not clear from the passage. C is correct one. Next question. Some people believe that what gets measured improves. Okay, important statement. You can use it in your life. Some others believe that what gets measured gets gained. One possible reason for the difference is the belief in the work culture in organizations. In organizations with good work culture, metrics help improve outcomes. However, the same metrics are counterproductive in organizations with poor work culture. Which of the following is correct logical interference? A says metrics are useful in organizations with poor work culture. This is wrong because he is saying metrics are good in those organizations where there is good culture, good work culture. But poor work culture organizations, they are counterproductive. Counterproductive means they are inefficient. Metrics are always counterproductive in organization. This is wrong. Whenever you are getting these extreme words, you understand this is wrong. Option C, metrics are never useful in organizations. This is wrong. Option D, metrics are useful in organization with good culture. D is the correct one. D is the correct one, Baba. Okay. See the next question. Rice, a versatile and inexpensive source of carbohydrate, is a critical component of diet. It's not diet. Worldwide, climate change causing extreme weather poses a threat to the sustainable availability of the rice. The scientists are working on developing green super rice (GSR). Which one of the following can be inferred based on the information given in the above passage? GSR is an alternative to regular rice, but it grows only in extreme weather. Now, please understand, as per the question, directly you cannot observe, but indirectly you can observe that this statement, whatever information is there, it is given in the passage. He is saying GSR is an alternate to regular rice because he is saying in the second last statement, the scientists are working on developing green super rice. Yes or no? It means it is one alternate to the conventional rice, regular rice. But it grows only in an extreme weather. Now see, on one part you are saying the regular rice, it poses a threat to the sustainable availability of the rice because of climate change, extreme conditions. Yes or no? So what scientists are doing, they are going for green super rice. It means green super rice is going to be sustainable. That is why they are going for it. So indirectly what is written in statement A, it is correct. So we are not saying outrightly it is incorrect. Option B. Regular rice will continue to provide good yields even in the extreme weather. This is wrong. It is not mentioned anywhere. Option C, GSR may be used in future in response to the adverse effects of climate change. This is also a possibility. Option D, GSR grows in an extreme weather, but the quality of production is lesser. This is wrong because there is nothing mentioned about the quality of production. Okay. Now see, we have to decide from A and C. So let me just read the passage again. Rice is saying GSR is an alternative to regular rice, but it grows only in an extreme weather condition. So rice, a versatile, inexpensive source. So A is going to be wrong because he's saying it is growing only in the extreme weather condition. So this is wrong. Okay, because there is no information given in the passage that they are only growing in the extreme weather condition. Climate change causing extreme weather poses a threat to sustainable availability of the rice. The scientists are working on developing green super rice. It means in extreme weather conditions they can grow, but it is not that only in extreme conditions they can grow. But C is going to be 100% true because scientists are still working on developing this rice, means it may be used in the future in response to the adverse effect of climate change. So C is the correct answer. Is it clear, everybody? See the next question. So basically there are two words, look like same but have a different meaning. The fair is too high to be considered as fair. So fair and fair. C is the correct option. Question number 49. As you grow older, an injury to your heel may take longer to heal. So the last one is heal, 100%. So first should be HEEL. So D is the correct option. So this is all from my side, friends. I hope you enjoyed the session. Now, Rakesh Talia sir is going to join you. But before that, let me just give you some information about the GATE and Engineering Services test series. Get unlimited access to the full-length mock subject-wise test. Link is given in the description. These are the important features of this test series: 60 plus text covering the GATE and EAC, detailed mock analysis, virtual scientific calculator, 4,000 plus practice questions, all India open mocks, and this all is curated by GATE experts. So friends, just stay connected for a small glitch. Stay there, and your favorite, my favorite, Rakesh Talleja sir is going to join us soon. Okay. So just give me a moment.
Hello, 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 hello. Hello, 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 everybody. Hi, guys. Good evening, everyone. Welcome to the GATE mock test electrical engineering, and I am good. Hope you are also good. All right. Okay. All right. So, guys, we are live since morning. It's almost 6 hours. Hats off to your patience, because in the mock test we don't have the breaks and all as well. Okay, it's much better, Raghu Rao. Okay, so in the mock test you don't get any break, you don't get any time to take any refreshment or something like that. Yeah, it's online, you may be taking some juice, fruit, something like that. But let's quickly continue, and I'll be ending this mock test taking 3 subjects. Number 1, electromagnetics, which of course is a lesser weightage for electrical branch, but still even though it may be 5 to 6 marks, it's going to play a crucial role. Then I will take mathematics and aptitude. From the aptitude, verbal questions are already discussed by Ashutosh sir, so I'll be discussing about the remaining, that is the questions based on quantitative analysis and the logical reasoning part. Yes guys, so just a minute, I shall just get started. Okay, so that's what I've updated to you. EMT, maths and aptitude, this is what we are going to cover up in the session. In case some of you watching the session live still forgotten to like the session, so do not forget to like the session. Yes guys, and then let's get started. Chalo guys, so all ready. First question from the electromagnetics, here it is coming on your way. The value of capacitance for concentric spherical shells of the radii 2 cm and 5 cm having the perfect interior dielectric of epsilon r is equal to 10 is dash picoseconds. Okay, what should be the value of the capacitance for this concentric spherical capacitor? The formula for capacitance, now guys, let me be very straightforward that this is a mock test and we are not here to derive anything. We are here to apply our concepts and formula, right? Okay, so I'll be going in a quick manner so that we look into the remaining questions. I think 16-17 questions are there with me, including all three subjects, so we try to cover it in a good amount of time, a small amount of time. Okay, so I'll request all of you that whenever I give the question, it's a small suggestion from my side, whenever I give the question, as soon as you see the question on screen, put the sound on mute from your side, so that by the time I solve, you are also solving your own, and then let's match the answer. Okay, let's match the answer. This time, working in this parallel mode, we'll be able to save the time as well. So I'll request once again, whenever you see a fresh question on screen, mute, don't listen to me. First solve your own. If you don't know that concept at all, then you can wait. Okay, but first solve on your own, match your answers. If it is match, put +1. If it is 1 mark, +2 if it is 2 marks. If it is wrong, immediately put the minus mark. Keep a track of your marks, right? And if you have got wrong marks, then you can look into the solution. By the time solution will be ready on your screen. We'll follow this strategy, guys. Okay, so what is the capacitance, guys? It is given by the formula 4 pi epsilon upon 1 upon a minus 1 upon b, where a and b are the radius of the inner and the outer spheres. Is that clear, everybody? All good. Chalo. Okay, so what is the values now? 4 pi. What is going to be the epsilon? That is 10 epsilon naught, because relative permittivity is given. So 10 into epsilon naught. Let's use epsilon naught as 1 upon 36 pi 10 raised to the power minus 9 is divided by 1 upon a. A is 2 centimeter. Let me directly convert to the SI unit, 0.02 minus 1 upon the 0.05. Okay, so eventually this is cancelled as 9. So I have 10 by 9 is further divided by 100 by 2. That's going to be 50 minus 20 into 10 raised to the power minus 9. Okay, and we want it in picofarads. ये भी ध्यान रखना है. Let's quickly calculate the numbers. And then further I have divided by the 30. Yes, so this is actually turning out to be 0.037 10 raised to the power minus 9 farad. Okay, multiply by 1000, so 10 power minus 12 will come automatically, and then that is the picofarad. So answer in picofarad is the 37. Next question on your screen. Okay, next question on your screen coming up here. If the electric field E is equal to 2ax minus 3ay plus 4az, then the work done in moving a 7 coulomb charge by a distance of 3 meter in the direction of a vector. All right, sir. In the direction of a vector. Okay, sir. So there is the electric field, which looks like a uniform field here. Then the work done in moving, okay, then the work done in moving a 7 coulomb of charge, okay, let's say from some point A to some point B. Okay, the points are not given, but rather they have given the direction. Okay, right, let's say this is some point A, this is some point B. Okay, but you are moving in the direction of some vector and by a distance whose magnitude is 3. Okay, Acha. Now work done, as we all understand, is usually the integral f dot dl. As per the basic concepts of physics, you know, the work done is line integral of the force vector, where force is equal to Q into E, right? F dot dl or F dot dr, whatever you want to write it, one in the same thing. And F by the Coulomb's law, okay, because there is the presence of electric field, the force experienced by this charge will be given by Q into E. So this becomes QE dot dr. But here, as you are able to see, in the given situation, there is a uniform field, and because of that uniform field, okay, it's like uniform, it's like constant, so we'll only be left with integral dr, and that is written as r, so it is actually E dot r. Okay, for the uniform field case, we can write it as E dot r. Okay, now what is the value of the work done? Okay, that is given by the value of the charge 7 into the electric field that is mentioned, that is 2ax minus 3ay plus the 4az dot product with the r, whose distance magnitude is 3, and there is some direction vector also, ax minus ay plus az. Is that clear? Yes. Okay, so let's take it up. That's going to be 21. Then this is 2 into 1. Then 3 into 2. That is going to be 6 and plus 4. That is what it looks like. Huh? 2 into 1 and then minus 3 into minus 1. Oh, that is plus 3 only. So this is 3 and then 4 into 1. Okay, so this is 21 is total multiplied by 5 plus 4, 9. So 189 joules. 189 joules is the answer. Moleshwan, just check it up. Maybe a factor of 3 you have missed. Yes, 189 joules is the answer. 189 joules is the answer. Correct? 189 joules is the answer. If you have got that correct, it was an NAT question. You can put 2 marks. In case you haven't got correct, there is no negative mark for this because it's a NAT question. Right, Moleshwaram. Correct. In cylindrical coordinate systems, the magnetic flux density B is given to you 2 by R A phi, or you can also call it as, normally, cylindrical coordinate systems, people remember it as rho phi z. So it's like 2 by rho A phi. What is the total magnetic flux in Weber crossing the plane phi equal to 45 in the region defined by 0.5 less than radius less than 2.5 and 0 less than z less than 2? Okay, it's a basic question. Okay, cylindrical coordinate system, it's a very basic question. Okay, and EMT is more or less coming very fundamental only for EEE. So that's the level I wanted to keep, not unnecessary exaggerating the what we say, the depth of the question. This is what is expected in EMT from EE mostly. Ab dekho, what is the total total magnetic flux? That is of course the surface integral. That is of course the surface integral of the flux density vector. Now the flux density vector B. The flux density vector B is given to be in the azimuthal direction. This is in the A phi direction. This is in the azimuthal direction. That is the A phi direction. What is the ds then? What is the ds? Okay. ds. Now, actually we are taking dot product. So we will consider only that component of ds which is along the A phi direction. Rest others will be cancelled. Okay. So along the azimuthal direction, that is along the A phi direction, ds is given by, in the cylindrical coordinates, it is given by d rho dz a phi. D rho dz a phi. Correct. So using these values, the phi is gonna be double integral, this evaluation of surface integral 2 by r, that is 2 by rho a phi, 2 by rho a phi, mul dot product with d rho dz a phi. Of course, this is in milli. Okay, यहाँ पे 10 power minus 3 भी आएगा, that's in milli. Okay, so I can take that 2 into 10 raised to the power minus 3, a phi dot a phi is 1. Now d rho upon rho, 1 upon rho integral ln rho, dz integral simply z. Put down the limit of z 0 se 2, put down the limit of rho 0.5 se 2.5. Okay, that's it. Okay, so this is 2 into 10 raised to the power minus 3 into upper limit log of 2.5 minus log of 0.5 into z ka upper limit 2, lower limit is 0, right? So that becomes 2 to the 4, 4 into 10 power minus 3, log a minus log b is log a by b, so that is going to become log of 5 actually. Okay. So final answer 6.43, and answer is also expected in milliweber, correct? So this is turning out to be kitna aaya tha? 6.43, sir. So 6.43, 10 power minus 3, I will call it as milli, unit of flux will be Weber. So 6.43 milliweber. 6.43 milliwebers it is. Correct everybody dear? Correct, everybody? Right. All right. So, as we all know that EMT has a relatively very smaller weightage in electrical. So, this EMT I kept for 5 marks. Somewhere around 4 to 6 marks we can expect in the EMT. Looking into the recent trend, expect 4 to 6 marks in this subject. Looking into the recent trends. So, I have kept 5 marks. It was 1 question of 1 marks and 2 questions of 2 marks. That made total 5. 1 question of 1 mark, remaining 2 questions of 2 marks each. Okay, but and the level I have taken for this one is easy. The level taken was easy for EMT. Now let's move ahead to the next session. The next session is the engineering mathematics. Okay, na for double itna. But you have studied well. While you have studied earlier, you have studied everything. So don't worry. Even if they go in depth, there is not a problem for you, Raghu. Ab ye dekhna. Okay, now here there is no expectation. There is the fixed marks. Engineering mathematics, that is the fixed for 13 marks. Isme to kuch hai hi nahi kahani. Right? Okay. For EC branch, around 8 to 10 marks. 8 to 10 marks, sometimes little more also. But normally 8 to 10 marks is the average expectation, Shiva. Okay, so 13 marks fixed. Okay, so I have brought this for 13 marks because that is the fixed weightage. In this, you will be facing 3 questions of 1 marks. And you will be facing 5 questions of 2 marks. Clear? You will be facing 3 questions of 1 marks and the 5 questions of 2 marks. Here it is the first question. 1 marker, first 1 marker question. The inverse of a matrix A is given to you. In the system AX equal to B, where B is also given to you, then what is the solution of X? Very fundamental question of algebra, because 1 mark है, 1 mark से maths बहुत fundamental आता है. AX equal to B, what is the solution of X? If A is invertible, yes it is invertible. Because inverse is given to you directly. Yes, it is invertible. Okay, so what is the X? X is given by A inverse into B. And the good thing is A inverse is given to you. The good thing is A inverse is itself given to you. Clear? A inverse is itself given to you. Come on, everybody quickly solve and answer. Okay, so it's minus 5 and 1 and minus 2 and minus 9. Minus 2 and 1 and minus 1 and minus 5. 8 and the minus 2 and the 3 and the 15 and the 0, 0, 0 and minus 1 multiplied by the B, that is 100 minus 1. Okay, so when I multiply this, okay, ये तो बीच में 0 0 ही हो गया, तो it's minus 5 minus minus plus 9, so that's 4. Next is minus 2 plus 5, so that is 3. Okay, 4 3, correct. B answer आ गया वैसे, by the way. 8 minus 15 minus 7, last में minus 1 plus 1. Okay, so 4 3 minus 7 and plus 1 written in the form of row transpose. Answer is B. Answer is B. Right? Yes, Lavanya, Raghu, Krishna, Rohit, Raghu, Shiba. Correct answer. B is the very correct answer. B is the very correct answer. Moving ahead to the next one. MCQ 1 mark. Okay, functions of complex variable. Given that fz is equal to u plus iv be an analytic function, and if u is equal to 2x 1 minus y, then what should be the value for v? What should be the value for v? Once again, you also start solving. Put me on mute. Okay, solve करते जाएंगे, दोनों आंसर को मैच करेंगे. Now it's a question based on analytic function, complex functions में से analytic functions. Okay, and every analytic function will satisfy Cauchy-Riemann equations. What are the Cauchy-Riemann equations? Del u by del x is always equal to del v by del y, and del u by del y is given by the minus of del v by del x. Is given by the minus of del v by del x. Correct, sir? Okay. Right. So u has been given to you. That is the 2x into 1 minus y. Okay. Now del u by del x will be del v by del y. So that is equal to how much? Del u by del x. Now when you differentiate partially with x, y is constant. Y is constant. So I get twice of 1 minus y. X ka differentiation 1. Clear? Achha. So let's use this. Del v by del y is twice of 1 minus y. So what should be v? What should be v? Now integration with respect to इंटीग्रेशन विथ रिस्पेक्ट टू y, देखो ऐसा लिख लेते हैं इसको. सो आई हैव इवेंचुअली del v by del y is equal to 2 minus 2y. So what's going to be v? Integration of 2 will be 2y minus 2y का integral y square. Now normally, listen to me, normally you add constant of integration. Whenever you are solving the indefinite integration, you will use the constant of integration. Okay. But here, because it is the partial differentiation, in any partial differentiation with respect to y, x is also constant. Okay, so maybe not the constant c, maybe some function of x also can come up here. Yes, maybe some function of x also can come up here, because when you partially differentiate v with respect to the y, derivative of x, the x term will be differentiated to 0. Clear? That will become 0. Right? Okay. So that should be the form of v. Okay, but now there is the unknown quantity. How to find that unknown quantity? By the second CR equation. Okay, so now I have the second CR equation. Del u by del y should be the minus del v by del x. Right, u मुझे given है. Okay, 2x into 1 minus y. Differentiating with y, तो x is constant. 2x is constant. 1 minus y का differentiation minus 1 is equal to minus del v by del x. So differentiate this with respect to x. When you're differentiating with x, y is constant to 0, 0, and this will be f dash x. So here I get the f dash x. Clear? So f dash x minus minus cancel karte hue, f dash x is equal to 2x, and f of x will be equal to x square, plus here there can be some constant of integration. So what is the value of v then? What is the value of v? It is 2y minus y square plus fx, that is plus x square plus some constant. 2y minus y square plus x square plus c. Okay, options are slightly in the little rearranged form, but I should have x square and minus of y square. I should have x square and minus of y square. Right, ये तो गलत है, ये तो गलत है. X square and minus of y square. At the same time, I should have 2y. Okay, this will give you 2x. No. So correct answer is A. Matlab, you can open up whole thing, but not required. The correct answer is A. The correct answer is A. Yes, Krishna, it's A. Lavanya, please recheck. It's going to be A, not the D. All right. Next question on your screen. The PDF of a random variable is shown below. What should be the value of alpha? What should be the value of alpha? Right. Okay, chalo. The PDF of a random variable x is shown below. What should be the alpha? Now, because it is the PDF, and that to a graph. If it is function, we will integrate. It's a graph, we will calculate the area directly, because we know that area under PDF is equal to the unity. Okay, so let's use the area under this PDF, and the area under a trapezium is half into distance of the into sum of the parallel sides. So that is 4 plus 2 into the distance between parallel sides, that is alpha, and this is net equal to 1. So alpha is actually 2 divided by 6, or 1/3. Numerical answer type, again 0.3. Alpha is the 0.33. Very simple. Yes, Sobin Kumar, Lavanya, correct answer. That is the 0.33. Correct? That is known as the 0.33. Okay, sir. Okay, Raghu, correct. Chalo, next question, moving ahead. Okay, it's an MCQ 2 marker question. As I told you, 3 questions of 1 mark, they are done. Now 2 marker questions for maths. If y is equal to c1 e power 2x plus c2 e power x plus c3 e power minus x, satisfy the differential equation. Satisfy the differential equation dqy by dx plus a d2y by dx square plus b dy by dx plus cy equal to the 0. Then what should be the value of a cube plus b cube plus c cube divided by the abc? A cube plus b cube plus c cube is divided by the ABC. What should be the value corresponding to it? Tell me. What should be the value corresponding to it? A cube plus b cube plus c cube divided by ABC. Divided by ABC. Check karte hain? Okay. Now, if y, this is of what form? If y is of the form c1 e power m1x plus c2 e power m2x plus c3 e power m3x, where m1, m2, m3, m1, m2, m3 are the roots, real and distinct roots of the equation. Okay, roots of the equation. Okay, so what is the auxiliary equation that you will form from here? Okay, what is the auxiliary equation that you will form from here? It is d cube, that is n cube, then plus a m square plus bm plus c equal to 0. Okay, where the roots of the auxiliary equation should be m is equal to 1 है 2, then I have 1, then I have -1. These are the three roots. These are the three roots. Now, as per the cubic, this is one knowledge about differential equation. Then, as per a basic cubic equation analysis, okay, how to find the value of ABC? ये भी हम check कर लेते हैं. So, I have the m cube plus am square plus bm plus c equal to the 0. Correct. And the roots are 2, 1 and -1. Now, a is actually given by minus of the sum of the roots, right? Minus of the sum of the roots, 2 plus 1 plus -1. Okay, that is actually -2. A ka value -2. B is actually given by plus of pairwise product. Okay, plus the product of the doublet form. So 2 into 1 plus 2 into -1 plus 1 into -1. Okay, so B is equal to how much? 2 minus 2 cancel, -1. So B is -1. C is equal to again minus, alternate plus minus plus minus, and C is the triplet product. Matlab product of all the three roots, that is 2 into 1 into -1. So -2 minus is already ahead, that becomes +2. So we have got A, B, C. What is the value of A cube plus B cube plus C cube upon ABC? Is divided by ABC. Is divided by what? Is divided by ABC. Okay, chalo, let's see. Okay, so that is equal to how much? Just a moment. Correct. Right. So how much it is? That's -8. B cube will be -1. C cube is equal to 4 is divided by -2 into -1 into the 2. Okay. So this looks like -9 plus 4 -5 is divided by 4. -5 C cube, sorry, C cube is +8 actually. So this is left with -1 only. This is left with -1 divided by minus be plus, to divided by +4, so -0.25. Everybody, -0.25. Okay, -0.25. -0.25. It is the answer number D. It is the answer number D. That's the cubic equation funda, Shiba. See, what actually you need to apply here is, dekho, that is the cubic equation funda. Now, what is the rule here? What is the rule here? Whenever you have the cubic equation, right, just in the form of ax cube plus bx square plus cx plus d equal to 0, and suppose the roots of the cubic equation are alpha, beta and gamma, then you must always remember that alpha plus beta plus gamma is minus of b by a, right? Alpha beta plus alpha gamma plus beta gamma, pairwise product. Okay, that is given by C by A, and product of all three, alpha, beta, gamma, is given by minus of D by A again. Minus of D by A. That is what is the trend. Clear? So that is some cubic equation fundamentals. Now this was a MCQ 2-mark question based on the solution of differential equation based on the complementary function actually. Because it's a linear higher order, linear third order differential equation with constant coefficient. Next question, dear. This is 56. Next question. Before I go to next question, I have a crucial announcement for you that yes guys, okay, yes guys, the gate is around the corner, and here we bring you the last question practice session. Okay, yes, 111 top questions. 111 top questions of engineering, maths and general aptitude. Okay, of combined, the blaster session, maths and aptitude combined, non-stop 111 questions. Yes, non-stop 111 questions. Non-stop 111 questions. We bring to you live on the YouTube this Monday. Yes, this is on Monday on the same channel where you are watching this mock test. Monday 10 a.m. It's not PM. Monday 10 a.m. morning se start ho jayega ye, and we'll discuss 111 questions. We will be discussing the 111 questions of maths and general aptitude. Clear? Let's move ahead to the next question. Okay, so after transforming the integral to Cartesian form, the double integral, okay, can be expressed as, okay, now the given double integral form is in the polar coordinates, and you need to convert this into the regular Cartesian coordinates. We need to transform it into the Cartesian coordinate. Okay, this is again an MCQ 2 marker question. So let us discuss that, guys. So now, Cartesian mein, if I have xy, polar mein I have r and theta, what is the relation between them? R is given by square root of x square plus y square, and theta is given by tan inverse y by x. Vice versa, x is given by r cos theta, y is given by r sin theta, right? And what is dx dy? Dx dy is given by r dr d theta. R dr d theta. Correct, Ji? That is what it should be. That is what it has to be. Okay. Now, just need to manipulate the limits as well as the expression. Pehle expression ko manipulate kar lete hain, right? So what is this? This can be broken as r cube hai na? So I will use it, because this is r cube, so I will use it thrice actually. I will use it 3 times. One is clubbed with r cos theta. One of them is clubbed with sin theta, so r sin theta. And one of the r, you please take it as dr d theta. R dr d theta. The r dr d theta. That is known as the r dr d theta. R cos theta, r sin theta, r dr d theta. R cos theta, r sin theta, r dr d theta. R dr d theta. That is what it is. Clear? That is what it is. Okay, sir. Done hai. R dr d theta. Okay. So this expression is simplified. That's not a big deal. Now, what about the limits? The limit of theta is 0 to pi. The limit of r is from 0 to a. So when we want to understand this limits, na, let us understand this limits actually. Okay. R is 0 to a and theta is 0 to pi. Theta is 0 to pi. Let's take the value of r equal to a first of all. Let's fix any value of r, but the theta is from 0 to the pi. The theta is from the 0 to pi. Okay. Okay. This is the theta. Okay. And let's take not only r, let's take any value of r. Right. The length of this line, let's say the length of the line is equal to r, and the angle subtended by is theta. Now, what is given to you? Theta is from 0 to pi. That is why I take the semicircle. Right. And r is from 0 to a. Now, because r is from 0 to a, this is the a and this is the 0. This is the origin. That means the entire limits is describing this particular portion. Okay. Now to cover up this portion in the Cartesian, to cover up the same portion in the Cartesian coordinates, okay, normally what do we take in the Cartesian coordinates? We'll be defining a strip. This is a, this is minus a. We'll be defining a vertical strip. Okay. Let me take a vertical strip here, and in that vertical strip, y, lower limit is 0 and y. So what is the equation of this circle? It's a semicircle, part of a circle, but ultimately equation is x square plus y square equal to radius square. Radius here is a. So what is the upper limit of y? The upper limit of y, the upper limit of y is under root of the a square minus x square. Then what is the limit of x? Minus a to a. Limit of x is minus a to a. So integral is now going to become yes, Ashok, good. So integral is now going to become the I, which is integration 0 to pi, integration 0 to a, r cube sin theta cos theta dr d theta is now convertible to double integral देखो r cos theta, r sin theta will become 2y. So what is this? This is x, this is y, and r dr d theta is dx dy. Okay, so function inside the integration will be xy dx dy, right? Xy dx dy, or rather y is the limit of x. The limit of y depends on x, right? So I will write down dy dx, order of integration can be written as dy dx because I have taken the vertical strip. Okay, where the limit of y is 0 से under root of a square minus x square, and the limit of x goes from minus a to plus a. Minus a to the plus a. Minus a to the plus a. Okay, so limit of x is from minus a to the plus a. Option number B. Perfect. Option number B goes good. B and D I think same हो गया क्या? Are you able to feel any difference? कोई difference नहीं है. Some typo error definitely. Some typo error. Okay, इसमें कुछ typo error होगा. Okay, I'll change it up randomly. Let me call it as suppose a square minus y square. Okay, and then भी तो बन जाएगा. If I take the this limit, nah, then it has to be minus to plus and 0 to a. ठीक है. तो इसको हम ले लेते हैं. Y to minus. So let's call it as then B. Okay, so D I have changed because I think some typo error was same type हो गया है. I have changed it randomly. B is the correct answer. ठीक है. The very correct answer. चलो बढ़िया. Next question, guys. Moving ahead. Next question. Moving ahead. Two real numbers x and y are selected randomly. Okay. Given that 0 less than x less than 1, 0 less than y less than 1, what is the probability that y square is less than x? MCQ 2 question. Two real numbers x and y are selected randomly. Okay, given that 0 less than x less than 1, 0 less than y less than 1, what is the probability that y square is less than x? Now understand, it's a good question. It's a good question. Okay. X and y are uniform in the range 0 to 1. So x and y can take any values individually between 0 to 1 and 0 to 1. Okay, there is no problem with the x and y. Let me first talk about the sample space here. Let's say this is the sample space. Sorry, 0 to 1 and 0 to 1. Okay, let's consider this. Y square is less than equal to x. So guys, y square equal to x we all know is a parabola. So let me place that parabola also. Let me place that parabola also. The parabola y square equal to x. What are these points? This is 1, 0. X is anywhere. X is anywhere. ये है x axis. This is the y axis. X is anywhere from 0 to 1. Okay. And y is also anywhere between 0 to 1. So this point becomes 1, 1. Y square equal to x also passes through this point. So let me draw the parabola y square equal to the x. The parabola opening right. Parabola which will be opening towards the right. This is the parabola actually. This is my origin and this is my point 1, 1 here. Everybody. This portion, this is your omega. Omega matlab sample space. This is your sample space. Okay. Acha. What is the total area of the sample space? Forget. Y square equal to x is the parabola. But y square equal to x is the parabola. But I want y square to be less than x. I want lower values of y. I want the lower values of y. Matlab the portion below it. This portion. The portion below it. इसको थोड़ा सा यहाँ पे color कर देते हैं. This portion. This is the portion I want. Little bit more lighter. This is the portion I actually want. Clear? This is the portion I actually want. I will call this as my. I will call this as the favorable space. Favorable region. Now, what is the area of the favorable region? वो निकालना पड़ेगा. And what is the total area? Because whenever it's a two-dimensional distribution, it's a curve. Okay, what is the area of the sample space? Sample space is a rectangle of 1 cross 1. Sample space is a rectangle of 1 cross 1, so its area is equal to 1. Its area is equal to the 1. Clear? Sample space area is equal to the 1. Okay, what is the favorable region area? What is the favorable region area? What is the favorable region area? Okay, ये निकालना पड़ेगा. And for that again I'll be taking that vertical strip where lower limit y is 0, y square equal to x, so upper limit y is equal to root x. So what is this area? This area is integral y equal to 0 say root x, right? And then integral x is from 0 to 1 dy dx, because it's only area required, so integral dy dx we perform. Okay, so that is equal to dy ka integral y upper minus lower limit root x, so integral root x dx from x equal to 0 to 1. Root x ka integral will be x ki power 3 by 2 divided by 3 by 2, lower limit 0 upper limit 1, so ye ho gaya the 2 by 3 and 1 minus 0, so this is 2 by 3. Now what is the required probability there? The probability here, okay, whenever it is discrete set, you count favorable events upon total events. Here it is favorable area divided by total area of the sample space. Right. So favorable area 2 by 3, total is 1. So answer is 2 by 3 itself. That is the option. That is the option number C. Clear? Yes, Ashok, correct answer. It is the option number C. Good one. Good one here. Okay. Correct, Raghu. C, correct one. 2 by 3. It's a good question, decent question based on probability calculations. Moving ahead to the next. Given a vector field A is equal to 3x square I cap plus 6y j cap plus 3y square k cap, the integral of A from origin to the point 2, 2, 2 by the given root will be, okay, so what is the line integral? Integral A dot dl, that is integral ax dx, 3x square with dx plus 6yz with dy plus 3y square with dz, and this should be actually, अब आप इसको देखोगे ना, this is 3x square with dx only, this is x with dx. 3x square किसका differentiation होता है? Can we think? 3x square is the differentiation of x cube. X cube will get 3x square dx. Okay. Then look into this. 6y with dy, z constant है यहाँ पे, so 6y is the differentiation of 3y square which is sitting fixed here, but here z is differentiated which was sitting constant here. So in the second two terms, okay, in the last two terms we have a product rule, okay, where the product of 3y square and z is being differentiated, isn't it? Now see, 3y square constant, differentiation of z is dz. Z constant, differentiation of 3y square is 6y dy. Clear? Now differentiation is a linear operator, so integral and differential cancel, and I have x cube plus 3y square z. Integral and differential will cancel each other, and your answer is simply x cube plus 3y square z. So because I have solved the integration, I only need to put the limit from origin to the point 2, 2. From origin to the point 2, 2, 2. Okay. Yes, Shiba, very good. Okay. So just let's solve this calculation. 2, 2, 2. Upper limit ho gaya 8 plus 3 into 2 square 4 into 2. Lower limit is just 0, so not required. 424 plus 8, 32 units. A is the answer. 32 units. A is the answer. 32 units. Now you guys, exact differential equation was applied. Why? Okay, this equation, this came up to be path independent. The answer Answer only depend on the initial and final points. Where is the intermediate point? 200, 220. Where are the intermediate points? Not required. Why it is path independent? Why it is path independent? Why it is path independent? Because the reason that you all know, because the curl of f must be 0. Can you try? Can you try curl? That I leave it to you. But you can try curl. 110% curl will be 0. Then only the exact differential equations approach will come. Then only the exact differential approach will come. Clear, everybody? Then only the exact differentiation approach will come. Okay. So if you handle it this way, then it's a easy question for 2 marks. If you solve it throughout the route, then it's a lengthy question for 2 marks. Okay. Yes. We have discussed this in the, I think in the marathon session, we discussed this. Maths marathon, which was taken on the app. The directional derivative of f, which is equal to 4 e power 2x minus y plus z at the point 1, 1, minus 1 in the direction towards the point minus 3, 5, 6. Directional derivative पे question है. Okay. What is the directional derivative of this function? Here. What is the directional derivative of this function of any scalar function? Right. Directional derivative of any scalar function at the point P in the direction of some given vector. In the direction of some vector. Let's say that vector is A. That is given by gradient of the function at the point P dot product with A hat. A hat is the unit vector. A hat is the unit vector. Right. So यहाँ पे let us calculate. Okay. So let us do these basic calculations. The function f is 4 e raised to the power 2x minus y plus z. Let me first calculate the gradient of the function, which is given by the formula I del f by del x plus j del f by del y plus k del f by del z. Now dear, when you differentiate n with n, first of all, when you differentiate exponential function, the answer will be exponential. Okay, the answer will be exponential. Okay, so I can clearly say that 4 e raised to the power 2x minus y plus z. This is going to come in all the derivatives. Take it outside. Then 4 e power 2x minus y plus z differentiated with x will give same exponential. But by the chain rule, when you differentiate this power, y and z will be 0. 2x ka derivative will be 2. Okay, 2x ka derivative will be 2. So 2 will be left. Similarly, when you partially differentiate with y and finally apply chain rule, it is going to be minus y ka differentiation, which is minus 1. So minus j cap, and with respect to z, it is going to be plus 1. Ask me if you have the differentiation part. Okay. Now, we need this at the point, 1, 1, minus 1. At the point P, which is 1, 1, minus 1. The gradient at the point P, at the point where the directional derivative is required. Okay, so at the point, this becomes 4 e raised to the power 2 minus 1 minus 1. So e की power 0 हुआ into the vector 2i minus j plus k. E power 0 is just 1. Okay, so you have 4 2i minus j plus k. That is the gradient. Okay, now the direction of the vector A. Okay, so at this point and in the direction towards minus 3, 5 and 6. So you have the point 1, 1, minus 1 and you need to go towards some point which is minus 3 and 5 and 6. Towards this point, minus 3, the 5 and the plus 6. So this vector, let us say this is the vector A. Achha. Let us say this is some point P where the derivative was required. This is the point Q towards which I need to calculate the derivative. So vector A here is the vector PQ, and we all know vector PQ is the position vector of Q minus position vector of P, second minus first. So minus 3 minus 1, that is going to be minus 4 I cap, 5 minus 1 to plus 4 j cap, and 6 minus minus 1 to that is going to be 7 k cap. That is the vector A. That is the vector A. Now the vector A hat is required, sir. What is the vector A hat? Vector A divided by its modulus, right? So that is minus 4 I cap plus 4 j cap plus 7 k cap divided by the square root of 4 square plus 4 square plus 7 square, right? So this one is how much? 32. So this is actually 81. Under root of 81 is 9. Okay, so minus 4i plus 4j plus 7k divided by under root of 81, which is 9. So now what is the directional derivative? That is the gradient dot product with a hat. Gradient is written over there for 2i minus j plus k dot product with the a hat, that is minus 4i plus 4j plus 7k dot product divided by 9. So 4 by 9, now take the dot product, 2 into minus 4 minus 8 minus 1 into 4 plus 1 into 7, that is 7. Okay, so this is minus 12 and plus 7 minus 5, so 4 into the minus 5 by 9. The answer has to be minus 20 by 9. So this should be, I think, minus 2.22. Check out once. Yeah, any issue with the voice? I think minus 2.22. Check out once. Yeah, any issue with the voice? Small कुछ problem आया था. Okay, let's check it up again. Let's try to test it and check it again. Correct. Minus 2.22 is the answer. Okay, minus 2.22 is the correct answer. The NAT type question it was. Okay. All right, dear. So this was the 13 marks of the mathematics. Okay, now we will go to aptitude questions. But before that, a reminder that from 24th Jan, already the last open mega mock test for GATE 23 on the BYJU'S Exam Prep, which is free for all GATE aspirants, has been started, and it is live till 2 more days, 30th of January, right? Appear in this, register on the app, and see your performance amongst thousands of students appearing in the examination. Also, guys, just yesterday, we started with the GATE Super 11. Yes, top 11 questions of every subjects are being discussed. Yesterday I discussed for digital. Today also you have the sessions, okay, for Super 11. I think one of the session is EDC, and maybe one session, I think machines, it is there. Yes, by Ashutosh Sir only. So guys, attend all of this. This will give you the 11 best expected questions of every subject. Okay, all faculties discussing one by one, subject by subject. And also guys, just after the GATE examination, that is the first weekend of GATE examination is on 4th and 5th February. 4th computer science hai, right? 5th you have EC and EE. Right, so we are coming live at the 1 p.m. and the 6 p.m. Yes, for the forenoon sessions, we'll come live at 1 p.m. For the afternoon sessions, we'll come live at 6 p.m. to discuss the complete questions, their answer key, their solutions, the difficulty level, the expected cutoff, future opportunities, all those things, guys. Okay, now let's move ahead towards the general aptitude here. Now, a portion of general aptitude is done. Verbal ability already discussed by Ashutosh Sir. Okay, we are discussing only the quantitative and reasoning part. So 5 questions of verbal already discussed, that had the weightage of, I think, 6 marks. Okay, yeah, I think verbal part was done. Yes, as far as I am able to recall, verbal part is done, and that has the weightage of 1 into 4 plus 1 question of 2 markers. So total 6 marks is done. Okay, so here I bring you 9 marks exclusively from the quant and LR part. Okay, from the quant plus logical reasoning part plus spatial aptitude part, and I will have 1 question of 1 mark only, right? But 4 questions of 2 marks. This will become 9 marks. This is what is there. Okay, correct. This is what is there. So the first question, only 1 question of 1 mark, and that is question based on clock. An accurate clock shows 8 o'clock in the morning. Through how many degrees will the R and rotate when the clock shows 2 o'clock? So what is the rotation speed of the R and? What do you know about the speed of the R and? How much degrees does it move? How much degree does it move? It has the speed of 30 degree per minute. I have taught you all these things. 30 degree per minute. So R and speed is the 30 degree per minute. Clear? The R and speed is the 30 degree per minute. 30 degree per minute. Clear? 30 degree per minute, right? Now 8 o'clock to 2 o'clock, right? 8 a.m. in the morning to 2 p.m. in the afternoon. This is total how many hours? This is total 6 hours, right? So 6 into 30 degree per hour. So 180 degree will be the total rotation. 180 degree will be the total rotation. It's D. It's a D. Fundamental question which you must know about clocks, the speeds of the hour hand, the speeds of the minute hand, and etc. Minute hand will have the speed of 360 degree per minute per hour. Okay, per minute लिख दिया. I'm sorry. Per hour. Per minute. Per minute तो half degree होता है. Right, this is per hour and that is also known as then half degree per minute. Half degree per minute. Okay, minute hand के बारे में ऐड कर दूं मैं. The minute mh, minute hand speed, that is known as 360 degree per hour. Every hour minute hand will come back to its own position, or that is known as 6 degree per minute. 6 degree per minute. Okay, chalo बढ़िया है. Next question 62. Okay, it's a simple question for 2 marks, but then we have one or two good questions as well. Simple one for 2 marks. What is the largest 4-digit number exactly divisible by 78? लैंग्वेज में लोग की थोड़ा आपको कुछ मेहनत करना पड़ेगा, बट एक्चुअली इट्स नॉट a question with lot of effort. It's very simple. Largest 4-digit number exactly divisible by 78. Largest 4-digit number exactly divisible by 78. Acha, what is the largest 4-digit number, all whether it is divisible by 78 or not? Okay. Yes, Muthu Kumar, very good. So the largest 4-digit number is 9999. 9999. Largest possible 4-digit number. Okay. When you divide that by 78, na, how much? We have the calculator in hand. But only thing is why I have taken this question. ये आपको लैंग्वेज क्लियर होना चाहिए. दिस इज 128.19. 128.19 मतलब the question part is 128. Question part is no, this is not permutation. That is why, you know, that is the intent. I know looking into this question, people will think about maybe some remainder concepts or maybe some counting, permutation, combination. No, it's a fundamental logical question. So exactly 128 is divided by the 78. You know what is going to be the result? That is going to be 9984. That is the highest. That is the highest 4-digit number. Because if you take 129, if you increase this will be more than 9999 and that will go beyond the 4-digit range. Okay, so the answer is equal to how much? 9984. That's the answer. Got this? Now I'm telling you, the solution is very simple, but still the language confuses some of the students. That is why I have taken this. But it's a very simple question according to me. Clear? 9984 is the last answer, dear. 9984 is the last answer. Next one, 63. Okay, arrangement question, normally expected. 6 friends, O, P, Q, R, S and T are sitting around a triangular table facing inside the center. 3 of them are sitting at the middle of the side and other 3 are sitting at the corner of the table. P sits at one of the corner and is third to the left of O, who is 4 to the right of Q. Only one person sits between P and R. S is second to the right of R, who sits second to the left of. A very expected arrangement, seating arrangement question. It's a triangular seating arrangement. It's a triangular arrangement to be taken here. So I'll take a triangle. But eventually triangle, when you make the person sit on a triangle, it becomes a closed loop. It's not a row. It's not a linear row. It becomes a closed. It becomes a closed arrangement. And in the closed arrangement, whether it is circular or square arrangement or triangular arrangement, the best thing is for any closed loop, there is no beginning, there is no end. So you can define your own beginning. जैसे P sits at one of the corner, that is the beginning point. P sits at any one of the corner. To take any one of the corners, all are equivalent. Okay, P sits at any one of the corner. Okay, sir, ये P है. So there are 3 corners, and then 3 of the persons will sit at the mid points. Yes, guys, keep doing it. Put me on mute. Keep doing it. Last में match your answers with me. Let's solve it in parallel. But आप सुनना मत, आप mute कर दो. P sits at one of the corner and is third to the left of O. And is third to the left of O. P is third to the left of a person O. So देखो 1, 2, 3 ये रहा O. Now O, all are facing the center. All are facing the center. Right. So O is facing in this direction. So left side is this one. ये इसका left side हुआ. So 1, 2, 3. Third to the left of O. So I've got O seated now. Okay. So I've got O also rectified for you. Clear? Next. And is third to the left of O. O who is fourth to the right of Q, तो यहां से Q भी आ जाएगा. O who is fourth to the right of Q, right? O is fourth to the right of Q. Okay, तो पहले उल्टा चलेंगे, तो 1 2 3 4, fourth to the right of Q. Okay, तो O sorry, O के लेफ्ट में चलते हैं. 1 2 3 and 4. देखो 1 2 3 and 4. This should be Q. Okay, now fourth to the right of Q, you can match. First right, second right, third right and fourth right. Yes, O is fourth to the right of Q. So Q भी आ गया dear. Q also sorted. Next, only one person sits between P and R. Only one person sits between P and R. So where is R? R can be here or can be here. There are two possibilities right now. Okay, R is one place, leaving one place away from P. Okay, so there are two options of R. So देखते हैं. There is only one person between P and R, and S is second to the right of R. यहां से R पता चलेगा. S is second to the right of R. Suppose this is the R, dear. Suppose this is the R. Okay. E is facing center. Second to, this will be the right hand. Second to the right of R should be S. S is second to the right of R. Already P is seated here. So that is not the correct possibility for R. Clear? That is not the correct possibility for R. So R is here, not there. Okay, R is here, not there. And S is second to the right of R. So this is R, first right, second right. यहाँ पे S आ जाएगा. Okay, sir, so this is S. Only person left is T that I have placed here. And now look into the question. Who sits second to the left of T? This is T. Okay, he is facing center. So P and Q इस तरफ left जाएंगे. Q is sitting to the left of T. Answer has to be D. Q is sitting second to the left of T. Second left. It is the D option. It is the D option. Everybody clear? It is the D option. It is the D option. Yes, Krishna, correct. Krishna, very correct answer. Very good. That is the option number D. Clear? That is the option number D. Okay, sir. Next question for 2 marks. Geometry and mensurations. ABCDEF is a regular hexagon of side 2 feet. What is the area in square feet of the rectangle BCEF? ABCDEF is the regular hexagon. पहले उसको बना लेंगे. A regular hexagon of side 2 feet. Let's take it like this. A, B, C, D, E, F. The regular hexagon of side 2 feet. What is the area of the rectangle BCEF? Okay, this is what I am looking for. BCEF. Okay. So, what is the area? The area of the rectangle is base into height. So, देखो, one of the dimension is BC multiplied by if I get the CE. If I get the CE. Okay. BC तो मुझे पता है. The side is 2 feet and all sides are equal. All sides are equal. All sides are equal. Right. I want the value of CE. How to get the CE, dear? How to get the CE? इसको अलग कर देते हैं. Please pay attention. Let us separate the CDE. Let us separate the CDE. Okay. CD and DE are the sides, so they are both 2. And what is the angle within a regular hexagon? What is the angle within a regular hexagon? It is 120 degree. All angles are 120 degree. So this is 120 degree. Now this is the isosceles triangle. Okay. These two sides are equal. So angles opposite them is also equal. So 120, 180 minus 120, 60. 60 को equally divide करना है. So 60 by 2 is 30. So these two are 30 degree each. Now I'll simply apply the sine rule. I can simply apply what? Sine rule. I want CE na. So CE is divided by opposite angle sine 120 degree should be equal to, take anything CD, take any of the side CD divided by the sine 30. Opposite angle is 30 degree. Okay, sir. Right. So what should be the value of CE? CD kitna hai? CD is the side. That is 2. Upon sine 30 degree. Sine 30 is half. Into sine 120 degree. यहाँ पहले sin 120 को यहीं लिख लेते हैं. What is the sin 120 degree? That is sin 60 degree and root 3 by 2. Okay, so 2 and 2 got cancelled. These two got cancelled. Root 3 shifted on the right. CE का value आ जाएगा 2 root 3. So BC is 2, CE is 2 root 3. My net answer is 4 root 3, it is D. Yes, dear. The correct answer is D. A good question, decent question on geometry and mensuration, I can say. Yes, Shiba. Correct. Chalo, done. So that is the 4 root 3. All right. Next and the last question here. In a flight of 600 kilometer, an aircraft was slowed down due to bad weather. Okay. Its average speed for the trip was reduced by 200 km per hour and the time of the flight increased by 30 minutes. What is the duration of the flight? Duration in hours. What is the duration of the flight? This is a flight of 600 km. The distance is given to you. We can simply use the relation here that distance is given by speed is multiplied by time. But there will be the two relations coming up here. First, the distance, which is 600, is the speed s into time t. But on one particular day, due to bad weather, let's say s and t are the original speed and original time. Okay. On one particular day, the average speed was reduced by 200 kilometer. So distance will now be speed minus s minus 200. And because the speed reduced, the time increased by 30 minutes. So t plus half hour. Let us say we are writing in hours. 30 minutes is half hour. 30 minutes is half hour. Correct? What is the duration of the flight? Duration se mera matlab hai, let me specify here, actual duration of the flight. Actual duration of the flight. Correct? Chalo. Yes, guys, do not forget to subscribe the channel because I've told you many more activities are coming up your way. Okay, so we just have to solve these cases. Solve करेंगे इसको. So this is 600. Okay, that is 600. That is equal to s into t. Okay, minus s by 2 minus 200t minus 200 into half. That is minus 100. But st is eventually 600, so that will get cancelled. Okay, that will get cancelled. So eventually you have s by 2 is equal to 100 minus. No, sorry. What is the s by 2? ये हुआ minus s by 2 and this one is plus 100. Okay, so s by 2 should be equal to 100 minus 200t. Okay, so यहाँ पे substitute करें. 600 is equal to s into t. S is equal to 200 minus 400t is multiplied by t. 200 cancel कर दें तो 3 is equal to 1 minus of 2t. एक सेकेंड. 1 minus of 2t into the t. No, I'm not satisfied. कुछ issue हो रहा है. This is plus s by 2 only. Only one place minus is coming. Right. S by 2 is 200t. ये reverse होगा. Otherwise calculations will fail. 200t minus 100. Okay. So what is the value of s? Actually s ही लिख लेते हैं. So what is the value of the s from here? Then it becomes the 400t minus 200. Let us substitute here. 400t minus 200 whole multiplied by the t. 200 से cancel किया तो 3 is equal to 2t minus 1 into t. Now you can solve the quadratic equation. Or else you can just match the answer. Right. The only option that is going to match is t equal to 1. Right. 2 minus 1 into 1. नहीं 1 नहीं होगा. So no, it's not going to be 1. 2 into 2. 4 minus 1 3 2s are 6. वो भी नहीं होगा. Then some error with the options maybe, I think then. Some error with the options. कहीं बाकी rest is okay. Plus s by 2 minus 200t. भाई sorry, ये plus minus कहीं और कुछ करना था. हो कुछ किया. Okay, I wanted to change there and there also it got changed. This is minus 100 only. So this is 400t plus 200. Now it is correct. 400t plus 200 into t. So it is 2t plus 1 into t. Yes, now t equal to 1 will satisfy. t equal to 1 will satisfy. 2 plus 1, 3. 3 into 1 is 3. You can solve the quadratic equation also. Correct. The correct answer is 1 hour only. The correct answer is 1 hour. Correct? Yes. Okay. So sign I had to change there by mistake. I changed there and forgot to change there. Okay, now it is normalized. Correct. It's 1 hour. No, 3 kaise? It's 1 hour. 2 plus 1, t equal to 1 is satisfying this equation. Or you can make the quadratic equation also, not a big deal. Hai na? 2t square plus t minus 3 equal to 0. Your call. Hai na? You can take that also. Okay. Chalo. So see, geometry and mensuration, as I told you during the marathon times also, I will plan, but I was actually very busy in the past days, and I'm looking forward that if I can plan in this coming Tuesday. Okay, so just stay updated. By tomorrow it will confirm, or maybe by today evening also. Maybe geometry mensuration, I can plan a practice session on geometry mensuration on this Tuesday. Let's see. Let's wait for that and let's see if it can be planned. Chalo. Chalo, done hai na? So guys, this is the 65th question and the end of the mock test. Hope you have performed well in the mock test, and let me keep you updated that this coming Monday now at 10 a.m. morning hours. Okay, we four, that is me, Ankit Joshi sir, Ashutosh Saxena sir and DV Sridhar sir, we are going to come live together and discuss 111 top questions of entire non-tech. Yes, last complete non-tech lab. Okay, before the GATE examination, where all questions of maths plus aptitude, including verbal. Ashutosh sir is there, matlab verbal bhi hoga. So all, just stay tuned. Engineering maths plus general aptitude will be discussed, including the verbal. Okay. EC, just 2 days back only we had conducted the mock test. Okay, just the 2 days back. Okay, guys. All right. So today you have had a very lengthy mock test, but the point is whether you have learned, whether you have analyzed your mistakes, whether you have calculated your marks, if it is not on the track, why it is not on the tracks, and more importantly, whatever concepts were taken either by me or Ashu Jhangra sir or Ashutosh sir or Sanjay sir, you have grasped something new today. Okay, grasp something new today. All right, guys. So now, without taking any more time, because it's already evening, I'll say goodbye to you. Okay, all the very best. Keep preparing very hard for the examination.